Buenos días. Can you hear me properly? ¿Podéis oírme bien? Buenos días a todas y a todos. Es un placer para mí, en nombre del rector de la Universidad Politécnica de Valencia y como vicerrectora de investigación, daros la bienvenida a la cuarta edición de los Días 5G, un evento de gran relevancia, como vosotros bien sabéis, que reúne a expertos, investigadores y profesionales del sector para abordar uno de los principales desafíos en el ámbito de las telecomunicaciones, el futuro de las Next Generation Networks, redes de próxima generación y en particular el camino hacia la 6G. Como vosotros mejor que nadie sabéis, el 6G no solo traerá avances tecnológicos, sino también oportunidades de transformación social y económica con un impacto global. Como la mejor universidad tecnológica de España, en la Universidad Politécnica de Valencia, UPV, trabajamos cada día con un profundo compromiso hacia la formación de nuestros más de 30.000 estudiantes de grado y máster, ofreciendo una oferta educativa moderna, flexible y adaptada a las necesidades sociales. Además, apoyamos a nuestros casi 3.000 investigadores en formación en nuestra escuela de doctorado y a nuestros más de 4.000 profesores, investigadores y personal de apoyo en su empeño por llevar la investigación puntera y la innovación a su máximo potencial. Somos una referencia internacional en diversos ámbitos, pero sin duda nuestro compromiso con el sector estratégico de las telecomunicaciones y la conectividad inteligente es uno de los más relevantes. Antes de dar inicio a las jornadas, quiero aprovechar esta ocasión para expresar mi agradecimiento especial a Narcís Cardona, quien ha sido director en los últimos años de nuestro Instituto Universitario de Investigación en Telecomunicaciones y Aplicaciones Multimedia. Nosotros lo llamamos ITEAM o ITIM, uno de los institutos más relevantes de la UPV. Mi agradecimiento también se extiende a todo su equipo, compuesto por más de 150 personas, por su liderazgo y trabajo incansable en hacer realidad esta iniciativa. Gracias, Narcís y ITEAM, por colocar a la UPV en la vanguardia de la investigación y la innovación tecnológica internacional, liderando los avances que definirán el futuro de las telecomunicaciones. Narcís, tu turno.
Gracias, Belén, por tu presencia, por tu asistencia, por tus palabras. Yo tenía previsto no usar el atril porque tampoco voy a usar demasiados papeles. Agradezco mucho la presencia de todos vosotros en el evento. Sé que hay gente que está todavía por llegar. Y especialmente quería agradecer, I'm sorry, I'm talking in Spanish, but maybe I should switch to English at some point in time. So I would like to thank very much our supporters, and Huawei is our supporter since some time ago. We are working a lot with them in very fruitful cooperation. So the workshop today on AI for 6G is because we have this cooperation with Huawei, and we wanted to show you how much is ongoing towards 6G based on this AI, Artificial Intelligence Technology. También quería agradecer al equipo de organización, por supuesto, a Eva, Alicia, a Fran, a todos los demás, a los voluntarios del grupo que estáis colaborando aquí. Y sobre todo espero que paséis unas jornadas muy agradables en un entorno y con un clima como el que nos regala habitualmente Valencia. Y digo habitualmente porque ya sabéis lo que está pasando estas últimas semanas. Y yo os contaré, porque voy a subir más veces al escenario, os iré contando dónde estamos, por qué estamos aquí, qué va a pasar a lo largo del día. Y espero que disfrutéis mucho de las jornadas, de las sesiones técnicas y que os llevéis a casa pues no solamente una buena impresión del lugar, sino algún conocimiento extra, que salgamos de aquí, dejadme decirlo así, aprendidos. Yo aprendo mucho cada vez que organizamos una cosa de estas y sobre todo también cuando estoy en clase. Y quería agradecer también la presencia y el apoyo de la Generalitat Valenciana. Generalitat Valenciana ha estado con nosotros en V5G Days desde el primer día, apoyándonos en el lanzamiento, en aquella primera edición, todavía con las mascarillas en pandemia, Recuerdo muy bien el distribuir la sala en aquel caso en una de cada 3 sillas de las que vemos ahora, y nos ha ido muy bien. Así que gracias Generalitat, y para abrir el evento, qué mejor que don Rafael Escamilla, director general de Ciencia de la Generalitat Valenciana. Por favor, Rafael. Gracias. Rafael. No. Corrígeme, por favor.
No.
No. Okay. So thank you very much for the introduction. First of all, it's my delightment and my pleasure to be here. I'm very honored to be here in these days. I would like to welcome, first of all, everyone, our guest speakers. I know that some people it's connecting remotely online through streaming platforms, apart from the people that we have here in the audience. So for us, I'm as a General Director for Science and Research from Valencian Community. I'm very proud to have this kind of events here, held by UPV in this iconic building in Marina Valencia. So this is the type of events that we are really proud of having here, because one of the main things, the more important things that we are trying to promote these days, and we are very committed in Generalitat Valenciana, is the connection between universities and companies, which we think that is fundamental. From our point of view, having research of maximum level in all the universities in Valencian community that do not transfer to the real life, to the society, doesn't impact in our economy and in our society, it's something that we want to really avoid. And that's why we are, in collaboration with universities, starting new programs that has as a goal to extend this collaboration, to make sure that everything that it's developed in universities reaches the different companies through different programs. For instance, we have these new doctoral industrial programs in which PhD students have to collaborate with the industry. We have other projects where universities have to collaborate also with a company in order to develop this type of research, and also improving the creation of spin-offs, startups, and other activities. So we are really committed, and in that particular areas, Universitat Politècnica is one of the leaders of the sector, collaborating with companies at global level. And of course, we want to take advantage of that to showcase what can be done in this area and in other areas where I think that everything that is done in university can reach our economy and also the society directly. So I would like to thank everyone that is here and, as I said before, connected remotely. Especially also the panelists, speakers, sponsors, and everyone that makes these days possible. I hope that we have these events like this in the future. Probably in the coming years will be V6G, because I see that technology is going very fast, and I thought 5G was something that was cutting edge, but it seems that technology goes faster than we can imagine. And Generalitat Valenciana is going to support, and it's really committed to this kind of events, and as well helping industry from all the possibilities that we have and university to make this kind of things real. So thank you, everyone. I hope that you enjoy. I think that you can network, discuss, and get fruitful conversations together that make possible everything that has as a goal this conference. So thank you, everyone, and have a nice day. Now, I think Teresa Riesgo, which is actually going to connect online, it's going to present from the Ministry of Science and Innovation his presentation. Thank you.
Good morning, everybody. My name is Teresa Riesgo. I am the Secretary General for Innovation in the Ministry of Science, Innovation and Universities of the Spanish government. I welcome you, everybody, to this event that happens every year in Valencia, and every year we can see the future, I say the present and the future of the 5G and future 6G networks. This is a very challenging moment where we are facing everything related with technological autonomy in our region, I mean in Europe, but also in the world. We are in a moment where networks and communications are becoming a key issue for security, for autonomy, but also for our economy and our daily life. For this reason, it is very important that Spain, Valencia, and UPV stays in the head front of the technology of these elements. And technology does not only relate with radio connections or with protocols with these type of things, but also with application, uses, and all the things that you will see in these 2 days in Valencia that are very nice to be happen here, because the organizers of this workshop, and particularly I want to thank you, Narcís Cardona, Professor Narcís Cardona, for the organization of this. As I say, it is very important that every year we can see the advances in technology, which are the challenges that we are facing, because things that were very promising 2 years ago, maybe they are now a reality, and maybe they are now something that we have stepped forward and we are going in another way. This is the idea of science, of research, and of innovation, that sometimes good ideas are not the final ideas, but are the ideas that we have to face with new challenges and with new applications that we are facing. I think these 2 days will be very helpful for you in case you are a researcher, in case you are an innovator, an entrepreneur, or in case you are a big company that want to learn more about the technology. I know and I see that in the program you will have the opportunity to listen to many of the good brains that we have in place here, but also people from abroad coming to share their knowledge and their innovation ideas about this 5G and the upcoming 6G networks. 2 weeks ago, we had the opportunity to attend the Mobile World Conference in Barcelona, and we saw a lot of new coming technologies, but also the uses of staying technologies, of the technologies that are already in place. I hope that you enjoy these days in Valencia, and again, I'm very sorry to not being with you these days, but I hope that you will have all the opportunity to learn and to network. Thank you very much.
Bueno, muchas gracias, Narcís, y todo el equipo ITEAM y todos los investigadores y profesionales presentes. Necesitamos talento y lo tenemos, pero también necesitamos el apoyo de nuestras instituciones. Por eso quería dar las gracias a Rafael y a Teresa en diferido. También quería dar las gracias, aunque Narcís ya lo ha hecho, a los sponsors del evento, instituciones públicas y empresas del sector. Estamos especialmente agradecidos por la confianza en el talento y el conocimiento que generamos en las universidades y en concreto en la UPV, y evidentemente invitamos a todas las empresas a que nos conozcan mejor y a que colaboren con las universidades en este ámbito y en otros que puedan requerir. Juntos podemos impulsar la transformación tecnológica y social que todos necesitamos. Bueno, durante estos días vais a tener hoy y mañana, en este entorno privilegiado, como han comentado, la oportunidad de profundizar en 3 retos clave, interactuando con expertos de todo el mundo. Vais a explorar las innovaciones que traerá el 6G, cómo la IA transformará las redes de comunicaciones, el papel de la fotónica en el desarrollo de sistemas de comunicación más eficientes y un reto muy importante que es cómo abordar el desafío de la sostenibilidad de estos sistemas, porque la sostenibilidad de estos sistemas de comunicaciones es esencial para que puedan aplicarse de forma generalizada. También analizaréis cómo estos sistemas de telecomunicaciones avanzados transformarán nuestros entornos urbanos, llevándonos a ciudades más inteligentes que seguro mejorarán nuestra vida, pero que deben ser también humanas y resilientes. Y que es fundamental que todos estos avances los hagamos conjuntamente, con la implicación de todos los actores, los gobiernos, las instituciones públicas, las empresas y los ciudadanos. Además, no quiero dejar de destacar que en este mundo cada vez más interconectado y vulnerable nos deis soluciones para mantener comunicaciones estables, eficientes y globales en escenarios de cambios y emergencia como el que tristemente nos ha tocado vivir recientemente. Ya concluyo animándoos a disfrutar del Congreso, de las conferencias de vanguardia, de los paneles de discusión, aprovechar esta plataforma única para generar nuevas ideas y aportarnos soluciones innovadoras. Estoy convencida de que saldréis de aquí con nuevas perspectivas y nuevos proyectos que nos acercarán a las soluciones que necesitamos todos para el futuro. Os deseo unas jornadas muy productivas, enriquecedoras e inspiradoras y bienvenidos al Valencia 5G Days 2025. Muchísimas gracias.
Gracias a todos. Pues vamos a empezar con la parte técnica del evento, que para eso habíamos venido. Como veis, hemos preparado un escenario para que nos sintamos como en casa. Y bueno, si alguien se siente como en casa aquí, yo creo que es David López Pérez, puesto que es de la casa. David es investigador distinguido de la Universidad Politécnica de Valencia. Y tiene una larga trayectoria como investigador en compañías, en empresas. Él viene del mundo empresarial y se une al mundo universitario hace un par de años. Ha estado en Nokia durante bastante tiempo, en Huawei también durante bastante tiempo. Y bueno, tiene un currículum digno de leer, porque él sustenta unas 60 patentes y un montón de publicaciones de alto impacto. De manera que, bueno, yo creo que no hace falta resumir, no puedo resumir tu currículum en un minuto, David, pero sí puedo decir una cosa añadida a lo que no tengo aquí en la biografía, es que además es una bellísima persona. Así que gracias, David. El escenario es para ti o lo que quieras. Thank you.
Okay. Thank you very much. Thank you, Narcis, for the invitation to these 5G days. Indeed, I was reflecting that these are 5G days, and I think you are right from the commercial and operation perspective of the network. But from an innovation point of view and research, I think the 5G days are long gone. So this year, 2025, is a key milestone for the 6G. The 3GPP will start the 6G standardization later this year. And this is very important because it means that every key player in industry has already a vision on how they are going to monetize 6G. A good vision is necessary because it's key to put together a plan to develop the right products to attack the market, to conquer the market, right? And the key question is where the money is going to come from. Where are we going to get the 6G money, right? And here the answer is quite diverged. So different people think that the money will come from different places. Some people is thinking that it will come from the virtual realities. Others will think that it will come through AI, sensing, global connectivity, you name it. There is a bunch of them, right? And to put clarity to this understanding, I really appreciate the effort of the colleagues of the O-RAN Alliance, that they have gone and created the families of use cases that people is talking about, right? And here's the summary. So the families of use cases where the money may come from are enhancing mobile broadband, plus URLC, plus machine type of communication, plus AI and sensing. So the money apparently will be in those families. But I don't know you guys, but when I see this, I feel like, oh, I've seen this before. I have a déjà vu. And then I go back to the literature, and I find this. For those that are unfamiliar, this is the triangle of truth of 5G, some people used to call it. That basically says that the 5G business is going to be built in 3 families of businesses. And look at that. Again, enhancing mobile broadband, URLC, and machine type of communication. And when I see this, I still become very worried. Why? Because we are planning to build the 6G business in some services that has not succeeded in 5G. Whether we like it or not, at least is my viewpoint, 5G, as of today, didn't sell as expected. And if you read the news, I read them every day, you can find news like this. Ericsson lays off 1,200 people in headquarters in Sweden. Not a good sign. Nokia sees how the business in Q2 goes down. So not a good sign. We are not selling as expected. So if you guys are planning to build your 6G business and get the money, so for me, all the bets are in AI and sensing. So for me, that could be the first takeaway that I would like you to take from here. But this is my viewpoint. I think it's also another important thing. I think is let's not overdo it. So let us look at 5G. The 5G specification, release 15, 16, 17, and 18, they have a bunch of features that is enormous. So the amount of capabilities that has been designed in the specification is way too large. But the reality is that in a true commercial product, only very few of them are implemented. Right? We have a very capable specification, but at the end of the day, vendors go and just implement just few features because the hardware cannot take more. Complexity increase the money of the product, the cost of the product. From my viewpoint, there are 3 key pillars in 5G technology. There is the C-band massive MIMO that provides more capacity, the capacity needed for these new applications we have today. There is FDN, MBF, and network slicing that basically has allowed the digitalization and virtualization of the network, and therefore providing quality of service in a more controlled manner. And then we have URLC, ultra-reliable low-latency communication. That is that sexy feature that is cool enough, that has allowed 5G to enter a new marketplace, the Industry 4.0, right? It's the excuse to sell. So very important, let's not overdo it again in 6G. 5G, many features, only 3 main pillars implemented. And let's learn about the fiascos. For example, 5G has a gigantic fiasco, which to me was the millimeter wave. Lot of research, lot of development effort in millimeter wave. At the end of the day, didn't succeed commercially. Look at the news. United States, T-Mobile, declares that millimeter wave deployment is not feasible after spending a ton of money. South Korea revokes 28 gigahertz licenses. So a lot of effort, deployments, they revoke the licenses. So again, let's learn from the past, let's not overdo it. And with that, here I go with my bet. So this is how I see the future. For me, the 6G will build similarly as 5G. It will have 3 main pillars. There will be a hardware breakthrough that will be the centimeter wave TerraMIMO that will allow more capacity to support the new services that we plan to serve. There will be a software development that is AI. For sure, AI will be everywhere in the network, on the application layer, generating traffic, but it's going to help us as well to optimize the network itself. Networks for AI, AI for networks. And then there will be this cool feature, the sexy one that we need to sell 6G. And I think that one will be sensing. So a lot of efforts at the moment are on sensing. But I remain doubtful of the true success like URLC. I think it's cool, it will sell, but probably won't get us the money that we expect to get, as has been for URLC, according to my viewpoint. So this is David Lopez's view. So maybe right, maybe wrong, but I'm going to go with it. And I want to talk about the two bottom ones, centimeter wave and AI, for you guys to understand what it is, the benefits that brings, and the challenges that they have. So let's go with it. So I don't know if you guys are familiar with wireless communications, but the spectrum is like the air that the telecommunication network breathes, right? So networks are built on a spectrum, and every new generation of technology comes with new bands open. So for 6G, we are expecting that new bands will be opening in the upper mid-band, in the centimeter wave area, from 7 to 17 gigahertz. I really hope so. And if they come, they will come with channels with 200 and 400 megahertz. This means 4 times the capacity of 5G. So if that happens, and has to happen, we'll build a technology around this frequency. And what is the good thing of this frequency is that the properties are really good. The properties of this frequency, the electromagnetic waves, propagate much better than a millimeter wave. So that's why I'm hopeful that we won't face the issues that we have faced in the commercial deployment of millimeter wave, because these new bands have some better properties. So importantly, the loss of the channel, there are some estimations basically that says that at 10 gigahertz, you are going to increase the path loss around 10 dB. Okay, 10 dB is a loss, but we are confident that we can overcome that with more massive MIMO, with more beamforming gain. So, and importantly, it has also good indoor penetration properties. So it's easy with this new technology, or it's kind of easy to get from outdoor to indoor coverage, okay? So bottom line, very new frequency with very good propagation characteristics, good for developing a new technology. Now, how that technology will look like, and this is the key. So if we want to bridge this 10 dB loss, we need a new technology that has more beamforming gain. It's able to put the power in a given direction in a more effective manner. And for that, we need a new range of products. I don't know if you know, but today the standard C-band massive MIMO is built with 64 transceivers and around 196 antennas. So companies like Huawei, Ericsson, Nokia are talking about building larger arrays for the 10 gigahertz band, for the centimeter wave band, with much more antennas and much more transceivers. So going from 64 to 128 up to even 1,024 transceivers. So that is crazy. It's a very large amount of hardware put together in an array. And it's good. If we are able to do this, we will get the best of these channels and increase capacity up to 50 gigabits per second per user, according to Huawei, which is magnificent. But as you know, in life, to gain something, you need to lose something elsewhere, right? So, and there is a problem here. The problem is that if we build the massive MIMO array the same way we build it in 5G, the energy consumption of the array will be gigantic. So if energy consumption is a problem today, if we build these massive MIMO arrays for the new centimeter wave band the same way, using the same type of transceivers, the energy consumption will be prohibitive. And this is really important to take into account. We need to do something different. And innovation is really needed in these antenna arrays and all the processing behind. So now, I'm going to give you some numbers. I'm going to quantify. We've done a lot of efforts in trying to quantify which is going to be the gain in performance and also the loss in energy consumption, okay? And then I'm going to show you how AI can help me to bring down that energy consumption. That is a bit the research that we are doing at the moment. We are doing this with multiple projects. One of them is with Huawei. So as part of the effort, we have built this sophisticated system-level simulation tool that is data-driven. What does it mean? So we have a tool that we can get data from a true deployment, blend it in, and perform analysis of how the network is going to perform, taking into account different KPIs. And today I'm going to show you a very simple performance comparison for you to have an idea of what you can gain and what you can lose. I'm going to compare 7 different types of deployments. So there will be a 4G deployment, that is the number 1. There will be a 5G deployment, a standalone. Then there will be 3 deployments that are heterogeneous, more similar to the reality, where we blend 4G and 5G. So there is the third one will be 4G collocated with 5G on the same sites. The fourth one will be 4G and 5G non-collocated, with the 5G being denser. And the fourth one is the same as the fifth is the same as the fourth, but with more capable base station. And then the cool one. So the scenario where we have 4G, 5G, and 6G deployed all together. Collocated, having 6G collocated with 5G on the same radio, and the non-collocation case. And to do this, we have done it with a tool that we have built here at the UPB that is called Julia, which is one of the first systems, first open source system level simulators. It's built in Python, it's GPU accelerated, and it's able of doing multi-layer massive MIMO simulations. And here are the key insights. I'm going to be brief because I don't want to bother you. But the key insights are the following. So let's look at the reddish type of curves. Those reddish curves are the 5G performance. It's the performance that you get today in a true network. And that is around 30 megabps per second per user. If we go 6G, if we collocate the 6G arrays with the 5G, collocate means that you deploy in the same site, in the same place. So we expect that the performance will improve in median 4 times, and we'll go to this 100 megabits per second per user in median, which is one of the targets of the 6G standardization. But if we deploy the 6G, these massive antennas smartly, where the users are, we see that the gains will be substantial, so 3 times more. We will go to speeds of 300 megabits per second. That is amazing, and in the top of the performance, we'll go beyond the gigabits per second. So this curve is telling me that there is a big advantage of taking these 6G antennas and place them not where it's easy, that is deploying them where I have my 5G sites already, but deploying them where they are needed, close to the users. And to understand what the users are, machine learning is, for example, a very good tool that can help us to have traffic predictions, allow us to wonder what the users are, and make the right choices with the deployment. But I foresee that more than ever, deploying 6G in the right manner, non-collocated with 5G, is the way to go. Here are the energy consumption of the very same deployments. If you compare the blue with the red, basically it's comparing today's 4G with today's 4G plus 5G, we see the energy consumption increasing 3 times. We all know that, so this is a public fact. So when we deployed 5G, the energy consumption of the network grew 3 times. And now when we will deploy 6G, that will continue to grow 33% more. So is this a problem? It might be a problem because electricity is expensive. So now operators, they need to make a choice. Okay, 6G is cool. 6G may give me more performance, may give me 100 megabits per second, or may give me 300 megabits per second. But I need to pay the electricity bill, and that one is non-negligible. So therefore, again, if I need to pay that electricity, better to pay for the blue curve, deploying smartly where the users are to get the most, rather than deploying where it's cheap and convenient because I have my 5G sites. So we have all this analysis in this paper for those that are interested. And just to wrap up, let me talk about the future. So centimeter wave massive MIMO will be a component, but I think AI will be another very important component. And today we are already using AI to optimize networks. There is nothing new in that. In my previous job at Huawei, I was doing that every day. So what it will be new in the 6G is that we will build networks for AI. And that is different. That is a paradigm change. So my network is going to behave in a different way. And the way I see it, something that is exciting to me is summarized in this figure. So I foresee a future where the machine will collect, as today, measurements. That would be the number one. And today, what the base station does with the measurements is to perform some operations and throw them away. In the future, I foresee that they will use that data to build models. So every cell will be building its own model, energy consumption model, SNR prediction model, et cetera, et cetera. And here the key thing, the standardization is going to help us that different cells exchange their models. So all of a sudden, I will understand how you feel about your environment. I will know how you consume power, how likely is your users to have a given SNR, et cetera, et cetera. And with that, the decision-making process will be much easier and much more accurate, because all of a sudden I can take decision based on what I know, but also on what you know, because you have shared with me your model, your many models of many different aspects of what you perceive. And with that, for example, we here at the university, we are running experiments on how we can use this tool, for example, to optimize user-to-cell association. Just as an example, if you have a very heterogeneous network in the city of Valencia with 4G, 5G technologies, different products, different versions, et cetera, not every cell consumes in the same way. The new sites consume less than the old ones. And therefore, associating the users to the cells that are the strongest is not anymore the most efficient. Maybe associating more users with the new sites is better. And this I can only know if I know how they consume energy, and I can know through the model. So building on these logics, what we are doing is testing all this, and some of our results, for example, says that if we enable this AI model exchange, and nodes know about the behaviors of others, it's possible to decrease the energy consumption, for example, by 6%, just by looking at the user reselection process. So there are many gains that if we are smart and have knowledge on the network, we can harvest with AI. So therefore, I invite all of you to think in this direction. What can I do with AI, and how can I build something to optimize what we currently have? So I think there are many opportunities in that area, both for academics and industry. And there is a summary as well of the work with Huawei. And that's it from my side. So if you have any question.
I think that many of us, we trusted in millimeter wave from a single measurement campaign in New York, and
right.
You remember that. So probably next time we should not do that way. There is a microphone in case you have some questions. Any question from the audience? Yes. Vision.
I can listen to you and repeat the question. Right. Yes. So, so, so we build these energy consumption models using data. So we use some true deployments in Shanghai. So we, at that time, I was at Huawei. I was a colleague of yours. So we built all these AI-driven machine learning models. So I think that we had like around 12,000 cells, and the data was gathered for different different days, different hours of the day, different products, different versions of the products. So the model was quite heterogeneous. And these simulations take into account an average of the 24 hours of the day. So we simulated for every hour of the day according to the data, and then the results I was presenting is the average, basically. So for the 6G, we made some assumptions. Okay.
Can you repeat the question?
Can you repeat again?
Okay,
Yes.
let me try. I mean that 6G may have more a design on the energy efficiency. Have you already taken that into consideration?
So what we did is to take some assumptions because there is no 6G products to create the model. So we took the 5G model and make some assumptions that the hardware is going to improve in a given way. So basically the static power consumption is going to decrease by 30%, and the transceiver energy consumption, it will be, instead of around 3 watts, it will be around 1.5 watts or something. So we made some assumptions because we don't have data to measure the 6G radio.
Okay, thank you.
We have time for one more question here. Sergio. Yeah.
Thank you. Focusing on energy savings, where do you stand on switching off, switching on the cells at night,
Right.
etc.?
So all the work that we did in Huawei was for the carrier shutdown, the symbol shutdown, RF shutdown. And of course, you can save energy. Our estimations is that you can save a lot of energy. But the reality out there is that today they are barely used. These techniques are not used simply because operators, they want maximum coverage. The main target is to penetrate indoors. We need to have indoor coverage from outdoor. In my experience, what operator does is full power. We never switch off anything because there is a fear we lose coverage. Shutting down means losing resources, and maybe some customer is calling, oh, I'm disappointed. I have coverage and now I don't. I move from A to B. So the tools are there. AI can help us to optimize. I don't think the operator mindset is still, now it's more because the electricity is very expensive and they need to decrease the bill. But the mindset is still coverage and capacity rather than saving.
Okay.
My viewpoint.
Okay. Thank you very much again, David.
Okay.
It's a pleasure.
Thank you.
Very nice talk. So let's move to the next speaker, distinguished speaker, I would say. Dr. Wen Tong is the CTO of Huawei Wireless, and so he's in front of wireless research in the company. Well, also he has a long trajectory, joining Huawei in 2009 after being a fellow in Nortel Network Technology Labs. Okay, Dr. Tong, I think you may know him. He's a recognized leader in technology in this area, in wireless. So he has been behind the development of many of the technologies that we are experiencing today in our devices and in our life, leading this research in Huawei. He's a fellow of IEEE. He received the IEEE Communication Society Industry Innovation Award and the Distinguished Industry Leader Award in 2018. So, well, he has a huge number of patents and publications, and we are honored to have him with us. Dear Professor Tong, dear Dr. Tong, just come on stage. Thank you very much. Maybe this way you can. This is for switching, yes.
Good morning. Thank you, Narcis, for the invitation. I was actually on this forum at the first session, first edition. I think because of pandemic, I was show up with a 2 virtual ones, so I need to do this real. My topic is AI, and then the 6G trajectory will be heavily impacted or be revolutionary or be disrupted by the recent revolution of the AI. The AI revolution is developing in such a rapid pace for the past 20 months, and that 6G will show up in the consumer market about after 2030. So, why AI? This is the one picture. In 2018, I was asked in the research community, what is next for communication? So that's the model that I put on this. But it's a very vague vision that we all held for this, for the past definition of a 6G. So meaning there will be a new AI layer or neural network layer as an interface to bridge the intelligence through the communication. So this is the new paradigm. And with these new layers, they will be completely changed human-to-human communication, and human-to-machine communication, machine-to-machine communication. It's very straightforward for machine-to-machine communication when you have an AI capability. And then there will be for human and the machine communication, this is the reality with this ChatGPT revolution, because that, in fact, is delivered a revision that natural language to anything. You just need to express your intent. And there is no software development, application development. Through the network, the other end of the AI agent will execute what your intent it is. So that means it will be another ground of level of the play that anybody, any company, any people can do application. So the superscalar, the barrier will be removed, let's say, in less than 10 months now. So this is the new landscape we will see. And I want to add one topic on the human-to-human communication, because you start to do your daily activity, you have your agent, your personal data, all your activity will be input this as a supervised learning model. So with that model is you, that represent you. So anybody want to talk to you, they don't need to do real time communication. You just publish your model to the person so they can do that local talking. That means simultaneously, you can talk to millions of people at the same time with different conversations. So that's the landscape you will have in terms of human-to-human communication. And that is the efficiency. All of a sudden, you will become 1 million agent people as a digital worker to fulfill the job. As the AI progress, the large language model is over. So 2024, it's done. Now, nobody worry about large language models, so the next one is AI agent for this 2025 and 26. What does it mean, agent? That means agent will take your intent, do lots of planning, reasoning, with a very long sequence of the workflow that will automatically execute your intent for you. Imagine, so this is the capability. every process, every the industry process, our business process will be automated by this. So in a nutshell, you will treat like every email will become an agent, every web browsing will become an agent, or maybe a one agent. So you do not need a phone to have 20 apps. And if you do, I do my lunch, I do my taxi and all this. This is only one interface. You just need to tell them what I want to do today. Everything will be arranged. So that's the agent part. Then that's more powerful is on the platform, you will have an AGI. That means we specialize or we are good on certain aspect. On the top of the world, maybe 90%, you are the best. But this AGI is a polymath. That with this AI, you will be specialized over anything. That means again, we will have 1 million Einstein, we will have 1 million Leonardo da Vinci show up. So this is a different world with AGI. So that is basically every engine, every people interact will be going through the AGI. So that's the landscape of 2026 and 28. What I meant is the technology roadmap is clear. It's the matter to develop the vertical by vertical. They was all combining this. This is then I didn't mention for 2028 at a time. Okay, we need to connect the agent to deliver this, but one progress is very highly impactful is the super intelligence. I think in industry, we believe that is durable now. We know the road path to that. So the super intelligence, that means you can do a lot of things that are better than human. This will be a service everybody die to pay for. Why? Because when you deal with your peers, your colleagues, or your daily works, if you are not connected to the super intelligence, that means your efficiency, your capabilities is unfair. It's the time that we have a feature phone, you only know how to do phone call, you're completely not connected to the internet. That is the point of transition that we were facing for 6G. And then get into how to design the 6G now. So the important thing for the network to AI is clear, because Moore's law is stopped. There's no way to build a human brain-like things in the portable form with battery. So you have to access the network in order to get intelligence. This is number one. That's why we need a connectivity. The second is, it doesn't matter, the bits is not important. The data package is even not important. The important thing is how many, the connectivity between the format of intelligence that in the AI world is the transformer they call token. How many token you have, or you communicate, you consume. In the large language models, so the token is some kind of a billing level that will describe any ChatGPT service. So this is one is the AI channel. The third one is the sensing. The sensing meaning that we are talking about digital AI. You do everything, you do your chart in the digital world. Nothing automate the workforce. So the physical AI need a sensing, because when the robot come into this room, they have to align with the physical world in order to take action. So this is my talk. The very most of my rest of time I was spent on the AI and the sensing. That radio network will change to connecting information to heavily tilt to the AI and sensing delivery. So then the UE side is you have a sensing, you have an inference capability, you can do a so-called tactile with a very precision action to do. Sensing, you have many other sensing, for example, the video and the millimeter wave and the other radio wave. I talk about the centimeter wave of sensing. So what a robot service need to realize today is like this. You have a robot with a neural network to train how to pour the coffee, and then you have to take this network to this room. And in that case, you need somebody in the remote to tell the robot exactly this room, where is the table, and how do you do this coffee service. And then you need to do this many, many times. This is a very not favorable situation because a human being cannot do some 1,000 times of coffee pouring. So this is another thing, how to fine-tune, generate data, and then you have this robot capable in this room to deliver the service. Imagine one action, other things, clean the floor, many other things, you need to do this. That's the AI people today, they have to do this in the human in the loop for the specific job, although the robot is capable to do the coffee, but for this room, you have to do this. Now, if we are with the robot is a so-called agent is enabled, that means you have a sensing, you have a reaction, you know consequence of your action, and you have your own observation. That's consequence is a reward in the AI language. So in that case, there's an automatic machine to tune what is the technical term called policy, or a technical term called reward. So those are the things that you sort of learn general special rule in this room to do the service. So this is a classical feedback system. And then this is the detail how to do complex work. The idea go back again. The so-called software-defined radio, software-defined service that 5G people like me all was doing before. We need a software to program the robot to do this thing. Now, in this new scenario in 6G is you do sensing. That means you do a bunch of measurement to have the physical reality, and then you communicate, and then you start to do execute one action. These two steps, as I mentioned, is very important to do the so-called physical AI, the life AI. And in that case, in the network layer, that means in the core network so we just give them the intent, and then number one step, the model will start to do the large ARM is a large reasoning model, so they need so many steps to complete your command, and then there is an agent to do reasoning, decision, action, and sensing, this type of loop. So it will eventually generate step 1, step 2, step 3 with very precision of, there are some other terms called chain of thoughts that with one consequence of probably hundreds of steps, micro steps to do this, and then the chain of action. When to do what, how much you do. So these are the one come to the radio network, and then you, in the robot, you have many interactions, and this carries through the radio connectivity. You do MMTC with observation, URLC with action, and then you get also reward from what you do, and then you have a bistatic, semi-static, monostatic sensing. This is the big work with we were with Nashi's. We kill almost last 4 years to do this sensing and observation. So that's step by step to do. This is the foundation for automation of everything. Okay. The other sensing thing is very important. Is imagine in this room we have 100 devices. They all propagate radio wave. If we collect all the video for the previous generation, 5G, 4G, 3G, 2G, 1G, we only care bits. All the other propagation information for us is a bad thing because it's corrupt the signal. But if you think the other way around, because signal propagating the room, they carry the physical information. If we collect all of them, we basically can reconstruct the room, the physical model of this room. And this is the digital twin that everybody in the service domain is dying for in order to have this one so that you can build your service. And this is so easy now with the open source software, you can construct the room. With that room, now you can start to deliver this service with this new capability of network. Why is this important? Because once this is a global technology, it will be everywhere. Once it's defined, network is deployed, that means everywhere in the earth of the corner, you can have this capability, and therefore, with the consumer of this type of consumer robots, we're talking about something 20,000 per universal generic humanoid robot to start. It could be a very decrease the price down the road. At least Elon Musk was pricing this in the 20,000 at the beginning. So that could be easily match the human headcount in the entire 6 billion or 7 billion population. If you might like 2 or 3 of them to do the thing for you. So that's where it is the 2030 at that time. That is a scenario. Now a little bit technical how to do the coding of all this sensing of, and as well the observation reward model. So there are some good format we need to modify. This is sort of our job, need to make 6G happening. And then this is the one key concept, it's called the token communication. As I mentioned, because in the device, the intelligence capability today is about 10 billion coefficient. Likely in 2030, because Moore's law, semiconductors stopped, and then we will have some 100 billion coefficient. That is the intelligence at the mouse level. Not even a dog need 500 billion. For every human being, we have 100 trillion of the coefficient. So it has to be somewhere in the network to access. So in between, they're talking connectivity is this token. It's a very universal. It's any language to any language, and it can be compressed 10,000 times if you want. That 10 books with a one-page, half-page summary, or you can have one thing that they can generate a novel for you. So these are the one of the communication with both sides have the neural network computing. Let's say in this case, we need to do this action token and text token. So the text token meaning that the translate intent to a sequence of a thing you need to do, and then with this RAM part, you will make it align with the physical reality. So that's where the concept I'm trying to deliver today. And this is the latest experiments that a robot is doing the work. The radio wave is sensing, that's the green dot, the robot, what is action to do, and then use the radio link to command the robot to take next action. So this is the new way of 6G. And by the way, this is not camera, so your privacy is preserved. And actually you can selectively, so not just that monostic, static pointing where you want to do the sensing. It's all like being controlled, nicely. So here, for example, you put your hands on, and the robot may pour coffee for you. It looks seems like it looks very very nice in the centimeter wave. So these are the bands, probably the primary frequency bands for 6G. So I mean, we can, in the I team, we can probably talk in the next phase. We do some the 6G robots around in the harbor and do this type of. I don't think it's a future. It is really near. It's about 5 years. It will be real. Thank you.
Thank you. Thank you very much. Very interesting talk as usual, Dr. Tong. And every time I hear you, there are new things, and there are new insights and new visions. So thank you very much. I'm sure that there are questions from the audience for you. This AI architecture seems to be, really a step ahead compared to what we have now in the networks. So current networks are not based on AI, and are not using these agents, at least with a pre-structured architecture. So how far do you guess we are from this jump to this next generation of networks in which the architecture is purely based on AI models and not on communication links? Do we need 5 years, 7, 10? Are there any technology gaps in between? Micro?
The gap is the following. The so-called AI communication, those are the vision. You know, we even have a book on this stuff. But all of a sudden, this is the ChatGPT show up. That is a different ball game, and they are moving very fast. That's what the timetable that I show you. That Silicon Valley people are all consensus on that. So this is the one aspect. They are unexpected with very fast movement and progress. But on the other side, our community is not very sensitive or being even aware of this thing. So now there will be the same thing like some 20 years, 40 years, 30 years ago I was experiencing when every mobile operator make a very good money with a GSM call. Internet show up. So there was an industry with a very brief decision, let's have a data only. That's a LTE. Even with a full of the contradictory that people was this deliberately labeled LTE, very long-term future, you will use the internet on the phone. But guess what? The iPhone show up and everybody use the phone to do even the voice call. So that's where this is probably the transition yet again with AI.
This is not only changing the structure of the network, but also the business models. Absolutely, yes, and how to make money out of it, right? Okay. Question from, you may introduce yourself maybe when you do a question, so we know it.
Sorry, thank you for your thoughts. Since it is very interesting to combine the academy point of view and the vendor point of view, how do you introduce in your keynote the energy savings point of view from David? Thank you.
Yes.
This is a legacy dilemma for the industry. What we were trying to develop, the radio, 1G, 4G, 3G, 5G, is a universal radio that turn on any place it works. So that means when you transmit every packet, you assume it's blind. You do not know any situation. So you do a lot of measurement and the protocol shaking in order to make sure that packet is reliably transmitted. This wastes a lot of energy because you have a measurement, the protocol shaking, and consumers don't see, but we have probably 10,000 specifications onto how this make sure this packet is transmitted. That's a complexity and the energy saving portion. Now, if you know where's the people in that specific room, by the way, all the previous measurement is learned into the neural network model, so they pretty much know how to deliver the packet to you. So cut down a lot of cases. You turn off the radio most of the time. So that's what the saving. So in a nutshell, our study show that you can cut almost the entire network half of the energy, any bands. So if go to the bands like we talk about, centimeter wave or millimeter wave, it's a 4 times cut through the energy.
Thank you.
Thank you. Any other questions? Some comments? Okay. No, thank you very much, Dr. Tong. Thank you. So now, you know that, okay, ITIM is a huge research institute, of course, in Valencia. We have plenty of experts in research in this area, but we are not alone. In Spain, there are many other, or some other relevant institutes. We have today a couple of them talking on stage, CTTC, that will come afterwards, and I2CAT. I2CAT is a research center in Barcelona, and Francisco Vázquez is senior researcher and head of the V2X communication research line at I2CAT Foundation since January 2022. He has participated in a number of European and competitive funded projects in Spain as well, and in many transfer projects. He's the technical coordinator of the European 5G MED project now, demonstrating the potential of 5G technology to support connected, automated and mobility services in cross-border scenarios. Since his main research activity focuses on intelligent traffic management, cooperative intelligent transportation network services, so vehicular communications, in fact, the talk is about this. Let me remind you that right after this talk, we will have a coffee break out there, and that we have demos. There are some demos on the stage over there about immersive reality. So, Francisco, thank you.
Thank you for the introduction, Narcis.
Thank you very much.
So good morning, everyone. Let me see if I can. Doesn't change. Okay, the aim of my talk is, I'm focusing on connected and automated mobility, as Narcis already introduced. Maybe we can think for a while, just for a moment, how connected and automated mobility and intelligent transportation systems are going to be transformed in the following 5 to 10 years, where the implementation of digital twins powered by advanced 5G and 6G technologies are going to transform this. Oh, ¿qué pasa aquí? Okay. Technical issues. Yeah. So I will present today our 6G Twin Road project, in which we are somehow contributing to this transformation of connected and automated mobility, leveraging digital twins, several functionalities of next generation mobile networks, and also smart sensing. So I will start first with a very fast overview of my presentation, showing you some of the figures of our project, the main goals of the 6UT Road project, the structure of the project, and then I will show you the partner ecosystem that we built around 6UT Road. After that, I will finalize my presentation, explaining some of the key achievements that we obtained along the project and some of the lessons that we learned along the way. So 6UT Road is one of these unique IMASD projects that we got with the funds of this Next Generation EU. At ITUCAT, we obtained 7 of these unique projects in total. The project started in 2022, and it will be finished by the end of 2025. It has a total budget of 3 million euros, with 70% of the budget dedicated to subcontracting. So the main goals of 6UT Road are to advance connected and automated mobility in any kind of urban and interurban environments through the use of next-generation networks, digital twins, and smart sensors. So the idea here is to transform how vehicles, the infrastructure, and mobile networks interact with each other in order to create a safer, more sustainable, and more efficient ecosystem. So let's take a look at the structure of the project. What we did is to organize the project in 4 different sub-projects according to the different challenges that we are facing. In the first sub-project, we are focusing on AI-driven 6G networks to enable vehicular services. So here, the main goal is to ensure that we have safe teleoperation of autonomous vehicles. For this, we are using predictive QoS management. In this sub-project, we are collaborating with Orange and also with IDIADA. So we are using the test track of IDIADA for the demonstrations. Then we have the second sub-project that is about vehicular enablers for road traffic operators. So the main goal of this is to enable coordinated maneuvers in complex traffic scenarios, coordinating also with the protection of vulnerable road users. And at the end, we do the evaluation of these use cases using different types of radar technologies. In the third, we have smart sensing technologies on vehicles and infrastructure, with the idea of creating digital twin of the traffic scenario on board, so that we are able to create volumetric digital maps using any kind of optical sensors. So here we are using sensor fusion and geoposition to track the road users in order to make decisions on the car. In the last sub-project, it's about digital twins of vehicular environments. So here we are creating digital twins of urban and interurban scenarios for intelligent traffic management. We are using real data sets to train prediction and decision-making inside the digital twin, and we did the validation of these digital twins deployed on real scenarios. So as you can see, we collaborated with several companies. We had the Tier 1 supplier Ficosa in sub-project 3, and also Buptix as a manufacturer of light field cameras. And then in the last sub-project about digital twins, we did the work with Aimsun. They are manufacturers and providers of a mobility simulator. And we also did the work with Autopistas, providing a highway where we built a digital twin, and also with Acisa. They were in charge of a digital twin of a section of the city of Tarrasa. So let's take a look at the achievements sub-project per sub-project. So first, focusing on the teleoperation of autonomous vehicles. So the use case of teleoperation is quite clear and very well known. So we have an autonomous vehicle that finds a complex traffic situation. So we can have a vehicle that finds a traffic jam and it does not know how to react. Or maybe we can have some failure. When this happens, it makes a request of remote assistance to a teleoperation center. And in there is a human driver that is doing the teleoperation of the vehicle from a remote station. So we have in the middle the mobile network for the exchange of sensors data from the car to the teleoperation center, and control commands going from the teleoperation center to the car. So here the main challenges are to ensure the teleoperation process with seamless connectivity. So we need to ensure that we have uninterrupted service continuity. So we need to avoid those areas with low or bad coverage, because here the safety of the teleoperation process really depends on the performance of the network. So whenever we have a drop in the signal quality or an increase of the latency, then the vehicle will stop. So what we did in order to overcome these challenges is to build a predictive QoS management system for this teleoperation. It is composed of 2 main elements. that are a network exposure API that allows us to exchange information between the mobile network operator and the teleoperation service. And we also build a prediction of QoS function that is based on the collection of network metrics in real time and also the planned trajectory for the teleoperation. So we did several demonstrations and validations in IDEA test tracks where we did this prediction of the QoS. And here you have, let's see if this video works. Yeah. So here we have a video with some of the experiments that we run. These are the cars that we use for the teleoperation. These are some images of the remote station. And we will see 3 different scenarios. In the first scenario, we have a complete teleoperation process. We have good quality of signal along the whole path. So the remote driver is able to control in all moments. Here you can see the remote station with the big screen where all the images from the car are received. We see the position of the teleoperated car at all moments. So here we don't have any issue. The measurements of latency and signal quality are good, so no problem. Here we have all the metrics in the dashboard that are being used by the predictive QoS system. In this second scenario, the predictive QoS management system is working. And we will see how, at a certain point, there will be a warning at the predictive QoS in the HMI of the driver, a warning to indicating that we have a degradation in the QoS, so he is able to react and reduce the speed during the teleoperation process. So we are here providing a safer teleoperation. And in this final scenario, what we do is just the predictive QoS is disabled. So whenever there is a reduction in the signal quality, this is something that we did tricking one of the base stations, the car will suddenly stop because the teleoperation cannot be executed. OK, one moment. And here we won't have time for reaction, and the teleoperation process will be halted by the system. So we have a sudden stop during the teleoperation process. So those are some of the achievements in Project 1. Let's move to Project 2 about vehicular enablers. In here, we focused our research in the coordination of maneuvers between vehicles in complex traffic scenarios. So here we are using the exchange of V2X messages between cars. So we focused on a use case that is an unsignalized intersection. So we have a couple of vehicles that are approaching to this intersection. And what we do here, the idea is very basic. So the vehicles are broadcasting periodically their planned trajectory. So what is the plan within the next few seconds? Whenever one of the vehicles wants to change the trajectory because he saw maybe an obstacle, a pedestrian trying to cross the street, what it does is to analyze planned trajectories and see if there is a potential collision. And when this happens, there is a coordination process and negotiation between the 2 vehicles involved. So here the challenge is to ensure that we have low latency communications and high reliability in the exchange of these V2X messages. We developed a couple of versions of this maneuver coordination service. One is centralized in the infrastructure, so all the intelligence is deployed in the infrastructure. We have a roadside unit providing support to the system. And then we have another solution where all the intelligence is distributed in the vehicles, and they do the negotiation themselves. Again, we did several demonstrations and validations in IDEA test tracks. So here you will see 2 vehicles approaching to this intersection. So in the first, we have that the vehicles are just using the traffic rules. These are the dashboards that we have in both cars with an indication of the speeds that they need to apply at all moments. So here, the car with the highest priority crosses the intersection as we normally do, so providing priority to the car that is coming from the right. And then in the next experiment, what we do is we do a negotiation between the 2 vehicles, and we are providing priority to the vehicle that is coming from the left side. So in this case, the white vehicle is the one that crosses first. So we are optimizing the unsignalized intersection. The idea here is that there is a pedestrian trying to cross the street, and the vehicle that had maximum priority decided to reduce the speed to provide the pass to the other vehicle. So let's jump now into smart sensing technologies on vehicles and infrastructure. This is project 3. So here the research was focused on this use case of cooperative perception to enhance the situational awareness of autonomous vehicles. The idea is that we have sensors deployed on the infrastructure, but also in the cars. But these sensors have, of course, limited perception range. They have limited accuracy. We can have obstacles. And what we do in order to overcome this limited perception is to exchange sensors data between vehicles and also with the infrastructure to extend this perception range, and at the same time construct a digital twin of the traffic scene on a 3D map. So here there are several challenges. One of them is the synchronization of multiple sensors that we have in the scenario, and of course the detection and the tracking of multiple objects in real time from different points of view. We developed several solutions. The first is a testbed where we have the infrastructure composed of 2 posts with a stereo vision system, and then we have also a vehicle equipped with 4 low-cost light-field cameras and the several lidars and other types of sensors. And with this, we built a 3D object detection and tracking using these multimodal sensors. And we developed late data fusion mechanisms using the exchange of cooperative perception messages. So all the information that is detected by the vehicles and by the infrastructure is embedded into these CPM messages and are exchanged between the different elements. And then we jump to the digital twins of vehicular environments. The idea is to create a virtual representation of the mobility scenario with the goal of simulating and predicting the behavior of our traffic scenario using collected data in real time. So the idea here at the end is to facilitate intelligent decision-making to enhance traffic safety, reduce congestion and pollution. So we designed a digital twin architecture composed of several elements. We did this work in collaboration with IMSUN and Autopistas. We have a data hub that is aggregating data from different elements in the real mobility scenario. So we are collecting data from the infrastructure sensors, the cameras, and connected vehicles. We have a prediction engine that is in charge of predicting incidents, analyzing data in real time. So we are able to predict traffic congestion, accident risk, and an increase of the pollution levels. And then we have a decision engine that is the one that evaluates the behavior of our traffic scenario under different conditions. So we are using for this, in this design, a mobility simulator by IMSUN. At the end, what it does is to recommend a set of actions to avoid incidents and optimize mobility. And then we have the final element is a validation engine. This is the one that interfaces with the traffic operators in the traffic management center. It shows how these selected actions can enhance and improve the traffic. And at the end, the human operator, in this case, is the one that transfers the actions to the physical world. And this is done by the transmission of messages to connected vehicles and also by the different changes in traffic light and informative panels. With this digital twin framework, we built a digital twin of the C32 highway. It's a highway in the south of the city of Barcelona. So we have a segment of 50 kilometers. It's a quite complex segment with 8 tunnels, 3 viaducts, and 19 accesses in total. And in this infrastructure, we have different types of sensors deployed by Autopistas with the idea to sense and detect traffic intensity measurements, density, and also measurements of gas emissions. The highway is, of course, it has connectivity. We have 4G and 5G networks deployed and providing coverage, and we also have several roadside units providing the cellular V2X PC5 connectivity to those areas, for example, in the tunnels where we don't have 5G connectivity. The idea with the digital twin is, of course, to optimize several KPIs. So we want to increase the intensity, decrease the travel time, and also minimize the variance of the speed along the whole path. We implemented 2 different use cases with this digital twin of the C32. In the first use case, the aim is to reduce traffic congestion and improve safety. What we do is to select and to define and to adjust the speed in the highway in different segments. So we are defining different speeds according to the incidents that we are predicting. And we are also adjusting the inter-vehicle distance. So with the simulations and the results that we obtain, we believe that we can have reductions in the travel time around 8%, and then an increase of the intensity of around 4%. And then in the second use case, it's about the reduction of pollution. For this, we use the copper model for the estimation of the vehicle's emission. It is integrated in the mobility simulator. What we do is, at the end, we do adjustments in the speed according to the predictions of the digital twin, and these are the levels of reduction in the gases emissions. So let's take a look at some of the lessons that we learned along the project. In project 1, as I explained before, we did this development of the network exposure API and the prediction of QoS function, facilitating safer teleoperation of autonomous vehicles. So with this, as you could see in the demonstration, we were able to adjust the speed according to the predicted QoS. So this offers the opportunity and the possibility to select the right and the best trajectory according to which are the QoS levels along the whole path. It is clear, of course, that with this exchange of information between advanced 5G, 6G networks and the vehicular services, we will facilitate the implementation of quality-on-demand functionalities. So we will be able to adapt network configuration according to the vehicular services needs. And then there will be a reconfiguration of the network and the vehicular services according to the operation of the network in order to avoid overloading of network cells. In the second sub-project, the one about maneuver coordination, we demonstrated the feasibility of this maneuver coordination using 5G standalone networks. So we focused on the 3.5 gigahertz band, and we also use LTE V2X PC5 interface for device-to-device communications. And we were able to demonstrate how these maneuver coordination services operate really in unsignalized intersections. The idea is to adapt this algorithm to other kinds of complex maneuvers. So we are thinking about lane merging, on-ramp merging in all these complex V2X scenarios. And this will be, of course, validated using level 4 autonomous vehicles. In the third sub-project, we identified the sub-project about the cooperative perception using this creation of digital twins of board. We found several limitations on the use of light field cameras. There were really an optimization for the use in this type of cameras in automated driving. They generate high volume data, which means that we need significant computational power. Any noise and artifacts are really limiting precise 3D reconstruction, which means that we need complex and precise alignment algorithms. And they also have a really limited range of perception. We implemented cooperative perception based on this late data fusion, which means that whatever is detected by the vehicles is embedded in cooperative perception messages using one vehicle and the infrastructure. The next step is to test all the kind of data fusion techniques. So the idea is to test intermediate and early data fusion, which means that we're going to share raw sensors data from the sensors on board the car and the infrastructure. This is something that we need to evaluate. Of course, there are trade-offs in terms of bandwidth requirements and also energy consumption, but we have maybe better perception accuracy. And then in the fourth sub-project, the one about digital twins, we demonstrated how our digital twin framework can be customized for any kind of urban and interurban scenario. We have the example of the C32 highway, which shows promising results to improve traffic efficiency and reduce emissions. In this case, the solution is based on a mobility simulator, so we are running simulations from time to time. Whenever we detect or predict a traffic incident, what we do is to run and execute several rounds of simulations with different actions using the data collected in real time. With this solution, the problem is that the time that we require for decision-making is 6 minutes, so we are trying now to optimize the decision-making process using AI-driven decisions. And then the recommendations, as I explained, are sent to vehicles within specific highway segments. So we are sending recommendations of adjust speed in this particular segment. And all the vehicles that are within that segment are receiving these recommendations. The idea is to make this a little bit more complex to allow other use cases by sending recommendations to each of the vehicles, so specific recommendations per vehicle. With this, we can implement use cases like, for example, the reduction of the time of arrival of an emergency vehicle to a place where we can have an accident. So we are trying to do the, let's say, the coordination of vehicles around a specific area by sending microscopic recommendations. And that's all from my side. Thank you for your attention.
Bueno, creo que le voy a dar trabajo al traductor de español a inglés, a hacer las preguntas esta vez en castellano. Gracias, Francisco. Por mi experiencia, cuando hemos hecho nosotros pruebas de remote driving, recuerdo una hace años, en el 2019, en la que teníamos un carrito de golf y los primeros equipos de 5G, siempre encontramos los mismos cuellos de botella, que son la latencia extremo a extremo, que impide que, digamos, que la conducción sea realmente algo en lo que uno aprecie que está conduciendo, y el ancho de banda respecto a la calidad de la imagen que puede reproducir desde la cámara. Yo no sé cuál es vuestra experiencia en eso, si habéis calculado, habéis sacado cifras o tenéis algunos valores de, no sé, de cómo ha mejorado todo esto la 5G, si nos ha puesto latencias más bajas y si el throughput es suficiente para que una cámara de 360 pueda realmente verse en tiempo real en un sitio remoto. Apologies for the Spanish speaking.
Do you want in Spanish?
En español, si quieres, como quieras.
Bueno, la experiencia en remote driving, en teleoperaciones, es en este proyecto, en 6 Union Road. Aquí conseguimos en los circuitos de pruebas de IDIADA unas latencias de unos 30 milisegundos, round trip time, 25-30 milisegundos. Los test los hicimos a una velocidad de unos 40-50 kilómetros por hora. Y luego experiencias en otros proyectos en los que hemos hecho teleoperación de vehículo autónomo en autopista. El proyecto 5G Met, llegamos a velocidades de en torno a los 70 kilómetros por hora en autopista con latencias de unos 40 milisegundos.
Quiere decir que de alguna forma el conductor anticipa lo que va a pasar en el vehículo, como pasa en los videojuegos, ¿no? Okay. ¿Cuestiones? Por ahí hay una.
Hola, buenas, soy Gerardo. Tengo un par de preguntas. Lo primero es si ves el estándar de celular V2X como el estándar para quedarse en comunicación vehículo a vehículo para la mayoría de la industria. Y lo segundo es si ves una implementación a corto o medio plazo del estándar, pues contar con RSUs en la calle, con OBUs en los coches, para poder ver una implementación en el mundo real a corto plazo. Gracias.
Vale. En cuanto al despliegue de RSUs, es una cuestión interesante, la verdad. Por la experiencia que estamos teniendo con autopistas, las RSUs se despliegan en aquellas zonas en las que la conectividad celular no llega, básicamente en los túneles, como he comentado. El problema que tenemos es la escalabilidad. Si queremos desplegar RSUs en todos sitios, esto va a ser realmente complicado, no escala. Eso sería la segunda pregunta. La primera pregunta no recuerdo.
En cuanto al estándar de V2X, si va a ser el estándar homogéneo en toda la industria de comunicación vehículo a vehículo, porque también está el 802.11p, el DSRC?
También es una interesante pregunta. Hay fabricantes que apuestan por el 800.11p y luego están los que apuestan por el Cellular V2X. Y hay trade-offs, evidentemente. El problema del 802.11p es la escalabilidad, de nuevo. Y bueno, yo diría que acabaremos teniendo Cellular V2X. Básicamente por el problema de la escalabilidad.
Claro. Gracias.
¿Alguna otra pregunta? Any questions in English?
Oh, here,
Yes, okay.
me again. My name
May you
is...
introduce yourself? Because
Yeah,
you have
sorry.
3 questions already, so very good to introduce you.
I'm enjoying this too much today. My name is Mavi, and I have 2 questions. In the geolocation step, English or Spanish?
English if you want.
Okay. In the geolocation step, are you relying on a third-party system, GPS, for example, or are you real-time doing a geolocation algorithm, trilateration, triangulation, etc.? And the second question, in the part of the sensing, it's fully camera, like, for example, a Tesla, or also LiDAR for better accuracy and reliability?
Yeah.
Thank you.
Okay, thank you very much for your questions. Yeah, for the first one, we are using GPS. Improved with GNSS RTK. So we do these corrections transmitted using these specific V2X messages which incorporate this correction of the positioning. And for the other question about the types of cameras, yes, we are using RGB cameras, so conventional RGB cameras on board the cars. Also, as I explained, light field cameras, also optical cameras, RGB, with specific features. And then we are also LiDARs. We are also using LiDARs on the cars and also in the infrastructure. These are the main elements that we use for sensing.
To complete the first question, is it possible to comply with the requirements to real-time geolocate, or do you need GPS? Mandatory.
Yeah. So the use of the LiDARs is especially needed for the geolocation of those elements that we have in the traffic scene that you are detecting with your sensors. So this is why we use cameras and we combine it with the RGB cameras and the LiDARs. Okay. And then, of course, you need the accurate positioning of the car, and this is something that we obtain using the GNSS-RTK location.
Okay, thank you.
Okay, you're welcome.
Okay, thank you very much. Any final question from you? No? Okay, thank you very much.
Okay, thank you.
So, if efficiency is the keyword in 6G, we are really very efficient. Thank you very much for by the way, the 3 speakers of the session, because we are right in time. Let me explain something that is happening today, que va a pasar hoy en este evento, y es que vamos a tener catering. Entonces ahora nos vamos a tomar un café con unos bollos, en fin, un poquito de un coffee break. Luego tendremos a mediodía un buffet de arroces, tal vez no paella, pero en Valencia hacemos muchos tipos de arroz, lo sabéis. Y después de las sesiones, al final de las sesiones, para todos los supervivientes, tenemos lo que en Milán llamarían un aperitivo, aquí en este sitio tan moderno un after work, pero que deberíamos llamar, y que en el programa pone networking session, pero que en realidad lo que vamos a hacer es tomarnos una cerveza y unas tapas para celebrar que hemos terminado bien el día. Eso será a las 5 de la tarde. Okay, so enjoy the coffee break and we are back in 20 minutes. Thank you very much. So let's, can you take the people inside? Okay. Oh yeah, everybody tends to be coming, okay. All right. So let's resume the program of the workshop on artificial intelligence networks towards 6G. And the current talk is mine, so I will introduce you because you have seen that in the event we have invited a number of industries that will jump on stage to explain their best developments and also to discuss during the panel sessions. But at an international level, we have this 1.6G association to which many of you belong, by the way. I think Expo is in 1.6G, Ken May is in 1.6G, 5Com is in 1.6G. There are many companies here that already belong to this association, and I will tell you very briefly what this 1.6G is about. Mainly to you to consider to join this association. So this is a research and innovation association. It's a non-profit association. We launched it 4 years ago. And it's open to collaborative framework, or it's a collaborative framework for working in the definition and the discussion on any aspect on the future technologies, mainly, of course, the 6G. You see there the founding members, and by the way, it's Universidad Politécnica Valencia there, of course. And as you see there, our vision is to create this next generation of networks to be sustainable and resilient and secure. I would say mainly to serve the society from the very beginning, enrolling the industries in the association. So this early onboarding of vertical industries is what I was meaning, right? All these sectors are welcome, or these verticals are welcome, but we are of course open to consider new verticals in the association. We pretend to facilitate the collaboration between industries and academia and institutions to target the best solutions for 6G possible. So open to new topics, but these are the current main verticals. We are already a huge number of partners, more than 120 from 31 countries, and of course we are growing. Yesterday we had a board meeting and we accepted 3 more institutions on board, so it's 123 plus what we have now. And as mentioned, many of the names are really well known. If you go to the web page, you can check who is there, and who is there currently on board on the steering committee board is these people in here. Maybe you can recognize some faces. The association is organizing working groups, essentially a group to define use cases and scenarios, this working group 1. A second group to develop technologies. This is where the majority of academia and research centers are providing inputs, of course. It's working group 2. Working group 3, by the way, led by the next speaker, Xuelian. It takes care of the communication and dissemination and the promotion of the 1.6G in many different fora. And finally, a testbed and trials. We want to demonstrate what we do in 1.6G with this group number 4. You see here all the list of topics. Many of these topics are being discussed today. You see there robotics, digital twin, non-terrestrial networks, etc. So many of these things will be in the event these 2 days. And if you go to the webpage, you will check how all this is. What can you get even without being part of the 1.6G? If you are part of 1.6G, you can contribute to this. If you are not part of the 1.6G, which is for free, by the way, you can get our outputs. White papers like this 5G technology overview, continuously being updated and upgraded. Not only this big one, but there are vertical white papers. So we have robotics, we have health, and so on. So every of them contains in the webpage a white paper that you can check. And as mentioned, we organized demos. By the way, the demos that we have over there, have you seen it? It's immersive reality experience with our lab in the UPV. The UPV is like 4 kilometers away. It's not 1.6G itself, but in 1.6G we organize these kind of things in events, in conferences, etc. Next time in UCNC, and then in our own event. I will show you in a minute. Also track us, track16g.org for open lectures. You see that we continuously organize lectures for training people or for explaining new things and our developments with these relevant speakers, with these distinguished lecturers many times. And also we have reached the momentum in which we have this ecosystem or the enrollment of 1.6G with, or the liaisons of 1.6G with these international associations. And you see many really well-recognized names, no? The 6G Forum, the AIoTAI, the IMT 2030, and Next Generation Mobile Networks, etc. So WWRF. So we are enrolling, and we are not only liaisons with these institutions worldwide, but also contributing to the IMT 2030 vision through the ITUR. We are, of course, as well liaison partner with ETSI. So many, you can find many networking opportunities and the liaisons to the proper institutions and companies and academia within 1.6G. In Bologna, Italy, in September, we are organizing our next summit, 1.6G Summit. Make plans to come. It's a huge event. It was in Valencia in September this last year, together with the PMRC, and now it is in Bologna, a very nice place as well for being visited. And okay, these are the dates. So save the date, book a hotel, and be there with us. Okay, and of course, join. You can contact us by email or through the web page. And as mentioned in the beginning, registering is very easy. You just go into the web page and declare your intention to be part of this association. And then the committee analyzes your proposal, because we need people that, of course, pretends to contribute somehow. And if that is very easy, you are accepted. Yeah. Thank you very much. This is 1.6G. Hopefully that we can enroll some of the Spanish, Valencian companies that are still not there in the next weeks. So, if our next speaker is ready, yes. Xueli An is the head of the 6G Network Architecture Research Group at Huawei Technologies in Munich. May I say that she's a very good friend of us already, of the I-team. She has been involved in many projects so far. I would highlight that he has been in the working group, the vice chair of the use cases and requirements of the 5G Alliance for Connected Industries and Automation, so the 5G Asia. She became also vice chair of the Enabling Technologies for Future Vertical Ecosystem Transformation in Network Europe. And as mentioned, she's in charge of the Dissemination and Communication Working Group of the 1.6G Association, and many other things in her biography that I have no time to read for you. But thank you very much, Xueli. Expert in networks architecture.
Yes.
Guessing, very interesting topic. Thank you very much.
Thank you very much. Okay, let me check the slides. Yeah, okay, thank you very much. So first of all, buenos dias. Thank you very much for the invitation. And I have to make my presentation in English, and hope you could follow me. And maybe next year I will try to improve my Spanish. Okay, about the 6G. So today my topic is about the agentic AI. So this figure, you already see it from Dr. Chong Wen's slides, but I want to tell you a story from the other side. Because from Huawei, we begin our research from 2017 and 2018. And then in 2021, we published the first white paper globally. And back then, we are working to define what is a 6G. And we have this vision. We want to use the 6G to connect the intelligence. But over the past few years, especially after 2021, and we all know the booming of the large language model and all these AGI topics really overwhelming our society. So even when my mom called me, and she even asked me, are you working on the generative AI? And did you try the DeepSeek models? And I was surprised, because at that moment, I realized AI is not only about a technology, it's a society phenomenon. So even people like my mom, they try to follow the talk, and they understand what it is about. I think this is really a big impact to the entire society. And meanwhile, as you know, 6G, we already went through this pre-standardization research. And at this year, we will kick off the standardization work from 3GPP. And then the questions we want to answer is, how can we really take the advantage of this promising speed of AI and then utilize it into the design of the 6G network? So for my talk, what I want to focus is about the AI agent part. In the early morning, David also shared his view on the 6G, and you could see like we have a common opinion. 6G will enable a lot of new use cases, which will bring the connectivities to the next level. But on the other side, what we want to emphasize is 6G is more than communication. So it means like we have this integrated communication and sensing. So you could sense the environment. You could do the environment models. This is also so-called the word model. And on the other side, you also have this native AI in mind. So this will be really the two killer features for the 6G. Then for my talk, so it's agentic AI-enabled core network. So it's short for A-core. So what is A-core? This is just really a high-level concept. So if I want to explain it in a short language, is A-core is a multi-agent system. So basically, this is the fundamental concept of A-core. And what they do is they take the intent from the vertical, from the UE, and from the over-the-top players. They take the intent, and such intent could be even based on the natural language. And then the multi-agent system will understand the intent, and based on the intent, they will do self-design, self-deployment, and even self-optimization of the whole system. So the services we provide is the so-called generative networks. So this is a new term for 6G. But if you work on 5G, you may be familiar with this network slicing concept. So you can think about that this will be the next step of network slicing in 6G domain. About the agent. So even though this is a very fancy term in nowadays, and especially many big companies, they say agent. So 2025 will be the first year of the agent era. So many companies in 2025 already gave a lot of solutions on the agent. But if we look into the history, so actually this is not a new concept. It's even traced back to more than 50 years ago. And people already have this idea, I want to design this autonomous system. But 50 years ago, it is only based on the simple policy and the rule-based. And they can only resolve a very simplified scenario. But during the time 1990s to the 2020, and actually due to the raising of this machine learning, actually agents become much more interesting. And then you see a lot of research work on the agent based on the reinforcement learning. But still, this agent doesn't really get a lot of intentions from the industry. So the reason is because if you want to get this award model trained, you need to get a lot of data, which actually we don't have. And then you also need to handle a very specific scenario. So this cannot be generalized. So the agent concept only become interesting after 2020, when the large language model come into the picture. And this actually brings the capability of agent to be general purpose. And they can also handle the multimodalities of different type of traffic. And then they can also do the self-reflection and self-evolving and so on. So what I do here is, because agent, if you just Google it online, a lot of articles and a lot of definitions. But if you want to utilize it in the telecommunication field, you need to make it very clear because you need to write it in the specification. You want to standardize it. So at this moment, we just take the general features of the agent. So for example, it should be an autonomous system which could self-planning, and then they can self-learning and self-evolving. And the most important thing is, I think they could be self-reflection. So actually, this is not easy, because you can always do the inference, you can do the training, but the system itself could realize what is not wrong, what is not okay, and what is the bottleneck, and the system itself could self-improvement. So this is a self-reflection, actually is not very easy to do. And the tool use, so this is actually a kind of like a new definition, which the old agent doesn't have. The reason they want to use this tool use is because we know this the foundation model, actually it's based on the inference. So you put some input, and then all the neurons are working, and then based on certain probabilities, you get the output. So this is the inference process. But for example, if I want to ask, what is the weather of Valencia today? I don't want to input the intent and then get the inference. Maybe I want to just call for the website to see what is the weather of Valencia to get a more accurate result. So this is actually indicate a new capability of this agentic system is it should be capable to understand the context and also capable to use the available tools. And then last but not least is this multi-agent collaboration, because this is actually important for the concept if you want to use the agent in a complicated system. So the reason we want to promote the multi-agent communication system is because if you have one agent, you must have a really big, gigantic model behind in order to do the right inference. But we all know it's very difficult to train a foundation model. And also, the inference time could be really long. So you don't want to say, I want to do a certain thing about my telecommunication system, but I have to wait 15 minutes. So this is what we don't want. So therefore, we think this kind of a multi-agent scenario suits better if your system has multiple domain and multiple different business scope. So for example, you may have an agent in the radio aspect, and you may have agent in the core network aspect, and so on. At this moment, what we are doing in Huawei is we propose like 4 different type of agent, but this is really we think the fundamental agents you must have in order to design your system. But it doesn't mean only 4. So if you say like if you want to bring to energy efficiency or sustainability, maybe you have a new agent. But this is really up to the scenario. But at this moment, we are researching this 4 type of agent. In order to make the agents work, it's not it's more than just define them. Because for the communication system, we also need to let them to work together with each other. So that is why we also have a certain component. So for example, you need to have a new interface. So what we call it is agent-based interface. And you need to also have the common components to support the, I think, can you hear me well? Okay, so you also need to have the common component in order to empower the operation of the agent. So that is our thinking, like in order to have the new design, you need to have this type of thinking in mind. Then we come with this multi-agent scenario, then we bring it to the core network. I think many of you working on the radio aspect, But if you come to the system, end-to-end system, you need to have the core network, you need to have the orchestration and the management layer and so on. So what I want to bring you here is the part about the network architecture. So the intent may come from the different type of users. So these users could be the customers from the operators, and could be even the UE, so what we call the consumer type of users. And then the different type of users, they can put their requirement, so in terms of intent. And then this intent will be digested, understood by the multi-agent system. And using this type of architecture, then you can generate these generative networks. So this is the type of service we will provide to the end user in the end. So this is really the fundamental concept of this A-core. So this, if you compare to what Dr. Truman is mentioned, so this is one of the direction we work in the research at this moment. Then about the agent. So I think this planning agent is one of the important ones because actually it is the one to take the intent of the user and then try to generate the solutions. So if you think about it in nowadays, I don't know how much you're familiar with the operator network service setup. Like, you may not even believe many of the work, even the design is done by the engineer, and then the configuration is done manually. So this is the current status. And especially if we take this way of working to the verticals, and we know like there are different type of the verticals and different type of requirement. Actually, this is very difficult to scaling up the business. So that is what we see, like this kind of a planning agent can resolve the problem. For example, at this moment in the lab, we can take some base model, for example, from Mixtra, from Llama, or from DeepSeek, no matter which model you have, and then you can put the input. And to be honest, for the current base model, already they have a really good way to generate this chain of thought. So if you don't believe, I really encourage you go back home and then try to download some model and input some telecommunication questions. The model will really surprise you. So of course, like there are a lot of science behind it. So as Dr. Tong mentioned, there could be chain of thought. And then other than the chain of thought, you can also have a multiple chain of thought, or even the graph of thought. And then based on the type of scenarios, you could really transform the intent to the subtask. But of course, this may not be sufficient because we know all these base models, they are trained based on the public internet data. And they may not have the specific knowledge of the telecommunication because operators will not put this as a public information. So what we also do in order to get a better model is you can get a base model and you can fine-tune it with the specific domain knowledge. So in this way, you can get a better inference of the chain of the thought. Another important is this assembly agent. So basically, this assembly agent, you can think about is to take the chain of the thought, so what is the output from the previous planning agent, and then map it to the actions. So this is what we call the chain of the actions. So in this way, this planning agent, actually they work with the toolbox to say, if I have a description of the task and what would be the right function I should get. This sounds actually very simple, like I have a description, but I just need to find the right tool. But if you really put this in practice, actually this is not that easy because you also need to have a certain domain knowledge. So for example, if I say I want to monitor the traffic according a certain area, so this is my natural language. But based on this intent, maybe the model need to understand if you want to model the traffic, you may need a sensing information. And then you may need the sensing network functions. So you see, like this is the way how they try to get a conclusion. I need sensing capabilities, and this should be one of the sub-functions in my network service. So for human, especially for engineer, this is very straightforward. But if you want to get a model to understand I need to transform a certain sentence to a task, and then from task to the function. So this is not straightforward. So you need to have a specific training of the models. And then, as I mentioned, after you're using the assembly agent, you transform from the chain of the thought to the chain of the actions, and then you will generate the plan of the network service. Afterwards, this assembly agent will work together with your connection agent and also the execution agent to deploy the service. So this is how the life cycle or workflow of this multi-agent system is working. Then another interesting concept is this generative networks. So as I mentioned to you before, so this is the next step to which will go beyond of network slicing. Because if you think of network slicing, it only contains the network functions. But in 6G, what we envision is the 6G is not only for the connectivities. So for this generative network services, you can also have the third-party applications. So for example, maybe we will have this V2X applications integrated with my generative network service, or I can have the motion control for the robot type of applications. So in this way, you can really bring this end-to-end from network service to the third-party applications and get the best results in order to support the application. So this is the idea of this generative networks. But being different from the network slicing is, if you're familiar with the 3GPP, you need to standardize all the network functions. You need to standardize the interface. You even need to standardize the procedures. But what we want to achieve here is we want to compose the tools, like the network function, we call it tools, which are selected from the toolbox. So you want to compose it based on the intent. So there must be a certain flexibility in terms of how you transmit the packets and then how your protocol may look like. So that is why we think this kind of service-based interface may be replaced by this agent-based interface. Memory. So this is also a new topic for 6G as well. You can think about database in 5G. But database in 5G actually has very limited functionalities. Like what the operator utilizes is to store the subscriber information. Like if you have a contract with Telefonica or Deutsche Telekom, and they will have your subscription information and also indicate what is the level of customers you are. So if you are the gold level, maybe you have a better quality of service and so on. But this is not sufficient. Because if we know, like in 6G, we will have a much more different type of data. Like if you have the sensing, you have a lot of sensing data. And maybe you have AI, you have a lot of model data. And if you have applications like V2X, digital twins, so it means like this data will be much, much broader and difficult to manage. So we take the concept of memory. So memory is also coming from this agentic domain. And then what they propose is they may have a different type of memory, like a short-term or long-term, and then you can even have the memory to self-involve. So it means like instead of only store the structured data, actually you can also store the knowledge, so which is kind of a distillation of your raw data, and then you generate the knowledge. And on the other side, this RAG concept, so retrieval augmented generation, is also very popular. So it means like instead of have the fixed content, my memory can also store the expertise of which is, for example, a record in the document, and then I can give you recommendations. So it means like when you try to search the database before, you always say, what is my input? You get exactly the same input. But from the memory, what you put the input, the memory will give you the answer. Actually, it's based on the information you stored and also the model, the type of model you have. So therefore, this is much powerful than a usual database. And then on the other side, because your agent is working and that generates the network solutions all the time, and it will also interact with the environment. So either the virtual world or the physical world. And then the environment interaction can give the feedback to the agent to say if your solution is good or not, because this is also very essential. Now, in this way, you could always update your memory, which could have your original plan to say, actually, you have some flaws in your design, then it can be self-improve all the time. So therefore, this kind of memory, what I said is go beyond of a database because this kind of like a self-involving capabilities. Then about the interface, I think if you are working on the standardization, this is one of the most important topic because companies go to the standardization, they try to standardize the interface because this is the most easy way to patent your ideas. For the 5G, on the left side, you can think about this is 5G. So 5G uses this service-based interface. The reason is because we have a service-based architecture. Because all the functions, they are defined in a way, like if you have a mobility management function, you have AMF. If you have a session management function, you have SMF, and so on. So this is a very typical way in the standardization to say, how should I standardize my function? And then how the function communicate with each other. This is the interface. Because in 5G, everything is deterministic. So it means like if I provide an input, I have exactly the same output. So if I have a message from AMF, then it will end up with SMF. So I have the exact IP address, even the port number of that functions in order to reach it. So on one way, this is very easy to specify the products. But on the other way, it means that it lacks of the flexibility. And one of the new research, what we are doing is we try to understand this agent-based interface. So for example, if I want to discuss with something with someone, maybe I will not say I only talk to A or I only talk to B, but based on my content, I can decide I should talk to A or B or even C. So this is actually provide a kind of like a flexibility in terms of communication. We think at this scope, this is still not fully understood by the industry at this moment. And it could be a lot of interesting idea behind it. Then overall, what is the change? So basically, I talk a lot of flavor of different enabling technologies. How do you design this multi-agent-based system? But importantly, what this system could bring to our customers. So for example, what this will make a difference for the operators. On the left side, it's a kind of very simplified model, but I think this really indicates what is happening in nowadays. We have our networks, and we have our functions. And then, of course, in 5G, we already have some functions that actually go beyond our communication. But it's very difficult to monetize. So the industry have an idea. They say, I make APIs. Because one of the most successful way from the OTTs, like if you work with Google, you may have a Google, like an API to get a Google map. Or maybe you have an API to get a YouTube video. So you don't have to deploy all the others. You just utilize these APIs. Then we think, oh, this is a really cool idea. And the business model is also very clear. Then actually, what the industry promotes is, I want to use this open API to expose the network capabilities. But somehow, this is still at a very early stage. And there's also no evidence to say this is very successful. The main reason is because of the ecosystem. Because if you want to have this API successful, you must have a very broad community and the developers to really work with these APIs. But for example, I don't know how many of you know, there's APIs for the 5G communication system. So what we want actually is another way. So in 6G, by using A-Core, is we want to bring the APPs into the communication system. So this is also the type of integrations we want to simplify for our customers. For example, in 5G, typical example is if you work for the Industry 4.0, you always say, how should I integrate Profinet with 5G or OPCOA with 5G? And there are a lot of discussions between different standardization organizations. And in the end, what you do is queues mapping. Like I need to understand when a traffic comes from the industrial domain, how this should be transmitted in a wireless. So this sounds simple, but like one topic could last 3 to 4 years in order to understand the different problem scope. But if we bring the applications into the system, and then we can try to help to shield this kind of integration complexities by these agentic models behind. So this actually will resolve for difficulties and also complexities for the third-party service providers. So this is actually we think is the real the new business values could be brought in by this A-core concept. Now about the use cases. So at this moment, we are working on many different type of use case, like the operator use case. So it means like how operator could utilize A-core to do the self-optimization. And then we also work on the vertical use cases. And we even work on the use cases on the, like UE could trigger the network service by itself. So, but as Dr. Tongwen mentioned, the limitation is the imagination. We do believe like if we give the sufficient capabilities in terms of AI and also ISAC, then we do believe this type of new use cases will emerging in the next decade. So therefore, I think if any of you have the good ideas, how can we utilize this kind of A-core to enable some new services? I think this is some areas we are interested to work together with partners. The last topic I want to share is about the standardization. Because I think many academic partners, they say, we do a lot of research, but it's very difficult to impact on the standardization. It's very difficult to impact the industry. But I will say it's not the case anymore, or it's not as difficult as you thought. So this is just one example I want to bring in. This is the work we do under SC. Within this SC ISG, we are working with industry partners and also academic partners in order to understand this agentic AI-based framework. And also UPV is one of the partners under this group. So basically, what we did in last year is we already defined the fundamental concept and also the reference architectures. This paper already published, so if you are interested, you could already get it online. Then for this year, our target is to have 2 new work items. So one is on the use cases and the requirement, because this topic already became important in the standardization group, and the operators, they want to understand like which kind of use cases and the new requirement could bring by this kind of design criteria. And the second one is about the multi-agent framework. So this is quite technical, because if we want to bring the new design philosophy, we need to understand all the technical details. So ETSI actually bring this kind of technology consensus opportunities for the industry players. So therefore, if you are working on the agentic AI-related topic, I would encourage you to join and then bring your academic research papers and then to share your opinion. And maybe this will be referenced by 3GPP later. Then it will generate its value in the next 3 to 5 years. Okay, so this also brings the end of my talk. This is a very short time, but this agentic AI-based network architecture design actually will touch more technical aspect in terms of model training and how to do the inference, and then how to do the communication and so on. And they also give the new challenges, for example, how do you do your control plane, how do you, if you need the new NAS or not, and then how you really bring your UE side to the radio side and then to your core network together. So therefore, I would say this is only the beginning point of this journey. And then we hope to work widely with all type of partners from the industry and academic. Thank you very much.
Do you have one? There is a microphone for her. I have one question as well while the microphone is coming. The experience that we have with some operators is that they are really having difficulties to implement and to make business out of the slicing.
Yeah.
Can we solve this situation with this AI-based model? So
Yeah.
will slices be easier to implement, softer to be developed, and then will be easier for the OpCos to do money out of it?
Yeah. I can just share one experience I have. During the 5G time, I work in GSMA. So this is one of the biggest organizations from operator side. And one project we did is how to define the slice template. So basically, after 2 years of a project, we get a template, I think over 150 different parameters, a really long list. And then we say we should bring this list to different partners and then to see how, if they could even understand it. And then we discuss with many vertical partners. They even say, oh, this is just even not possible to understand. Because for them, they say, I want to buy a 5G network, use a 5G network service, but I don't want to have a full team to understand 5G and operate 5G. So therefore, you see like this complexities to really bring the specific design of the network slice in order to satisfy the requirement. It's not straightforward. And especially in nowadays, if you have one slice, basically it's there all the time. You don't have any flexibilities of changing. So then it's a dilemma because at the very beginning we say when you have the slice, you want to bring the new business opportunities by the flexibility. But the flexibility is not there at this moment. So what we see, the beauty of this agentic AI is they shield this complexity by the inference. And then actually you reduce the barrier for the partners to utilize the communication system. So I would say this may be a way forward to bring slicing concept successful.
Okay.
Oh, yes, sure. Hi, thank you. As a user, we are still in the era of asking a question to an artificial agent and judging very carefully the answer, so you have to build trust. But so when I saw your slide about moving from imperative service-based interface to declarative, is that a full jump, or there are still safeguards behind and really an SBI interface behind the declarative? Because it seems scary to me to give so much responsibility to something that maybe not trustable, and who is going to safeguard that declarative interface?
Yeah, very, very interesting question. So if you think about, if I say one machine talks to the other machine, you need to specify the protocol. To say, if I say hello, you have to say hello. If I say, I want to deliver the packet to this IP, then you do it. There's no flexibility. But if you talk to me as a human to human, if we know the same language, then actually we can talk anything. We don't have to specify the format. We don't have to specify the rules. And then we understand each other based on the context. So this is actually what we think the communication could be different. So the flexible routing, flexible way of communication, this is definitely an interesting topic for the research because of AI. Right? Like, I think this is very different from the conventional routing problems. So therefore, I do agree with you. Like, it's a little bit scary because actually you really don't really understand how the packet may route. But on the other side, I want to point out is explainability. This is also important. So at this moment, a lot of research on the explainable AI is emerging. That is because if you want to utilize AI in a critical infrastructure, that you need to have a way to explain. So I would say a lot of topics actually are ongoing, but it still remain in the research domain. So that is why we are very open to cooperate with the research partners. And then we hope a big part of this research result will go to the standardizations in the next couple of years.
Thank you.
Okay, if you have any more question? If not, thank you very much, and we can. Thank you, Shirley.
Thank you.
So thank you. Yes, really, really impressive. Let me remind you that we have demos there in the demo area right there. If you want, you are curious to know. See, hey guys, say hello. Yes, that guy's over there. All right. So this friend of mine is the next speaker. He's the research director and head of the services as networks, not networks as services, at the CTTC in Barcelona. He has published a lot of papers, and he's in front of several 5G and 6G projects. I can tell you 6G large, 6G down, Plaza 6G, Anemone, etc., etc., etc. So he's a researcher now in cloud edge computing, telco cloud, network management, automation, orchestration, etc., etc. And he's Catalan. Nobody is perfect. Neither I do. Yes.
Okay. So the title of the talk, as you see, is on the way to AI native network management. So it's on the way. Narcís asked me to present, to give you examples, tangible examples of things that are already working somehow. So even if you see on the way, you will see some examples. And why we're here? Because we've been working in some projects, as you see from the logo soup there, in the past, now, and in the future, hopefully. And we do that as part of the work that we do in the Services as Networks research unit of CTTC, a research center in Barcelona. So we're going to talk, so in the Services as Networks research unit, what we do is service and network management, so kind of an architectural point of view. But most importantly, we are here because Narcís invited us. So thanks, Narcís, and the organization for inviting us, for having us here. It's always nice to come to Valencia in events organized by you. So, about tangibility of things. So what you see here is a poll. So as you know, the US and China, they are ahead of Europe. And this in particular was a poll, a survey of communication service providers in the US, most of them, not only, but most of them. And as you can see, the first way in which they are already currently using AI is for network operations. And as part of network operations, you're seeing how they split the work, right? So real-time network optimization, automated fault detection, predictive maintenance, and so on. So AI is already in place in production environments for different things. But network automation seems to be a promising place to apply AI already, right? So this is the first message. So it's already tangible. Now, why is it that everybody and all of us are talking about AI? I mean, David already explained it before, and we have seen all these triangles and so on. So because of the diversity and heterogeneity of requirements, so we've been dealing with these verticals and some more. So each of them have their own requirements. So that's one source of heterogeneity, complexity that we need to manage. The other one, and this comes from a simple example, well, relatively simple setup that we did in a project years ago, but even if it is simple, we were trying to, what you see at the top is the structure of the virtual service we were trying to deploy. You see two colors because it was a composite network service. So each box is a virtual network function, and the two colors were two sub-services as part of this complex service, right? The composite one. So that's from the service side. But we wanted to deploy it in two different administrative domains. So The line in the middle that you see separates two different administrative domains, two different operators, each one with its own policy and management and orchestration and so on. And below that management and orchestration stack, you have a physical infrastructure, which is heterogeneous also. So you may have optical networks, you may have wireless networks for transport and access. So there's a variability of environment. And this is a relatively simple example. But still, it's complex, right? So we tried to tame this complexity by defining some protocols that what we refer to as Network Service Federation, by which you could know the resources, and through the service offering of the other operator, you could deploy your own services in the infrastructure of the other operator. And once you deploy this virtual infrastructure, you need to be able to control end-to-end, like end-to-end meaning the cloud infrastructure, the transport infrastructure, talk to each switch, set up the Lambda, set up the Ethernet on top of the Lambda, you know, many things ongoing. So, and again, this was a relatively simple scenario, but you see the complexity, right? And this figure is also old, but I think it visually represents also, it talks about complexity also at the service level. This is from 2013. So what you see at the top is a Bing request, a request to the search engine of Microsoft. But what you see at the bottom is the response. And this was like what's going on at the cloud native level, right? With a relatively complex service, you may have as many as 10 hubs and 150 stages of processing, some of them in parallel. But you see that services themselves are networks already. So because this is service level, and that's why our group is called Service as Networks, because the service itself is becoming a network. So when you try to put this kind of complex services on top of the infrastructure that you saw before, like virtual infrastructure, physical infrastructure, and then you need some intelligence to do it in an efficient way, right? So you may have their own control loops in the services, their own control loops in the network, and then they may be conflicting. So how you tame all this complexity, this is the message I want to convey, right? So how do we try to tame this complexity? We've been working in the projects that you saw in the first slide, but I'm just giving you some keywords of the proof of concepts. So what you see here are the titles of proofs of concepts, meaning experimentally validated things. So because it's not just the concept, but we do test these things. And the important thing is, as we were requested by the ministry through these kinds of UNICO R&D projects, the goal was to create this ecosystem. Like so the private part was 70% of the project, right? So we sat down with these companies and we discussed with them what is it that you're interested in and so on. And this was the result. So the keywords that you see here, you will see some examples in a few slides, are the ones that we were dealing with. Also, of course, considering the inputs of the companies, what they see customers need, and so on. So zero touch appears there, as you see, open runs, how we handle the front haul, data-driven run optimization. You will see some examples. Second one is 6G Dawn. It's also a UNICO project. And same thing. The keywords there were, again, run optimization, but energy was fundamental in this project. So the question we were trying to answer was, what happens when you go to scale, right? So when you have a massive number of slices that you need to handle, each one with its own requirements, working on top of these kind of complex networks and heterogeneous networks. And yeah, we were considering things like security, resiliency. But let's move to the practical examples. So as part of the 6G Dome project, what we've been considering is also energy. Very simple examples, right? But we've done the more theoretical part, if you want, more complex one, considering fancy things at the simulation level, concept level, but we are trying to actually build it. And this comes from a demo paper we're presenting in a few months in Barcelona, in this conference here. So what we're setting up in the lab, or we have in the lab, is what you see. To very basic scenario where you have a coverage cell, a capacity cell, and we predict the traffic that users are going to generate in the cell, and then when we can, we switch off, basically. This saves energy, as David was mentioning before, so that's what we're doing here, right? We predict the traffic, simplest scenario, we switch off the cell, the capacity cell when we don't need it. Now, other things that we do at the RAN level is to be aware that there are different types of traffic in the network, different slices potentially. So you may want to generate models per slice. So this is what we did here, right? So since they are more or less similar, you have different kinds of traffic going through different kinds of slices, you may want to have different models per slice, and you may want to group the agents that you have distributed, the local agents that you may have in the G-Node Bs, specialized, so that overall, when you have a big network, all of them contribute to have a global model that you can use anywhere in the network, right? So this is what we were trying to do here, what we did, let's say. Again, over the testbed, right? And what you see here is the result. Well, the results presented in these demo papers and the other paper. Basically, we have local models, specialized, and in this case, the models, what they were doing was to allocate PRBs depending on the traffic that we were predicting this slice was going to generate. Each of the slices was going to generate, okay? So that was the goal of this setup. Now, as you saw, we presented examples, very specific ones. So the message is there are already tangible results. There are places where you can apply AI, but they tend to be quite specific, right? So the model you generate is specific for a problem, and you use it in a specific environments because you trained it in these environments. So, but when you try to take a look at the more end-to-end picture, things become a bit more complex because of all these complexities that we were mentioning before. So our definition of native AI means how do you manage intelligence or AI in a way, in a generic way, in the network so that you can solve and integrate it in the workflow of the service deployment or the lifecycle management of a service so that you can deploy it for any kind of service, for solving any kind of problem, because the same service may have multiple problems to solve. So what do we need to do to have such kind of intelligence, right? We took some steps in the past related that went a bit in this direction. This is somehow, again, a simple example of this vision. But what we were doing here, so we developed our own management and orchestration stack together with other partners like Networks, Polytechnic de Torino. This was done, by the way, in 5 Growth Project. which was led by Universidad Carlos III. So what we were doing here is, this was an HCNFV framework. So we took a network service descriptor, and in the network service descriptor, we specified not only the metrics that we wanted to monitor in the BNFs, but also we specified that we wanted to solve, in this case, for this demo, the scaling problem through AI. So what the system did is to place the service, to connect the boxes, like the BNFs that we just deployed. And then, once the service was deployed, we put the software to gather the metrics of interest for taking decisions. We fed them to the monitoring platform. We created a topic. The data was fed to this topic real time. We downloaded the model. In this case, it was a pre-trained model, line. We put it in the service orchestrator. We started feeding this model with real-time data, and then we started taking decisions on whether we needed to scale the service or not. So to deploy a new BNF next to the previous one because it was in bottleneck, and then we load balance, and we automatically connected with the rest of the service, right? So, as I said, this is a simple example for a specific service that we were deploying, but trying to go in the direction of being generic. But as you can imagine, doing this for any kind of service, for any kind of problem, well, then maybe we need agent-based interfaces or whatever, right? So this is what we are taking a look at in a more generic way, right? Now, in a simpler scenario, going end-to-end, this is an example that we did in 6G Dawn together with Ericsson and Telcaria. So Ericsson was leading this scenario. The nice thing about this scenario is that it somehow simplifies the environment. It's not a super generic scenario. It's an MPN scenario. So it's more or less under control. But the nice thing is that it is end-to-end. So it has this global view. And what they did, what we did together, because this flight rack that you see there is at the CTTC premises, and in Madrid they have the communication service provider side of the story, right? So in our lab, we are sort of the enterprise factory, if you want. In Madrid, they have this core part, including the 5G core and the digital twin. And then the nice thing they did was to modify these APIs so that they exposed a series of things. One is analytics, to know what's going on in the network, but not only that, they were capable of recommending configurations. Okay, so based on what the digital twin was telling them, that they were able to predict, for example, based on previous measurements and so on, what was going to be the energy consumed in a certain scenario when you have a certain kind of traffic, or the throughput you would get, or the latency you would get, right? So this was the job of the digital twin. So you could ask the digital twin to recommend your configuration. And not only that, but then it enforced the configuration of the network, right? So they modified this sort of a standard 3GPP NEF interface so that you could also apply the configurations. And this was the sequence of events. So you had a configuration with a certain bandwidth in this case. Traffic changed, for example. And based on this traffic, you ask through these APIs that the digital twin tells you and gives you a list, a ranked list of configurations that will fulfill your requirements but will consume less. And once you decide, in this case, we were assuming manual operation, but it could be more or less automated as long as you trust in the system. In the end, you decide what configuration you want based on your interest, and then you apply it through the interfaces, right? So this goes a bit in the direction of having this end-to-end view application of AI in a real production environment, because as I said, this comes from the interest of Ericsson, right? Now, another thing that we didn't talk much about is that when you give such relevance to AI, can I trust AI? So then we asked this question, and we tried to go in the direction of what do we do to trust what AI is telling us. So we took one of the frameworks that you saw before, like a federated learning environment where you had multiple agents distributed and so on, and we tried to put a trust layer in the middle. So we generated kind of a reputation system between the agents, because there may be malicious agents that want to, make your life complex and so on. So we designed a series of smart contracts, but the basic idea here is based, for example, on the normalized mean square error of each of the local models. You assign a reputation score to these models, and in the end, you just select the good ones so that you can train your model based on that, right? So that's another thing that we should somehow do. If we want native AI, it should be trustful, right? So that's the other thing we did, and again, experimentally in the project. So what's next? What are we trying to do in this project that you see here in Unity 6G? Put all these pieces together in a single architecture. And as you see, it's a complex architecture. It's heterogeneous because in addition of what I mentioned before, we have the link with the energy sources. We have satellite, so which makes the environment even more heterogeneous. So this end-to-end side of the story makes also things complex. Of course, we have the cloud, we have open runs, and so on. But as you see at the top, as part of one of the two sublayers of the management orchestration, we have the intelligence. And where should intelligence go? So based on our experience and so on, we're going to apply decentralized intelligence. We're also taking a look at this work that Etsy and I is doing on the agentic side of the story. And we'll try to integrate also with digital twins to exploit this intelligence. So hopefully, I somehow convinced you that AI is more or less mature, and it can be applied already, and it's being applied, as you saw in the first slide, in some production environments. But luckily enough, since we are researchers, there is still a lot of work ahead, right? Thank you.
Thank you very much, Josep. Questions? Yes, Lydia.
Hi, Josep.
Hi.
I've seen you've been talking quite a lot about Open Run.
Mm-hmm.
In your view, what is the role that in general is going to play Open Run in the deployment of 6G? Only Open Run? Combine single run and Open Run architecture?
Well, that's a good question. So meaning that when you start with that's a good question is that I don't have the answer. So the point is, I would, because the overall philosophy of Open Run is that in theory you should allow vendors to interoperate and so on. But in the end, what you see in reality is that this is not happening, because in the end, to make things interoperate with the specific options and so on, you need more or less the same ecosystem, like the same vendor and so on. But if this philosophy in the end works, nice thing is that in theory, you're making cheaper deployments, right? Because you're just putting the RU next to the users. And one of the things I didn't mention because I didn't have time, but one of the things that we're doing together with Telefonica is to see how far you can go to the middle of the network with the rest of the system, right? Because if you centralize, you can be more efficient in managing many different things. So if this Open RAN vision is finally realized and we do have interoperability, I do believe it's a valid option because it will make things cheaper, particularly on the RAN. And when you have considerations like energy, as the RAN is one of the, the most consuming part. So if you can reduce the complexity there, that will help a lot. So yeah, if we realize this vision, I think it will have a relevant role, sure.
Thank you.
Any other question? No? Okay. Thank you anyway. Giuseppe stays with us for the rest of the day, right?
Yes.
So you can approach him on any question. Thank you very much. Thanks, Giuseppe. I am neither perfect, you know. Yo también soy catalán, digo. So now we move to the last part of the session this morning, which is this panel discussion. So now we are going to use all these facilities that you see here. So I will ask first Karina Victoria from Cámara de Comercio Valencia. She's the responsible of the digital business unit in Cámara de Comercio. Cámara de Comercio es a corporation, es una, cambio al castellano, es una corporación que colabora con las administraciones públicas para la creación de empresas, para el asesoramiento a esas empresas, para la formación, la internacionalización, entre otras cosas, y seguro que me corregirás, porque seguro que hacéis muchas otras cosas. Somehow she represents this industry corporation, so the panel pretends to have some insights that are useful for the industries. So,
thank you so much,
let you the floor, Karina. Thank you very much.
Thank you so much. Well, good morning, everyone. And, well, at this time, it's better to say good afternoon. And welcome to this exciting business roundtable, where we discuss about the trending topic of the year, the artificial intelligence. And that is because the AI technology is disrupting in our life, such as the internet in the 18th and mobile phone in 19 years. But how AI is transforming communication, network, and 5G and 6G? To focus on this, let me introduce our wonderful panelists. Welcome, Lidia Alcalde, Product Strategy and Planning Engineer at Vodafone Group. Welcome. Good morning, Vicent Soler, Co-founder and Chief Executive Officer at Kenmay. It's a pleasure to have you here, David López, Distinguished Researcher at Universitat Politécnica de Valencia. And thank you so much, Xueli An, Head of 6G Network Architecture and Verticals Research Group at Huawei Technologies. So welcome, guys. We are very excited to know more things about how AI is transforming 5 and 6G communication network. And before we begin, I would like to mention that this roundtable, this business roundtable, is bilingual, so there will be moments that we speak in Spanish and the others will be speaking in English. And the other thing is, in this roundtable, we are going to try to answer 3 general questions. The first question is how AI is trying to solve 5 and 6G network communication. The second question is how Europe can be a good competitor or these technologies. And last one is how we can reduce the energy consumption. So let's go. Ahora sí que me paso al castellano. Nada, Lidia, voy a empezar por ti porque bueno, estamos viendo que Vodafone está apostando muy fuertemente por el tema de la inteligencia artificial en lo que son las redes, de la gestión de redes. De inteligencia artificial se habla mucho, pero ¿nos puedes decir un poco, ¿no? ¿Nos puedes dar esos tips de qué es lo que está haciendo o qué es lo que aporta la inteligencia artificial a las redes móviles y cómo lo estáis aplicando, los casos de usos que tenéis allí en Vodafone?
Vale, pues empezamos con 5G, que es la red que actualmente está desplegada. La inteligencia artificial no está desplegada todavía, pero sí que se está empezando a trabajar. Y el objetivo principal es mejorar la optimización del performance de la red y su eficiencia. Líneas en las que se está trabajando. La primera es la optimización de los recursos. Lo ha comentado Javier, en estos momentos la red es muy compleja. Tenemos tecnologías 2G, 3G, 4G, dentro de cada una varias bandas. Y el hacer, por ejemplo, un correcto balanceo del tráfico y de la carga para que cada cliente esté en la mejor capa que tiene que estar, eso va a tener una repercusión muy importante en su calidad de red, por ejemplo, en la velocidad de transmisión. Otro aspecto en el que se está trabajando es en la operación de la red. Si yo soy capaz de tener algoritmos de predicción de averías o herramientas de ayuda como las que acaba de explicar Javier, en la que me va a ayudar a resolver esa avería más rápido con toda la información que ya se tiene sobre las redes, eso va a desembocar en una mayor disponibilidad de la red, que es un claro beneficio al cliente. Y la tercera, que tampoco es original, es la optimización del consumo de potencia. Si yo soy capaz de predecir el tráfico y la red es capaz de una forma inteligente de apagar las celdas, como comentaba Mavi, estamos ahorrando muchísima energía. Eso se puede hacer de una forma programada. Por la noche apago capas, se ha hecho así ya muchos años y estoy ahorrando, pero si se hace de forma inteligente va a ser mucho más eficiente. Esa sería una línea en la que se beneficia más al operador que al cliente y, por supuesto, al planeta. Y luego en 6G el tema ya cambia y la inteligencia artificial no va a ayudar a la red, sino que está metida en la red y lo que va a generar son nuevos casos de usos y nuevos servicios al cliente.
¿Y allí en Vodafone cómo lo estáis aplicando? ¿Tenéis algún caso de uso?
Esos tres que te he dicho son POCs que se están haciendo. Por ejemplo, el de energía pues está trabajando. Son ya casos reales que se están haciendo.
Reales.
Trials, sí.
Vale. Y hablando de operadores, que también lo has comentado, Vicent, vosotros que sois expertos, ¿no?, en ayudar a estos operadores, ¿cuáles son esos problemas que está resolviendo la inteligencia artificial en este caso?
Bueno, los operadores vemos diferentes ámbitos de aplicación de la IA, ¿no? Uno de ellos es el Customer Experience. Se busca sobre todo retener al cliente, que en un cliente no se cambie de operador para no perder ingresos. Ahí lo que se intenta es correlar parámetros técnicos de la red, como pueden ser las caídas, el establecimiento, el throughput que comentaba hace un momento Lidia, con la experiencia que percibe cada usuario, de forma que se intenta retener a ese cliente, de forma que cuando vemos algún tipo de deficiencia en cuanto a la experiencia de usuario, se invierte en ese caso para arreglarlo, ¿no? Y la segunda gran parte, que nos ha dicho hace un momento Lidia, también Javi, ¿no?, es el Network Automation, ¿no?, la automatización de procesos de red, que así como el anterior buscaba mantener ingresos o retener ingresos, este Network Automation lo que busca es reducir costes. Al final, las redes cada vez son más complejas, hay cada vez más tecnología, más portadoras, a veces hay incluso menos gente en los operadores que antes a nivel técnico, con lo cual requiere una automatización de la gestión de las redes, porque si no, no somos capaces de abordar el día a día, ¿no? Y hay casos de uso, bueno, que hemos comentado anteriormente, pues de ahorro de energía, casos de uso de detección de anomalías y clusterización para identificar el root cause, detección de interferencias externas. Bueno, hay un montón de casuística que, bueno, que al día a día el operador pues le ayuda al ingeniero pues a ser más eficiente en su trabajo. Bueno, entonces, digo, básicamente dos líneas, ¿no? Reducir costes y mantener ingresos a nivel de cliente, con lo cual, como veis, buscando eficiencia económica también, ¿no? Obviamente.
Reducir costes para que luego no repercuta al consumidor final en
Bueno,
este
de hecho,
caso.
cada vez, si veis un poco lo que ha ocurrido en el sector teleco, los precios han bajado. O sea, que realmente justo es un sector que los precios han ido bajando, con lo cual lo que se busca es pues, mantener de alguna forma la rentabilidad del negocio.
Interesante, interesante. David, you are a researcher, so from your perspective, will AI open the door for new cellular network paradigms? And will we see some of those new concepts in 6G? It doesn't matter. Lo que quiera.
en microsegundos, no en minutos, no en horas. Y ese será el cambio, creo, más absoluto de los últimos 20 años en redes. Pero bueno, no sé si lo conseguiremos con el 6G, quizá con el 7G.
O lo mejor sí, la tecnología avanza tan rápido que posiblemente lo podamos ver, ¿no?
No soy muy optimista, pero se necesita tiempo.
Bueno.
Pero vamos hacia ello.
Perfecto, pues muchas gracias. Xueli, Huawei is a big company and it operates globally. Do you think that Europe is a good competitor of China or USA? And do you think so? And what could we improve? That is a good news for us. Thank you so much. Lidia, volvemos contigo porque, como había dicho Xueli, pues bueno, ellos quieren colaborar, están intentando hacer colaboraciones para venir hacia Europa y demás. Entonces, vosotros, Vodafone, tenéis mucha presencia a nivel europeo y sabéis bastante el tema de los retos locales. ¿Qué acciones crees o alianzas que serían clave para, de alguna manera, fortalecer nuestro ecosistema, ¿no? Y que no tuviésemos que depender tecnológicamente de, pues como hemos dicho, de grandes continentes o de grandes países como China y Estados Unidos?
Pues evidentemente es un problema que no es nuevo, ¿eh? Mira, voy a dar un dato. Cuando empieza la telefonía móvil, en los años 90, llega a haber en un momento dado 20 suministradores de red. Hace 5 años, desde hace ese tiempo, estamos ya con 4 para todas las redes, Europa, Asia y Estados Unidos. Entonces, Vodafone sí que tuvo clara la decisión y es apostar por el Open RAN. El Open RAN son las redes abiertas, de forma que tienen mucha más flexibilidad y el operador es capaz de elegir distintos suministradores de hardware y software. Esto en estos momentos, hasta este momento, no ocurría. El Open RAN se basa... Claro, esto no es fácil. Se basa, es una nueva arquitectura y se basa en la virtualización, en la desagregación de equipos, o sea, lo que hasta ahora era una estructura muy clara, que era la banda base, la unidad radio y la antena, eso se va a dividir en muchos más elementos. Se va a hacer una estandarización muy importante de los interfaces y de qué tiene que hacer cada elemento. Se van a virtualizar los equipos, eso quiere decir, yo ya no necesito un hardware específico de un suministrador, sino que voy a separar el hardware y el software. En un servidor normal puedo meter un software que va a realizar todas las funciones. Y al final lo que tenemos es una red mucho más flexible y en la que se ha dado cabida a muchísimos más suministradores, que cada uno va a hacer una parte. Va a haber de software, bueno, ya hay, esto ya es una realidad. ¿Vale? Esa es una estrategia clara y la otra es la innovación. Si todos recordamos, después de la pandemia, en el que se paralizaron los procesos de producción, aparte viene el bloqueo del barco en Suez, con lo cual se colapsa el mundo del transporte y hubo una crisis de componentes. Entonces Vodafone decide, bueno, y a mí lo que me hace falta son los chipsets, ¿por qué no los hacemos nosotros?
Muy bien.
Es arriesgado, ¿eh? Pero se estableció el Centro de Innovación de Málaga. Ahí se ha hecho un hub en el que se están desarrollando chipsets. Se ha creado un entorno de innovación para que entren muchas más empresas de inteligencia artificial, de desarrollo de software, de muchas competencias. Y hay una alianza clave, que son las universidades. En ese caso se está trabajando mucho con la Universidad de Málaga. Vodafone trabaja con la Universidad Politécnica de Valencia, con la Complutense, con otras universidades europeas. Y la tercera patita es la financiación.
Que todos buscamos financiación.
Sí, bueno, las entidades gubernamentales y el apoyo de las mismas, sobre todo en la financiación. O sea, que esas son las estrategias para intentar no tener esas dependencias que las hay.
Claro, la verdad es que el tema de la financiación es lo que decíamos, es es una de las patas bastante importantes para que podamos conseguir desarrollarlo desde aquí.
Son las tres. Esa es clave, la investigación que aportan las universidades es muy importante y la empresa tiene que estar ahí.
Claro. Y como os he hablado de las universidades, vuelvo a David, porque aparte, bueno, tú formas parte del equipo de iTeam, ¿no? Claro, hemos hablado de las alianzas con Lidia, pero en tu caso, tú que estás en el día a día de las universidades, aquí ¿qué papel juega ese talento universitario y también de alguna manera las formaciones para que todo eso, ¿no? Todo lo que hemos estado diciendo de los chips, etcétera, toda esa tecnología se puede desarrollar aquí mismo? La verdad es que sí, es interesante porque a veces no, en la gran mayoría de casos, los otros países pueden desarrollar este tipo de tecnologías porque tienen más inversión y al final sale que la persona o el talento es español en muchas de esas veces. Y bueno, eso nos hace pensar, ¿no?, de que tal vez pues, nosotros aquí tengamos que invertir más. Esperemos que nos escuchen y que puedan invertir más. Así que nada, muchas gracias, David. Os voy a hacer una pregunta que es para todos. Igual bueno, podéis responder en castellano o en inglés o en valenciano también, porque como estamos en Valencia, lo que queráis. Os voy a pedir que me resumáis en pocas palabras cuál es el principal obstáculo hoy para que la IA, ¿no?, en redes llegue a todas las empresas. Yo creo que, claro, tengo uno, que es el tema de la financiación y de los costes, podríamos decir, pero ¿me podríais decir algunos más retos? No sé.
Bueno, en nuestro caso, ¿funciona? Sí, ¿no? En nuestro caso vemos que lo que decía un poco Javi, ¿no? El hecho de que los datos no están disponibles. O sea, estamos viendo todavía que hay datos que pertenecen a un departamento, que ese departamento maneja ese dato, que está en un cloud, que luego tienes que mover otro cloud, y eso tiene un coste, y al final vemos un montón de silos a nivel de datos. Si no hay datos, no hay IA. O sea, no data, no hay AI. Es lo que hay, o sea, es la verdad. Entonces, claro, si tú tienes un histórico bueno, un acceso al dato, no vas a poder montar ningún tipo de algoritmo, ningún tipo de lógica que te funcione de forma autónoma y de forma automática. Entonces, para nosotros el dato es fundamental.
No sé, Shuley? Shuley.
Yeah, if I understand correctly, this is about the challenge. Yes. So I would say, first, challenge also comes with opportunities. And I think this is very essential for operators because for operator provide connectivity for decades, right? It just transport bits from point A to point B. But I think 6G, when AI come to the pictures, actually it become more interesting. As in my talk, as I mentioned, there could be a or game-changing moment, like operator could have some new business enabled by AI. So, for example, I think in Europe, this data locality is very important. This is also gave a kind of benefits for the operators to think about how to use operator platform to host the third-party applications, especially the service provider that do not have any computing resource in Europe. And this could be a very good business opportunity. Then on the other side, from research, we do believe like AI will be deeply integrated or even become the key component of the 6G infrastructure. So it means as operator may have the opportunity to provide AI as a service, right? So I think these are just some flavors of what we see, which is different from the previous generation. But of course, the challenge is this is a big mindset changing because from all the generations, we get used to the way how we define the standards and how we make the products. Actually, we never have a big impact from the other sectors. But the AI, it comes so big and so fast. Every 2-3 months, you see a new model announced. And then every 2-3 months, new applications, new startups emerging. And then maybe the models come from Asia, from US. And actually, we are overwhelmed by all these AI things. But then the question is, how can we really take AI as a kind of engine? Because if we build a car, you can take a very powerful engine, and then you can build a powerful car. If you don't have a powerful engine, then probably you don't have good products. So I would see like a challenge goes along with opportunities. And then for this one, we need the people to be open-minded to see what would be the potential new innovations that may exist, and then also the new use cases. So no need to mention, like I think many of you went to MWC this year. Then there's some terminal like AI phone or the AI glasses. I think this type of new gadgets will definitely appear in the coming years, and that might be also the trigger of the new services and also new infrastructures.
Wow, that's interesting. Thank you so much. Lidia?
Si la pregunta es la introducción de de la inteligencia artificial en las redes en una empresa más pequeña, en estos momentos lo que veo es que va a venir de la mano del operador, ¿no? O sea, de la red del operador. Y luego sí, lo veo a medio plazo, y así que será con los nuevos casos que van a tener una oportunidad de desarrollar cosas muy, muy específicas, pero eso sí que necesitamos un poquito de paciencia hasta que llegue.
Que no tenemos
Estamos hablando del 2030.
Ostras, vale, sí. Que no tenemos la gente paciencia nunca, siempre lo queremos todo para allá. David.
Si yo fuera una pequeña mediana empresa, creo que lo primero que pensaría es acerca del dato. ¿Qué tipo de dato tengo? ¿Tengo el dato? ¿Lo tengo bien estructurado? Si no, ni me lo planteo. Si lo tengo y lo tengo estructurado, ¿qué puedo hacer con el dato? ¿Tengo problemas de privacidad? Porque si tengo problemas de privacidad, el procesamiento tiene que ser local y necesito una inversión en GPUs para crear el modelo fundacional en casa, y eso vale dinero. Entonces, me haría preguntas en dirección aquí a los compañeros del dato. Si tengo una dirección, sí puedo, iría por él. O sea, quiero decir, si el dato está en las condiciones se dan, el beneficio creo que va a estar ahí en optimización del negocio.
Yo creo que aquí igual, perdona que te corte, David, bueno, continúa.
No, he acabado.
Creo que aquí el problema que también se puede ver no es que cuando sale alguna novedad o vemos algo que está impactando muy fuertemente, como el tema de la inteligencia artificial y demás, que es como que todas las empresas nos echamos encima, lo quiero, o sea, voy tarde, ¿no? Y de alguna manera no somos capaces, ¿no? O tenemos que entender que antes de aplicar ese tipo de tecnología y demás, tenemos que ver cómo está nuestra empresa para poder aplicarla más eficientemente, ¿no?
Una buena empresa siempre tiene una buena directiva que hace buenos juicios dónde invertir su dinero. Si eso no está ahí, la empresa va a quebrar antes o después. Aquí necesitamos este análisis técnico y creo que el dato sigue siendo fundamental. Beneficios por la optimización van a estar ahí. Ahora tienes que ver cuánto te cuesta, cuánto gano. Pero bueno, son decisiones a tomar.
Bueno, pues de este bloque, ¿no?, extraemos un poco que, pues eso, lo importante es el dato, es muy importante, pues bueno, tenerlo todo organizado y demás. Vamos a pasar al último bloque, que es algo que sí que nos está, pues, dando dolores de cabeza, ¿no? Y es que con esto del desarrollo tecnológico también nos viene la problemática del tema de la eficiencia energética, el consumo energético, la sostenibilidad, etcétera. Y vengo aquí de nuevo, Lidia. Quería hacerte la pregunta de qué es lo que estáis haciendo, ¿no?, en este caso en Vodafone, para reducir este tipo de problemática en las redes inteligentes y bueno, las técnicas que estáis aplicando.
Sí, a ver, es obvio, ¿no? El impacto que tiene el consumo de energía en las redes es muy elevado. Se calcula que es un 25% del coste económico total del gasto de la red, de una red de telefonía móvil. El 25% va a pagar las facturas de la luz, que es mucho. Y claro, se están haciendo muchos esfuerzos para el ahorro económico y porque esto ha de ser sostenible, ¿no? Lo decíamos al principio, una red si no es sostenible no va a ningún sitio. Cosas concretas, pues se están aplicando ya muchas funcionalidades. Esto es un problema que ya se ha analizado. El 3GPP ya en las releases que están ahora desplegadas definió muchas funcionalidades de ahorro de batería que se llaman cell sleep, sleep dormancy, o sea, para que entendáis, lo que hacen es apagar las celdas cuando no hacen falta. La otra técnica que se está usando es lo que ya hemos dicho, utilizar algoritmo de predicción para poder realizar este apagado de celda de una forma inteligente y dinámica, que de verdad no afecte al cliente. Esto es, por ejemplo, nosotros estamos trabajando más en Open RAN porque es un entorno más fácil para nosotros. Y luego se está trabajando mucho con los vendors para optimizar el producto. A raíz de una pregunta de Mavi, el doctor Tong ha contestado que la forma de transmitir dentro de, en la red todos los datos consume mucha energía y hay margen de optimizar eso. Entonces, nosotros como operador, lo que estamos haciendo es evaluarlos. Nosotros tenemos Vodafone tiene en España un entorno de pruebas de red real que llamamos en Ciudad Real, en el que se han instalado todos los equipos con los que trabajamos de los operadores, se hacen pruebas de performance, pero ahora hemos introducido el de medir la energía. Se mide en la radio, se mide en la Massive MIMO y se mide en la banda base. Se miden con carga, sin carga, activando sus funcionalidades de todos los operadores y luego eso se lo enseñamos. Se lo enseñamos de una forma anonimizada porque no es elegante decirle este consume más que este, pero si le decimos este eres tú, este es tu consumo y este está aquí. Y eso funciona. Primero, le demuestra a los otros vendors o suministradores que se puede llegar más allá y segundo, saben que su producto no es el mejor y eso está funcionando muy bien.
Parece que estamos concienciados, ¿no?
Sí, eso es así. Y luego hay un segundo campo que no suele salir mucho, pero que a mí me gusta, que es los esfuerzos que hacen los operadores introduciendo funcionalidades para el ahorro de batería del usuario. O sea, el teléfono hoy por hoy ha evolucionado mucho, tiene una capacidad de cálculo, tiene pantalla enorme y eso consume mucho y las baterías de los terminales no han evolucionado. No, lo único que hacemos es que cada vez que tengo un móvil hace más cosas y me dura menos la batería. Entonces ahí también hay un trabajo del 3GPP, de los vendors, de terminales, de los operadores en las redes, para meter funcionalidades en las que se reduzca ese consumo.
Muy bien. Sí, la verdad os lo agradeceremos. Nos lo agradeceremos mucho. Gracias, Lidia. Xueli, from Huawei's experience, what global technological strategies are being used to balance performance and energy efficiency?
Yeah. So the sustainability is one of the important pillars when we work on the 6G from day zero. And of course, like the most efficient, like you can have the efficient way to design the base station, and you have the algorithm to do the resource scheduling and so on. So these are the fundamental research we are doing, and then we hope this could also be bring into the to the standardization. So this will become the reality. Then on the other side, we also contribute to European funded projects as well. So we have one project on this sustainability, and then we do hope this kind of collaboration among the European partners could come to a really good solution. And from Huawei side, we are very experienced in terms of bring proposals to the standardization. So we hope we can work together with all the European partners. Then on the other side, definitely performance is important because we, on one side, we have this URLC, for example, you need to also support the maximum huge amount of connectivities, and then of course we say we don't want to really compromise on the performance in order to do the energy efficiency. So therefore, I think this kind of intelligent algorithms are very important, and also the new design. And on the other side, I think the new type of material would also play a role in 6G, and then this will give a more efficient way to transmit signals and so on. Another way we see is how to really optimize, because on one thing is how you save the energy, on the other thing is how do you really optimize the functionality of your system, and then to make it the best investment and return. So for example, this kind of ISAC features, you use a certain amount of resource to do the sensing, and this is actually kind of a new features for the communication system. And then this may really contribute to this vision of to bring a kind of like environmental digital twinning of the whole cities, then you can empower many, many different vertical applications on top, no matter factory automation or the V2X. So this will give you a kind of like a new revenue to think about. So therefore, I would say like there are still a lot of space to explore. And then overall, all this data and then technology will end up in one platform. This will, we hope this will be the 6G platform and then operated by the operators.
Thank you so much. Vicent, bueno, hemos estado hablando antes del tema de la financiación, que ha salido que se necesita mucha financiación, etcétera, etcétera, porque aparte de todo eso, la tecnología también es cara. Entonces, ¿tú piensas que las operadoras están hoy en día preparadas para asumir esos costes, ¿no?, de lo que es la implementación de la inteligencia artificial?
Pues te diría que sí, siempre y cuando tenga un beneficio para ellos. Es decir, yo recuerdo haber ido hace 7 o 8 años a varios operadores con la IA por delante. Me decían, otro que viene con la IA, pero esto a mí, ¿en qué me ahorra? O sea, esto, Lidia se ríe porque no lo sabe, ¿no? O sea, al final, yo les he listo para invertir en aquello que le dé un retorno de inversión. Bueno, se ha hecho aquí un par de veces ya, ¿no?, la palabra retorno de inversión. Y para mí la IA no es un fin, es un medio. Y yo creo que a veces se confunde en poner la IA como un fin, cuando realmente yo lo uso la IA para mejorar o bien un proceso, de forma que el resultado sea mejor. Mejor me refiero no a un 5%, sino a un 50 o 60%, un salto realmente cualitativo en cuanto a resultados, y el proceso en sí me suponga un ahorro de costes notable, porque si no tampoco voy a cambiar. ¿Y por qué lo digo? Porque al final el riesgo de cambiar un proceso está en curso funcionando con 4 if-thens o con 4 sistemas expertos que funcionan y que está implantado, lleva años y funciona perfectamente, cuando tú tienes una solución de IA y no está clara que realmente esa solución sea capaz de reemplazar ese proceso, entran siempre las dudas y no van a invertir, aunque tengas IA. O sea, al final la IA para mí, como decía, es un medio y no es un fin. Luego sí que estamos viendo inversiones estratégicas ya de estructura de datos. Ya vemos el rol del Chief Data Officer en algunos operadores, de forma que ya saben que el dato es fundamental, con sus data engineers, con su gobernanza del dato. Eso Vodafone ya hace mucho tiempo que lo lleva implantado, y vemos una tendencia a tener el dato disponible porque van viendo a futuro la necesidad de montar múltiples casos de uso con IA sobre los datos, ¿no? Y luego también vemos una minusvaloración de la especialidad técnica que requieres para explotar el dato. O sea, muchas veces aquí, yo recuerdo haber ido hace mucho tiempo a un operador y me decía, tenemos 200 data scientists y no tengo ningún caso de uso de ingeniería, no tengo nada. Y la pregunta es ¿por qué? Pues porque realmente se tiende un poco a pensar que cualquier matemático que viene a una carrera, que tiene mucho expertise en Machine Learning, le das un dato de energía de 25 contadores, de datos de Select Mode, de Memory Mode y demás, y crees que va a montarte un caso de uso que el ingeniero, en este caso a gente como Lidia, pues le dé valor. Y la verdad es que no. O sea, al final yo he visto casos donde pues, data scientists pues, muy conocedores de Machine Learning te están montando un caso de uso de cobertura sobre uno entero, que es el enumerado que viene el RSRP, que convertirlo a DPMs. O sea, yo creo que al final hay que ser conscientes de que la IA sin datos no funciona, pero tampoco sin expertise y sin dominio técnico. O sea, ahí es donde KenMei aporta valor, porque si no realmente, claro, la IA, pensamos que el ChatGPT va a hacerlo todo, no, requiere una capa de especialización y es donde empresas como KenMei pues, van a aportar valor. Con lo cual, bueno, la respuesta es, ¿están dispuestos a invertir? Sí, siempre y cuando le suponga un salto cualitativo en cuanto a resultados y le suponga un retorno de inversión notable. Si no, pues no van a invertir, por muy bonito que sea el algoritmo y por mucho que uses el IA.
La clave está en educarlos también y evangelizarlos en este
Bueno, es lo que haríamos todos, ¿no? Al final, si tuviéramos aquí 1.000 millones de euros, pues sí que haríamos experimentos, ¿no?
Claro.
Pero claro, realmente pues, el dinero es limitado.
Muchas gracias, Vicent. Y nada, me queda una última preguntita a David, y era preguntarte simplemente que aquí cuál es el papel que juega lo que es la investigación y el desarrollo, ¿no?, local en todo el tema de la eficiencia energética.
Local no lo sé, pero he tenido la suerte de trabajar en eficiencia energética en Huawei por alrededor de 3 años. Y para mí el problema fundamental es el hardware, y necesitamos nuevo hardware cada vez más eficientes, nuevos chipsets, mayor integración, chips más pequeños, consumirán menos, y para eso necesitamos estudiar más, investigar más.
¿Más fondos?
Y más fondos, más development. Es verdad que ahora nos estamos trayendo a Europa alguna chip development, como Lidia estaba mencionando. O sea, ahí hay una
creo que es el mejor camino para reducir el consumo, investigar en nuevo hardware y en nuevos chips. Luego todo el tema de la funcionalidad de apagado de celdas y demás. Creo que es muy importante, pero las ganancias están limitadas por cómo entendemos el paradigma de apagado de celdas. Te doy un ejemplo. Por ejemplo, el paradigma actual es que tú tienes que definir una capa de cobertura que te va a garantizar cobertura sí o sí a las 3 de la mañana en una zona y esas celdas no se pueden apagar. Y luego te defines una capa de capacidad y esas celdas tú sí puedes apagarlas. El problema es, acorde a los datos que yo he visto, que las celdas que se etiquetan de cobertura ya representan casi el 40% de las celdas de una red. Significa que ya no las puedo apagar. Si son eficientes en hardware, voy a ganar, pero si no, van a estar ahí. ¿Puedo apagarlas de capacidad? Vale, ahora tenemos algoritmos que son muy complejos de optimizar porque funcionan con umbrales. Si estos 3 umbrales están por encima o debajo, apago. Y eso es un poco muy ineficiente porque necesitas optimizar esos umbrales en una red muy grande, muy difícil, que hace que el operador sea conservativo. Como no sé muy bien cómo va a tirar esto, pues vale, voy a apagar, que sí se apagan, pero los umbrales los voy a dejar bajitos. Entonces, creo que necesitamos realmente un nuevo paradigma que no esté basado en umbrales y mecanismos antiguos de algoritmos, sino IA, que sea capaz de decir, tú te apagas ahora, tú te levantas ahora, etcétera, etcétera. Y para eso quizás las decisiones no deberían de ser autónomas en las celdas, sino centralizadas a través de este agente. Entonces ahí también creo que la investigación juega un papel fundamental.
Sí. Muy interesante, muchas gracias, David. Pues nos quedan aproximadamente unos 5 minutitos por si alguien quiere hacer alguna pregunta o mediante streaming también. A ver.
Tenemos preguntas en streaming, tenemos una pregunta aquí y yo tengo otra.
Vale.
Entonces no sé por dónde empezar. Quizá por la de streaming, ya que no hemos pasado ninguna hasta hoy. Alguien comenta que se refiere al bloque de datos. No es solo el dato, dice, lo que es necesario, sino tenerlo con la granularidad adecuada para el proceso que se quiera optimizar y cumplir con las regulaciones. Entonces, supongo que es un comentario más que una pregunta, pero bueno, no sé si queréis abundar sobre este tema de la granularidad, de las regulaciones o de algún aspecto que están citados aquí.
Creo que David es el que más ha hablado del dato.
Sí, yo puedo comentar. La granularidad lo entiendo como parte del dato, cómo de a menudo ese dato es disponible. Por ejemplo, en optimización de red y volviendo al tema de la eficiencia energética.
Sí.
Nosotros teníamos datos cada hora. Si tienes datos cada 5 minutos, te permite hacer una optimización mucho más granular que te va a permitir apagar las celdas más a menudo y de una forma más accurate. Entonces, la granularidad es fundamental. Pero bueno, lo entiendo como parte del dato en sí.
Muy bien. Bueno, quizás ella que no ha hecho ninguna pregunta hoy todavía.
Por ahondar en el ahorro energético, todos habéis nombrado el punto de vista del suministrador de red, por ejemplo, en este caso Huawei, optimizar hardware, etcétera. Pero también recuerdo que hace muchos años, cuando trabajaba para Vodafone, ya había programas de renovación del parque de sites, de los aires acondicionados, las baterías, en fin, la otra capa que rodea al hardware del suministrador de red, pero que en este caso el coste cae más en el operador, en el Vodafone en este caso. Entonces, pregunta, ¿tenéis todos claro que eso no va a influenciar en el ahorro energético y hay que centrarse en el hardware, o eso también influye? Y si sí que influye, sería la pregunta para Vodafone, ¿se está haciendo todavía algo en ese sentido? Mejora de energías renovables, tal. E incluso la pregunta sería también buena para Vicent, para Ken May. Eso es uno de los inputs de red, por ejemplo, desde el fault management, caída del aire acondicionado, caída del suministro de red, detección de puntos negros energéticos, etcétera. Es una pregunta compleja, disculpa.
Sí, yo puedo empezar, sí.
Vale.
En NGN hubo un proyecto hace poco, un par de años, de eficiencia energética y se estudió el desglose del consumo de una red a todos los niveles. y la entidad que consume más con diferencia es la radio. Entonces, por eso el énfasis del vendedor y creo del operador está en la radio. Sí que es verdad que lo que mencionas, el site, todo lo que hay alrededor, cuenta y hay que tenerlo en cuenta. Pero la razón es que la radio consume más y vemos que en las futuras tecnologías donde usamos más MIMO va a consumir incluso más. Entonces, por eso nuestro énfasis ahí.
Pues lo mismo, pero sí, también hay otros elementos, efectivamente, por si no todo el mundo lo sabe, en una caseta donde hay equipos de telefonía o de otras cosas, lo normal es que haya un aire acondicionado porque tiene que estar en un rango de temperatura. Y sí, además es un ejemplo de que a veces pasas por ahí y dices, pero este aire se abre incidencia y se van renovando, sí.
Bueno, yo aportaría una dimensión que nadie ha dicho, ¿no? Que es la experiencia de usuario. Aquí con Valer hemos hecho proyectos masivos a nivel nacional con varios operadores, con ahorros energéticos importantes, pero en el momento que tienes una queja de cliente, se hace rollback, se hace enseguida automáticamente, me da que me ahorre un 2%, un 1, un 0,5, se hace rollback de los cambios. O sea, que al final aquí también hay una dimensión importante. Yo apago portadoras, pero ojo que como se me queje un usuario, se va todo al garete. O sea, la parte de Customer Experience es una variable que a día de hoy no se tiene en cuenta en este tipo de procesos y que debe formar parte de la ecuación, porque como digo, y lo hemos visto varias veces, tú ahorras energía muy bien, pero como tengas una simple queja del cliente, aunque mejores a 100 personas, una queja del cliente se para directamente el proceso. De forma que lo que se tiende a hacer es un poco trabajar de noche y dejar procesos automáticos más sobre todo de noche. De día, pues a la mínima que se ve un peligro pequeño de que afecte la experiencia del usuario, automáticamente se paraliza.
Gracias.
Yeah. I just want to add some complementary opinion because definitely radio is one of the major components for energy efficiency. But when we talk a lot about AI, actually AI is also a monster if you think about how much power you need to train the models. So therefore, I think there's definitely we need to research as how to make the model more efficient, and especially when we cannot utilize one gigantic big model, then we can think about how to really have small models in different aspects. Another thing is now we also have working on a concept like we call it 0 bit, 0 watt. So if you don't have service, you try to bring down completely. But actually, this is not very easy. Because if you think about the service as a software and you actually spend a big component of the energy just to maintain the infrastructure, middlewares, and so on, and then how to really reach the goal of 0 bit, 0 watt, this is also something we are at this moment research.
Narcís, ¿hay más?
Pregunta del streaming también. Juanma dice que deberíamos hablar correctamente de la terminología IA. Discute si es un fin o un medio, él dice que es un fin. Y dice, una cosa es IA y otra es Intent-Based Optimization. Las dos requieren datos, pero la segunda, la Intent-Based Optimization, sigue un proceso preestablecido. Un flujograma en base a unas entradas que proporcionan salidas y no hay un modelo de inteligencia artificial detrás. Dice, nos está pasando lo mismo con la IA generativa, que se utiliza indiscriminadamente para definir cualquier cosa que genera confusión. No sé cuántas de las cosas que habéis contado o que hemos escuchado a lo largo de la mañana son intent-based optimization y cuáles son realmente AI. La última parte de la pregunta es mía.
De que la IA es un fin o es un medio, obviamente será un fin, por ejemplo, para el equipo de investigación, obviamente hay que estar ahí. Para las empresas por cliente también sea un fin, pero para empresas como nosotros, que somos empresas pequeñas, que tenemos que ser capaces de vender algo a clientes, pues solo vas a venderlo siempre y cuando sea útil y tenga realmente una utilidad. Y esa es la realidad de después de estar aquí 20 años emprendiendo. Obviamente, si lo puedes hacer de alguna forma, pues tira por la IA, ¿no? Entonces, bueno, es un poco mi experiencia a nivel, digamos, profesional en el día a día, que sí, que está muy bien tener la IA, pero si no sirve. Y luego el tema de Generative AI, ya sabéis, tenemos la IA, Machine Learning, el Generative AI, ahora está de moda la Agentic AI, que ha hecho un comentario hace un rato Javi. El Agentic AI va un poco más allá del Generative AI, porque un poco en Kemei lo que nos pasó es que teníamos un asistente basado en Generative AI y nos dimos cuenta que con el prompt y con el RAG y demás éramos incapaces de manejar la capacidad de conocimiento que le poníamos a la gente para manejarlo. Tuvimos que derivar la gente que hay. Con lo cual, bueno, al final, lo ha dicho esta persona, ¿no? La IA es, digamos, tiene diferentes tipos de ámbitos, IA, ML, Generative AI, Agentic AI, pero bueno, en nuestro caso, desde luego, tiene que ser útil y aportar mucho valor para nuestros clientes. No sé si alguien, a lo mejor la parte más de investigación.
No sé si alguien quiere decir algo más.
My last question is as follows.
Hemos terminado en tiempo, ¿no?
Yes, I have one more question.
Ok.
Tengo una pregunta, porque aquí en la mesa tenemos a la universidad o la investigación que es proveedor de conocimiento, Huawei, por ejemplo, Huawei, que es proveedor de tecnología de Vodafone, Kenmei, que es proveedor de servicios, puedo llamarle así, de optimización de Vodafone, Vodafone, que es proveedor de realidad para todos los demás. Todo este set de conocimiento, de tecnología que tenemos aquí en la mesa redonda, nuestras empresas locales pueden hacer uso de ello. Es decir, aparte de estos players, que son la investigación, el vendor, el operador y una empresa de ingeniería, ¿cómo otras empresas podrán beneficiarse de toda esta tecnología que estamos poniendo en sus manos? ¿Y podrán participar de esto? Es una pregunta muy complicada también, casi peor que la anterior. ¿Me entendéis lo que quiero decir? Es decir, aquí estamos en un ecosistema muy cerrado, pero siempre estamos pensando en que esto tiene que beneficiar a un usuario, a mí como usuario, pero como usuario particular de un teléfono en el bolsillo, probablemente. Pero como usuario empresa, ¿puedo sacarle partido a estas mejoras? Y segundo, ¿puedo participar en el juego y hacer algún modelo de negocio que se base en aprovechar todo esto que estáis montando?
Yo para mí, si la pregunta es una empresa de otro sector, ¿cómo se va a beneficiar? Para mí es lo que he intentado decir antes, se va a beneficiar de dos formas. Una del 6G y de los nuevos casos de uso en unos años, y luego otra opción es que se puede beneficiar ya de la inteligencia artificial, que puede ser con el apoyo de una red móvil o no, y que tiene que ser, para mí, con el apoyo de un experto en IA. Y lo que la empresa tiene que tener muy claro es que quiere definir muy bien su caso de uso, porque muchas veces, lo hemos dicho también, ¿no? Pues yo quiero esto. No, ¿tú qué es lo que quieres? Pues yo quiero mejorar mi producción o la seguridad de mis trabajadores aquí. Para eso yo le invitaría a plantear el caso de uso, a buscar un experto en inteligencia artificial que le ayude a definirlo, y luego, por supuesto, si necesita del apoyo de una red de comunicaciones móvil para la transmisión de esos datos, pues evaluar qué requerimientos tiene y utilizarla, si los cumple, y si no, pues pedir soporte al operador para que se los mejore.
Yeah, maybe I put some comments here. If we look back at 4G time, I would say, of course, the vendors and also operators earns a lot of money from 4G. But I would say the biggest winner is this service provider. If you read a popular app and you install on the phone, actually they can get most of the benefits or revenues.
Yes.
So I would say 6G might be the same thing. Like if you, for the small enterprise, if you understand what is the fundamental logic, like if you are not providing hardware or software, you are not working together with Vodafone, but you can still explore like a potential business. So I'm just sitting here and I just think aloud, maybe in 6G time, when I come to this conference, what I will do is I will buy an earphone, and which is enabled by the Vodafone SIM card, and offer me AI services. So I just put my earphone in and everything is translated to English. Then I'm sorry, I don't want to replace your work, but I would say this will be really cool applications. Or I have a glass and then just actually summarize all the keyword, then I understand right away. So I would say this could be something totally new, which doesn't exist in nowadays. but it could be a really good opportunities for the startup to think about how can you utilize these new capabilities of AI and sensing and connectivity, because they will come sooner or later. This is definitely the promise. And then the thing is we need more innovations and then think out of the box.
Thank you. No sé si... Pues ya está, Narcís. Bueno, pues muchas gracias a vosotros. Y nada, pues bueno, ya dejo paso a Narcís.
Gracias por la mesa. Muy amables, muy interesante. Thank you very much. Very nice speakers. May we have a picture of them, right? Okay. We don't have the photographer, yes. So. Okay, so remember that now we have a lunch break out there. We have some rice food. And that the afternoon sessions are really as impressive as the ones that we have seen this morning. So note that we finish with the keynote speech from Jose Cammani. He's a very famous photonic expert in our campus. And after Jose's talk, we will have a farewell beer and tapas event. This will be at around 5. So, thank you very much. By the way, you are doing a very good job, guys. It's excellent what you do in the cabin. So I wouldn't like you to be substituted by any kind of earphone or whatever. Thank you very much. Enjoy the lunchtime. ¿Qué? No te entiendo, pero...
Estamos listos. El ponente está allí, microfonado.
Sí, y yo estoy aquí también. Gracias. So, let's collect people in the room to start. Five late. Sí. Okay, so we can continue with the talks of this afternoon. As mentioned before, we have very impressive and very interesting talks this afternoon, except of my one. So our first speaker, maybe I should be down there and you should be up here. He's the vice president of the university. This is the José Montserrat is a researcher in UPB, a full professor, and he's currently the vice president for international affairs. He has been working in this field since many years, since he was a student of mine as well. But of course, he has reached a lot of achievements. A part of many publications and projects. He got the Best Professor Prize in 2010. Also at the national level, he got also the award of the Royal Academy of Engineering.
Correct.
Yes, and many other things. So and even he has served as a European Parliament and the World Bank advisor for the 5G communication topics. With him, we have shared many projects. It has been a pleasure to work with Jose all these years. And now he's doing research, of course, in the 6G, so in the evolution of 5G towards whatever 6G is about. And I think working with these big MIMO things and these big channel things and how to compress it and how to make it run without crashing every machine in which we try to compute it, it's the talk about. Thank you, Jose.
Thank you.
The floor is yours.
Well, it's a pleasure to be here. I am talking in English only for one guy in the room, but I will do the pleasure to talk in English for my friend Ichun. What Narcis did not say is that I was a student of him. He was my PhD supervisor, and he's my academic and scientific father. So I am here invited by Daddy, and I came with love to talk about my patent. So I come here to talk about my patent. It's not mine, but it's one of the patents we have made together in the Joint Research Unit of Huawei and the Technical University of Valencia. We got a patent, which is this one, and I got the mission from my supervisor to promote our patent the most for selling it. So the objective of my presentation is to convince you that this is a great idea. If I fail to convince you that this is a great idea, is that I made super bad. But it's about 6G. In fact, we have to change the logo of Valencia 6G maybe next year, right? It's easy. Just we take the 5 and we put beyond 5G. Okay. Let's start with the B here and then we move. So this is about 6G because 6G has something. You say it's the AI era. David will say always, and Sueli will say always is the AI era. But there is also something else you have to put on top of it to have more throughput. And the only way to have more throughput is either to be more efficient in the modulation and coding scheme, which is hard because we are already in 1,000 bits per symbol, so it's impossible, I would say, to go further. Either is to go for more bandwidth, which is also always a possibility, but makes things super expensive and cost-wise, or is to put more antennas. And this is one of the trends that we have today. In Huawei, last Mobile World Congress, I was invited by Sueli, and we saw phones with 32 antenna elements. These are a reality. We have already phones in the market with 32 antennas, and we have base stations with 1,024 antennas. So the things are becoming really massive. And if you make multi-user MIMO and you put hundreds of users with 32 antennas, you can have thousands of antennas in one end and thousands of antennas in another end. So we are talking now about millions of elements in the channel matrix. This is really massive. And when we start thinking in multiplying by 10 the 5G to 6G, we should put not millions, but tens of millions of elements to achieve that, hundreds of millions of elements to achieve that. And you have to consider not only this, but also the different frequencies. And in each one of the frequencies, you will have hundreds of millions of antennas to handle every 1/10 of millisecond, maybe. The things are becoming complicated. And massive MIMO is a great idea, but it's really reaching its capacity limits in terms of computation. If you see the channel matrix of massive MIMO, you will see that it's as ugly as this picture you see there. I mean, it's really, really, really ugly because it has no any kind of structure. But actually, one thing that we are seeing is that whenever we go high in the frequency domain, the more this matrix has some meaning inside. And this is the content of this idea. It's basically to start thinking in the projection space also of the MIMO matrix. We have never talked about the projection space of the MIMO matrix. We have been always talking in the space domain for the matrix of MIMO, but the similar as we did with the time to frequency domain projection. Remember, it was a time in which we were studying in the university this eye diagram of the symbols, and the information was in the time. And then suddenly they say, no, it's no longer in the time. It's in the projection space of the frequency. We make the Fourier transform, and we start talking about subcarriers. This paradigm change was because of the dimension of the bandwidth. So now with the dimension of the MIMO, we have the same problem in the space, in the MIMO space. And the same solution could be applicable. And this is the idea here, is to also work in the projection space of the MIMO. And why? Because actually, the higher the frequency is, the more confined the information is in specific again channels. The information becomes kind of ray tracing. They are more like rays, and the information is confined in specific pathways. So let's focus on these pathways, and let's try to put the information on these pathways. Every one of these pathways corresponds to a phase front of the signal. If you imagine, you are all communication engineers. So you know what a signal is. Imagine the phase front. The phase front is the line of points in which you have the same phase at the same instant of time. So if you draw this phase front, you will realize that when you are in high centimeter wave or in millimeter wave, this phase front becomes so clear that you can even identify the paths into the propagation. Whenever you have this, the characteristic is that if you apply the same philosophy of the projection space on the time frequency with respect to the space of the MIMO, you will realize that similarly as happened in the frequency, you have few elements that are significant. The projection space of MIMO is becoming sparse, and the more the frequency rises, the more sparse this matrix is. So the solution we proposed, together with Huawei in this proposal coming from the Joint Research Unit, is to actually remove the non-redundant information and to start working in a different projection space. As I said before, it's exactly the same paradigm change than what we did when we passed from time division multiplexing to OFDMA. This same we can do also in the angular space coming from the projection of the transform. And what we demonstrated with our research is that actually, if you take only the compressed version of the matrix and you remove all the information that is below a certain threshold, and you start working with this compressed matrix, and you perform the kind of precoders that we are used to do, I mean, you apply digital precoder as always, the information can be recovered. There is a linear projection. So this is the characteristics of the Fourier transform. Can be reversed. But all the things that happen in the zero forcing wall, let's say, they happen also linearly. So we can guarantee that at the end, the recovery is again only a Fourier transform. So the same philosophy, as I explained before, we can do now. So the proposal that we have patented is to start working on a different frequency domain. But now is the eigenchallenge domain or the angular domain. Now all the information becomes small in the number of units. The information is restricted in the dimension, so you can work with a simplified version of the system. Instead of using hundreds of millions of elements, you will have tens of elements again, with the maximum capacity as before. So this is the idea, is to build an equivalent of the system based on a basic 2D Fourier transform. How to make this box, how to make this blue box inside, depends. There are many options. We have, in fact, patented 2 or 3 different options. One, they are more efficient. There are others less efficient. There are some that are more forward-looking. There are others that are more backward-compatible. But in all the cases, the benefit is the same. The number of elements of significance in the eigenchannel domain, in the angular domain, are much few. And therefore, we can work, as always, assuming that you have a big increase of capacity due to the MIMO characteristics. If we are looking to the matrix in the different stages of this simplification diagram, you will say the ugliness of our conventional massive MIMO matrix, the characteristics in the angular domain that are starting to squeeze whenever you have high frequencies, how we can compress the matrix, and how we can actually diagonalize this compressed matrix simply. At the end, what you are getting is the most of the channel with very simple complexity. And now you can say, OK, but there is Evil's advocate reason here, that is that you have to do a 2D Fourier transform of a matrix enormous. Still, this is difficult. To make a Fourier transform is not that easy. 2D Fourier transform is not that easy. But actually, if you see of the numbers, and you imagine that in a 5G system, typically you have thousands of elements of frequency, and you put the tensor equivalent of the matrix, which is thousands of millions of elements, you will realize that the FFT can become a problem. In fact, can become a problem with a very simple number of matrices. With a dimension 256 by 256, you are already reaching the 1 millisecond time only with the 2D Fourier transform. So we have the same problem. And this is why I say that this transformation in the angular domain is not that simple. You need to make it in an efficient way. So one of the ideas, why not, is to make it physically, because you can do so. Physically, you can transform a Fourier transform 2D into a Butler matrix. And this is another contribution to science that we have made together in this research unit, is how to build this basically with equivalent propagation lines. And this is also demonstrated. is not still manufactured, because in fact we are in the process of, but we have already the solution that allow us to make this happen, and allow us to make it happen also dynamically, so you can change the angular characteristics depending on the selection of users you put in a multi-user domain system. If you build the system physically, which is the green light, you will realize that actually this is by free. So you don't have scalability problems. And this is the key point. All the FFT problems you can have with the calculation of the 2D transform, it can be solved physically. What will be the consequence of this? The consequence of this will be basically that the antennas will no longer be rectangular and planar, will be a cube, will be more deep, because you need the physics of the transmission lines to build the Fourier transform in a physical way. And the antennas can be different. But if we build different antennas, if we build antennas that are a kind of a cube, we will manage to get really, really benefit of tens of thousands of antennas by free, whenever you have enough information in the channel. Always, David is saying to me, and what about the channel? Whenever you have enough information in the channel. So now the key is how to choose the users to make the information happen. Well, we build a system, and we check it. We check it first with ray tracing, and we went to MATLAB, and I put all the information of the MATLAB here for you to check that we follow the toolbox of MATLAB. We select all by OpenAI information, OpenStreetMap, and so on and so forth. We build different scenarios. This is Shanghai, because our colleagues say better Shanghai than anywhere. And we build also in our offices. We use MATLAB. We get the maps of the propagation, and we check what is the capacity performance of this. In blue, you see the theory, the capacity maximum bits per second per hertz that you can reach by the capacity limits with a channel like this. In orange will be the full SVD, I mean, the precoder typically that you apply with zero forcing. And then all the other lines are this simplification. So how much I compress this matrix, how many elements I remove. And you will see that 1,000 to 1,000 antennas can be reproduced very well by 32 by 16 or 18 antennas. So this limited set of antennas represent mostly all the capacity of the system. There is no need to go for farther than this, because you will get all the information restricted in a very small set of antennas. You cannot imagine the difference in terms of calculation of the decomposition of a matrix of 1,000 to 1,000 compared with 30 by 18. It has nothing to do. With centimeter wave frequency space, 12 gigahertz, with millimeter wave space, 30 gigahertz, and also assuming that the system can be rectangular or not. So there is no need for symmetry on this solution. Because whenever case we found, for instance, looking in this example, with an asymmetric antenna, with only 6 by 3 elements, you characterize all the capacity of the system. So it's really amazing. Next step, we went with Narcis, and we say, Narcis, give us real measurements of this. So we got real measurements of some scenarios, and we check also with real measurements, which is good, because what we confirm, and Monica is laughing because she understands the information, what we confirm is that actually it's true. The information in the centimeter and millimeter wave space is really confined in angles, so we can apply this solution for compress of the MIMO channel. So it's a super fast speech. I wanted only to sell my idea. I hope all of you are convinced that the compressed MIMO is the next dimension of the increase of capacity, that we can introduce this compression in the angular domain as similarly as we made from the time to frequency domain, that again, a fast Fourier transform can be the solution. Not only, there are other solutions for making it. We have several, but this is the most straightforward to understand. We will have some benefits, side benefits of this, because we can compress also the channel state information feedback, because not all the elements of the matrix are relevant. So, OK, only transmit reference signals in the areas in which you have information. This is a secondary benefit of this, apart from the simplification of the capacity. Is computationally efficient, can be implemented physically in an antenna, can be reduced, the computation in an order of magnitude that can be qualified, and the only limitation of it is that the dimension of the antenna will get a third dimension. The depthness of it will be higher. So that's all from my side. I promise to make it short because you are after the lunch time, and I guess it is. But I am open for your questions.
Thank you so much, Jose. So I have 100 questions.
100?
But I'm sure the guys in the audience, they have some. Okay, my first question is about this implementation. You know, yes, Butler matrices to Butler matrices are fine, and you are obviously getting almost real-time FFT with that. But the drawback, I think, is that it has some power loss in every step.
Correct.
So if the matrix, Butler matrix is huge, then there is a huge of power loss, and then probably you get reduced dynamic range, and then you can capture only a few of the eigenvectors or the eigenvalues of the channel. What do you think?
You are right. I mean, it's totally like
but then
you got it super fast.
But you're here to sell the idea.
Yeah. Let me sell it.
Let me sell it.
He's right. I mean, this propagation line means that the signal has to come into a line, has to switch to another place, have to turn with a different phase, and have to zoom with others to. I mean, there are losses. It's obvious. And we implement this not in a physical way, but in CST, which is a kind of a simulator of radio frequency signals. And in CST, we got propagation losses of around 10 dBs with a structure of 1,000 to 1,000, which is big enough. 10 dBs is a lot, I have to say. So this is a problem. Felipe, which is the expert of antennas that is designing this, he promised me that this can be reduced touching the materials. I mean, touching the elements of the propagation path, because it can be compressed. Not to the infinite, but there are some ways of increasing the epsilon of the propagation in a way that you can reduce the propagation losses, but still it will have, I don't know, 6 dBs of propagation losses. It's an educated guess, but imagine this is a lot. How much you gain because of this? The massive number of antennas you can put. I mean, you will focus the information in a very, very, really specific way. You can put thousands of users making multi-user MIMO at the same time using this performance. I mean, the dimensioning can make you to transmit really pencil-like to thousands of users simultaneously, but you will get smaller size antennas or even lower frequency ranges of the radiating elements and so on. This is true. The second problem that you identify one is the switching time, because you have to try physically 1 million elements to check which one is the one you have to put. You don't know. You have to use the uplink signal to estimate and then use it. And we solve this, and with the current switches, you can make it in 10 nanoseconds. So this is not a problem, thanks God. But the 6 dB to 10 dBs propagation loss is the drawback of the solution. You have some benefits, but you have some drawbacks. But it's a good point to continue researching. I mean, I'm sure we will continue trying to find out how to make it better.
May there be a solution doing this in the optical domain? So taking the
of course. Why not?
Antenna signals to...
Sure. I'm sure if we talk with Jose or with Ivana that is here, she will say to you, you can combine in the optical domain and there are no losses.
You can do 2 dimensions FFT in the optical domain. Okay. Questions? Any mathematician in the room? No questions? Okay, yeah, I have one more, but anyway, yes, German?
Thank you very much for your report. I wonder, I know in Huawei there were some attempts to do the CSI compression and decompression with neural networks, in particular with autoencoders. What do you think personally about the prospect of such approach, and can it be efficient in comparison to traditional to DFFT, or because here a lot of people were talking about AI application. Maybe it's one of that.
Yes. Well, the reduction of the overhead of the reference signals is important. I mean, 15% of our resources are wasted only with the estimation of the channel. It's a lot, 15%. I wish we could go and reduce this to 0. This compressed MIMO is typically used for this, because if you identify in which directions you have the information, it's better to point only the information of the channel there and only estimate in this direction. But it's true that since there is mobility, it's very few stable with the mobility. If you are fixed, of course, this is an option. But if you are moving, the things there start to be tricky because you have to check in all the directions from time to time to see how the signal are going. So they are, as you say, AI techniques to reduce the signaling on this behalf. And this is an option that the research is extensive because massive MIMO, the big problem is the channel estimation. So we have to do something. We have to estimate, we have to predict, we have to adapt with filters to a bad decision, updating ourselves on the fly according to the performance instead of having a permanent analysis of the signal in the time domain. So there are many options. Why not the application of AI as a means to improve the efficiency of channel state information will be one of the topics to be researched in the future, yes. Thank you.
Thank you.
It's a good question.
So, okay. One question there, I think, Andres.
Come on, it's siesta time.
Thank you for your presentation. Do you have a threshold in order to determine the best channel matrix reduction?
Yes. So I cannot present the slides, but if I had the slides, I will show you. When you have the curves of performance, there were different levels of performance. It was the optimal, and then the zero forcing result, and then when you have 16 by 4, 32 by 16, 64, and it was increasing. How it was increased is because of this threshold. You say how much percentage of energy from the things that I'm going to remove with respect to the peak. So this is the proposal we made. And with different thresholds, you got different sizes of the matrices because you remove more or less. How to optimize the threshold? In fact, typically we say don't waste more than 1% of the energy. So this is the number we are using today. But you can waste 10% of the energy and be more compressed. Or you can say, no, only 0.0001% of energy and be more wide. So it's depending on the decision, because this energy that you are blocking is totally wasted. I mean, it's a percentage of resources that you will never use, and you could have used it under more power. So now it becomes the discussion, I talked to David because it's his discussion, of the energy efficiency. Which is the threshold from the energy efficient point of view? We don't know. We have not checked. But there will be a threshold from the energy point of view, from the sustainability point of view. Capacity versus power consumption, it will be an interesting analysis. But the current one is only about the percentage of energy that you waste, the percentage of resources that, of opportunities of transmission that you waste.
Okay. Anything else? I think Sergio has a question. David has one.
I called David 3 times, and the third one is...
The good thing of being quick is that then you have time for questions.
Yeah, I know. I like
Sergio or... Exactly.
In fact, it's like this. When you have outdoors, well, if I have the slides, you will see, with 6 by 3, you have almost all the information. The information is super, but in an indoor like this, imagine this place. I mean, whenever I am in a room, I start looking for the reflections, and I say, this is crazy because this is metallic, this is also, so I start looking for it. Here you will have many, many pathways, and you cannot compress that much, exactly. So it's better for compression, of course, in line of sight conditions and in outdoor situations. Correct. The higher the frequency, the better the compression rate.
Okay, Sergio.
Hello. When we are talking about, for example, spatial multiplexing, then if you do the FFT, and then in the angle domain, you will see different paths. But when you have a lot of elements, because of your angular resolution, you will see the different paths separated. But
Yes.
if you compress it, then they will mix in just one, so then it will be like one beaming antenna. So then you lose the spatial multiplexing. Is that taken into account in the compression?
That was our wonder. It was, we will lose the capacity because of this compression, because actually what we saw, as you are thinking in the channel, because you are a channel guy, and in your way of thinking, you are seeing this rays, and you are thinking like we were thinking, and we had the hypothesis, it will be possible to compress actually and don't lose capacity, and in fact you don't lose capacity. So the result that we demonstrated mathematically, because it was first mathematically demonstrated, was that you can keep this level of resolution even with the compression. because in the FFT, you keep this process alive. It's curious, but it happened like this. Whenever you have a great resolution, and when you have a great resolution, because of the frequency and because of the big matrix you have. So in 1,000 to 1,000 elements, you have big resolution. So you can still keep the details that you may lose in other conditions, but actually it's kept, and you keep the capacity. Yeah.
Thank you.
Okay.
Okay, now I am over. Thank you.
Thank you very much. So I'm not sure how should I present the next speaker, because it's myself. So I've been working in this field since, I will not tell you. Some of you, or many of you, were students of mine some years ago. And of course, I've been in front of the ITIM Research Institute for the very last 8 years, and in the foundation of the institute 20 years ago. And I'm really very proud of my students, not my current students, yes, as well, but from all of you previous students that I had, because you are excellent, and you have been excellent in your careers. So this is my presentation, not about myself, but about you. Thank you very much. The talk is about this thing that you've seen on the screen. It's digital twins for 6G, and I will talk not only about digital twins, but how these digital twins should evolve with the AI agents in them. No? It may happen that I switch to Spanish at some point in time in my speech, and then come back to English. Okay, this is a very brief summary of the talk. In fact, I'm only talking about these 4 points. What's my very peanuts of impression or views on the 6G? What is, in my view, the dynamic digital twins or radio frequency digital twins that we are building, and how it will evolve towards this A-RAN concept. A-RAN is Artificial Intelligence Radio Access Network. So, ahora cambio al castellano. Para venir a la presentación de una ponencia sobre inteligencia artificial, le pregunté a la inteligencia artificial qué era la 6G, de acuerdo al chat GPT, y me dijo que 6G es terabit por segundo, conectividad, extremely low latency, subir a frecuencias de terahercios y todo eso. Y todo eso que veis ahí. Y por supuesto dijo que la 6G será AI native, que será perceptiva, que tendrá más seguridad, más sostenible, más eficiente energéticamente, y que se basará en comunicaciones semánticas más que en comunicaciones de datos por sí mismas, ¿no? Y todo eso también junto con la pregunta al ChatGPT malo, si este es el ChatGPT average, ¿no? Esta es la respuesta promedio que consigue la IA generativa cuando le preguntas por qué es la siguiente generación. Pero hay muchas voces que están diciendo, lo hemos escuchado esta mañana, que igual estamos exagerando, sobreestimando la demanda de throughput por usuario que vamos a tener en el futuro, y que posiblemente estamos tratando de diseñar una red que tendrá, como nos pasó con las milimétricas, exceso de pretensiones en cuanto a la banda de frecuencias que utilizar sub-terahertz o al ancho de banda que necesitamos, ¿no? Incluso para el tema de la latencia, 1 milisegundo, por debajo de 1 milisegundo, cuando los sentidos humanos, bueno, el más rápido, que es el tacto, tiene 5 milisegundos de tiempo de reacción, y los interfaces todavía no tienen esa latencia. Cualquier pantalla, imaginaros, ¿no? A 50 frames por segundo o a 100 frames por segundo tenemos 10 milisegundos de latencia solo con el vídeo, ¿no? Entonces, bueno, hay muchas cosas que están ahí. Quizá ese gran ancho de banda se puede conseguir también en frecuencias no tan altas, en la banda media, o incluso combinando bandas de frecuencia en una cosa que sería obviamente necesaria, que es gestionar simultáneamente un ancho de banda suficientemente grande, o todo el espectro de RF en este momento. También se dice que todo eso, y lo ha contado David también esta mañana, que todo eso de el láser no va, que todo eso de los verticals y de las aplicaciones que estamos pretendiendo para 5G, perdón, para 6G, eso ya estaba en 5G, ¿vale? No nos tenemos que olvidar que estamos hablando de movilidad. So this is about mobility. Anything that is on the move and is connected to the network is our business. Everything that is static or is very low moving or behaving in a very small environment, probably this has a lot of competitive technologies. Yes, what is from the industrial perspective? From the industrial perspective, again, in 6G, we pretend to cover factories, vehicles, health, e-commerce, etc. But the operators, of course, they pretend that at least they would like to hear it is written increase revenue streams. I would say that OpCos will be happy if they keep the revenue streams and not decrease it. Yes, and of course, efficiency. Efficiency comes up to the scene every time that we talk about 6G. So at the very end, it will be something that we need to build to reach efficiency. Again, in the drawback or in the asking the ChatGPT or the generative AI, what is the drawbacks of the 6G, calling that many things that are pretended to be were already in 5G or can be covered by some mature evolution of the 5G technology. Yes, if we put a lot of resources in 5G, if we put a lot of elements, a lot of access nodes, etc., and we have huge amount of spectrum and resources deployed, probably we can reach whatever we want to need, but without the efficiency that we're pretending to reach, right? Okay. So, what should make the difference in 6G? And this is why this is the introduction to what I pretended to explain you is about digital twins. But efficiency is then the keyword to me for the 6G, for the definition of the next generation networks. Efficiency in these many senses. So, return of investments mentioned by Vicent this morning, energy per information bit, security, etc. Yeah, energy consumption, of course. Yes. Artificial intelligence comes to increase this efficiency or to make it possible. Yes, but the artificial intelligence, the AI, requires data, requires sensing. Also, very long discussion this morning about this. We require to have this data to sense. So sensing now is also a pillar, a key pillar of the 6G. Again, David mentioned this in the very beginning of the morning. So without sensing, we don't have data, and without data, we don't have anything to learn from, and we do not have AI at the very end. Okay? So, and then we can run a system, a physical system, a network in which we have sensing, and the different elements, the terminals and the base stations and whatever, they are sensing the environment and capturing information and using it to run AI algorithms or AI agents or AI models, and then optimize the network and make it more efficient. Yes, why not? And this is what will happen. But this is the short real time, right? And if we do not train these models properly, or we don't have enough time to train these models properly, probably we are just running these intent-based or event-driven things that we are already doing in the past. So training AI algorithms with rain data can run in the physical network, of course, but can run on digital twins. So to have a twin of the network that is running AI models, but these models can be trained without the risk of doing it directly in the real network, or for mid or long-term predictions, or for mid or long-term training, and then, of course, share these models or share these policies with the real AI agents. Yeah, so this is the main idea of the talk is this one. So why don't we use digital twins as a parallel thing to the real network, but not only as a parallel thing. If you have a digital twin and you run it, imagine that you have a precious, you will see later on a video, a precious definition or description of the 3D environment. We can reproduce this environment perfectly in a video game. And you play the video game, and you do simulations on top of that. You are doing only simulations. And you can test ideas for the network with this simulator. But now you go to the physical network and you run the network and you do these optimization algorithms inside it. You don't have the simulator running in real time. You have the physical network running in real time. And these are two separate things. Okay, it's obvious that if we can put together the physical network running real time and the digital twin training or understanding and learning from this real data that we are capturing, we have a low-risk thing running, which is the digital twin, learning and creating models and policies, and the real network running real-time, reducing the risk or without this one user call complaining because we have changed some facility and then there is a dropping the calls and so on and so forth. So we can try the digital twin before implementing it into the network. So intelligence or intelligent networks will be capable of doing that to maximize efficiency. So at the very end, the keyword of efficiency, I think it comes to be intelligence for efficiency when we talk about 6G networks. Yes, 6G networks will be perceptive because they need to sense the environment. They need to capture all this information to run AI agents, AI algorithms, and be efficient. Compared to previous networks that were just reactive or were just in the most predictive, I would say, right? So this perception allows us to reach the cognition, to, yes, perceive, see, interpret, know, learn, and then have this cognition of the environment based on this big amount of information. So perception can afford or can give us intelligence enough to make the networks efficient. So it's a kind of a chain between sensing, AI, and then the efficiency itself. This is not new. I mean, since some years ago, and these are white papers already published in the 5G PPP times and in the cost, in the beginning of the cost interact action, there are already this network intelligence stratum here or network intelligence stratum there, or some network digital twins appearing in the potential architectures of the next generation of networks. Yes, not new, but at the very end they are defining a kind of knowledge plane that will be, if this is a simplified schema of, very simplified, a schema of an SDN, software-defined network, and then we introduce this knowledge plane, which is in part this knowledge plane is a digital twin running an emulation or a twin mimicking the behavior of the network, yes? So of course, and it has the same northbound APIs connecting the application plane and the data plane in the southbound. Okay? If we look inside it, and this is my particular view, right-hand side you have the physical network, left-hand side you have the digital twin. Again, if we run them separately, we just do simulations, and then we just run real-time the network. But if we can put together, in the sense that data collected in the physical network is feeding the digital twin, and then some algorithms there can feed back information to the network, may this will be a powerful tool for the next generation networks behaving. See that the definition of the digital twin I'm doing is a multi-layer digital twin, because in some cases, in some scenarios, in some portions of the network, we cannot have all the layers. What I'm talking about layers, topology, of course, configuration, mobility. Yes, you know, if you work in the field, you know, this kind of information can be organized in these layers. Then the environment layer, 3D buildings, whatever. And then layers that we can calculate from that. We can estimate, have a pre-calculation of the radio frequency channel, the channel matrices, or we have a pre-calculation of the mobility prediction, whatever, yes? So, but in some cases, for instance, we do not have the 3D information of the place, and we only know that this is a urban area, and then we will not apply deterministic models, we will apply semi-stochastic models or stochastic models, yes? Here, and I will show you better some examples, yes. A simplified example of the idea is, okay, something is sensed in the radio access network, is moved to the digital twin pre-processing, and then the sensing is an event that detects that there is something new in the scene, which can be a user or can be just an object. If it is just an object, it goes to the static layer, the environmental layer, the 3D layer. If it is a moving object, goes to the mobility layer, and then depending on what it is, so after this pre-processing, then we launch an event with this manager of the digital twin that runs, in this case, a new radio frequency simulation to update the RF layer or to update everything inside the digital twin. So it's a kind of dynamic thing that is driven by events that happens in the sensing that I take from the real network. Okay? If what I have is a channel estimation, for instance, in a link, and I have a channel estimation at that particular point, then I can use it to update or to calibrate the RF layers of the pre-stored channels or the channel matrices. And if it is a user, Okay, then then we detect that it is a user what is sensed, and then we can run predictive informing or channel allocation or experiments on how the channel allocation of the predictive informing will run when I apply it to the real network. Okay, so all these kind of things we have put it together, and they are running now in our. Can we see the video? In our ray tracing simulator, we use. Okay, this is the ray tracing simulator. This is the campus, and this is part of the campus area where we have this beautiful thing, the digital twin, and you see that there are people running there. A base station is located here in front. We have this mobility. These people are moving, and then they enter an area in which we are interested in having this digital twin of the radio frequency channel. So we have the channels there, yes, calculated in real time. So this is real time running. So it's not an edited video, it's a real time user running the digital twin. And whenever it is a sensor detecting that the user is entering the area, and then the channel is calculated immediately. And it's done with deterministic ray tracing, because we have a very deterministic description of the environment. Otherwise, we can apply different models. But in this case, we apply this ray tracing, and we have a precise matrix of the channel that Jose mentioned that they are using for their experiments afterwards. Yes, and so when this human is a user, then we immediately assign a channel like you see here. Yes, it's a 3 eigenvector channel in this case, or 3 main components, or 2 sometimes. And this is normal. In outdoor, normally the reduction of the channel matrix that Jose mentioned can be set to 2 or 3 or 4 maximum number of components. Indoors is much more complicated, as he has mentioned. Okay, so this is currently how our radio frequency digital twin runs. What is next? And now I jump back to the slides. Transparencias, please. Okay, yes. Okay, next is, okay, we are running now algorithms that calculate the channel, that estimate the channel, that predict mobility. So these algorithms that we are running today will be mimicking algorithms that are already running in the real network. So for instance, I'm painting agents here, yes? Okay, it could be algorithms or AI agents, whatever you want. We can analyze the network behavior in real time. We can predict traffic, okay? Or we can predict network congestion, etc. This can be done in the digital twin. Again, if we do it separately, we just play a game. But if we link it with those same algorithms that run in the real network, we can do a very powerful thing. Yes, so it's a kind of federated learning between these 2 groups of AI agents. We can do the same for run optimization strategies. So we try these run optimization strategies in the safe side, which is the digital twin, and then apply or not to the real network. And this is again we can optimize informing, resource allocation, power control, whatever. And this is also something that is already ongoing in the real network. So at the very end, we are mimicking, or we are twinning algorithms or AI agents or AI tools that are already in the physical network, and we want to mimic, try, replicate in the digital twin. Yes, troubleshooting, of course, historical data to do predictions, proactive maintenance, etc., like you do in some of your companies. This runs in the real network. We can try in the digital twin. But again, it's not only playing here or applying there. It's combining, so feeding feedback information from the network to the digital twin and the other way around. In our case, we work more in the radio. In my case, in my group case, we work more in the very physical part of the network, in the radio access links. So essentially, we study the channels, the links, the behavior of the radio communication channel for the radio access, and this RF sensing or channel prediction is what we used to do. Yes, and this also can be allocated or done here in the digital twin, as you have just seen, or at the radio access network itself. So at the very end, and this is not as beauty as some of the presentations that we have seen, it's not as organized as we have seen before, but we have a set of AI things or agents that run at the digital twin that are coordinated or federated with those AI agents that run in the real network. No matter which is the real network, but the only thing we need is to have all or part of the information of the network to run all or part of these AIs here and learn each other. So there is an interface, of course, the models interface. We exchange policies or we exchange models between them. The good thing is that there can we run real time. Here we can run safe side, yes, but both learn each other. Okay, we have, as mentioned, performed this number 5, or what is here numbered as number 5 things, for instance, and this is just a summary of our results. You can check in the references. For instance, we have managed to find a way to estimate the channel from monostatic sensing only. So we estimate the communication channel from monostatic sensing. And this is because we use the mutual interference between two monostatic sensors. Yeah? And in this example, we separate the monostatic sensing, which is the blue one, from the B-static. But this B-static R21, the one in orange, I think you see it orange, is obtained from the two monostatic sensing signals. Sorry, from one monostatic sensing signals interfere from the other. And we have several publications together with Huawei about this point, and this is one of the first pieces of this digital twin intelligence. The second one is the modeling the scatterers, the targets. Sensing the environment means that we understand what happens around us, and then any kind of sensing signal that we launch from the next network can be a kind of a radar, if you want to put it this way, but we pretend to build it on top of communication signals, to use the communication signals to detect to work as a radar, yes? There are many discussions if we have to rely on, so to do communications based sensing or sensing-based communications. So if we put, let me put it this way, if we allocate bits in a radar signal, or if we allocate a kind of radar in OFDM signals. Yeah, so we can do one way or the other, but anyway, there will be something reflecting from every element in the environment, and we can model these elements, like you see here in the car. This car has been measured, so these are measurements in the millimeter wave band and in the FR3. This is FR2, FR3. And see that from the monostatic point of view, the car can be reduced, as graphically you may guess, to a certain number of points. So we can, and this is a contribution that we have done to the 3GPP meetings to provide this MSC model together with Huawei again. So we can model these targets with a simplified manner and using only a number of points. For the cars, the current proposal to 3GPP is to use 5 points for the monostatic sensing. It sounds trivial, yes, but we need simple models for many things. The question is that these points are not just 5 points and that's all. Are 5 points with a particular scattering properties. And this is the tricky thing in which we are working, of course. Yes? Then if we combine this with the time domain, so if we do time gating and background subtraction, and these guys around there, they know about this because they work with me on this topic, then you can infer which is the object that you are sensing. And you can guess which is the object that we are sensing here, right? Well, it's even better if we put the schema of the car on top. Yeah, so we are sensing and detecting that this is a car. There are some publications. The most recent one is last December in Globcom with people from Huawei, the Shanghai team. And one more thing that we can do, and this can be also one more AI algorithm running in the digital twin and then probably be adapted in the real network, is that, okay, we can recognize, not only model these targets, but we can recognize these targets from the scattering of these sensing signals. See that These are our measurements. This is not an invention or a simulation in MATLAB. This is measurements. And we measure this, and you see that the very left one is an AGV, a kind of a robot, a robotic car. The mid one is a person, a human, a PhD student, by the way. And the third one is a car. Yes, it is obvious that that is a car, yes, like we saw before. It's rather obvious, but it's not that obvious that this is human, and it's not that obvious that this is an AGV. But obviously with a bit of AI, we can distinguish and we can classify these targets. So from sensing, we can also not only model or detect the signals, the radio signals, but we can try to infer what is around us. Yeah, and this is the next step that everybody wants to take in the communications domain, to integrate sensing and communications to make the network perceptive. With this perception, we can have the intelligence, and with the intelligence, we can have efficiency. Yes, so this is why we are working strongly in channel modeling, deterministic channel modeling, ISAC, sensing and communications together, and all these kind of things that has been mentioned also by Jose. So, in summary, the work we do currently in the group is more or less all this. Yes, so we do definition of the digital twin to be included as an all explain of the next networks, and then start with the channel estimation, sensing, detection, target classification, and then the modeling of the whole thing in a deterministic digital twin. Now that's all. Some takeaways. I think AI agents in RF digital twins, in combination, in cooperation, federated with those running in the real network, this creates a very powerful thing that can end up being a key technology enabler for the 6G networks. That's all. Thank you very much. Any questions for the speaker? Comments? I do not have any. Yes? Mavi? Yeah.
Okay, thank you. To put to the test the digital twin, Spanish or English? Okay.
Como
English?
quieras.
To put to the test the digital twin with high traffic load, I'm assuming you have to embed already in the real network the digital twin and then put the high traffic load in. You cannot train high traffic load with a digital twin that it is still outside of the real environment, right?
I'm not sure if I understand your question properly, but
I can give you an example. If this room is something you are modeling in a digital twin,
yes,
you have your perfect model, the walls, the microphones,
yes,
whatever. But you may have 1 people or 2 people working, like in your video, or 500.
No, I can allocate 20 or 30 or 80 like you are now.
When are you confident to say, I know the behavior of my room with 1,000 people in the room? To do that modeling, you have to use real data, right? So you have to embed already the digital twin in the real network.
Indeed, there is a huge work in trying to calibrate. When we talk about this deterministic thing, deterministic models, to be honest, will never be 100%, 100.0% realistic. Because even if you pretend to describe this environment perfectly, and you know every material and every corner and everything that you have in here, what is this? This is wood, right? How thick is it? Is it thin or is it very thick? Depending on that, the amount of energy and the phase of the signal reflected in this wood will be different. So the 100% deterministic is never existing. Normally, when you have a crowd of people and not a single user like in my video, obviously there is a stochastic component in the channel model, and this will never be avoided. So for sure, for instance, for the phase of every ray that was shown by Jose, in our simulators is always random, because we never have the very precise information about the material at these frequencies, at least. to say, okay, I know that exactly the phase will be this number of radians. And the same thing happens with the people. Yes, I can guess that this crowd is obstructing the propagation of this ray when it goes through Conchi, and then is not crossing Conchi, but is attenuated by her. And that can be modeled. But what I cannot model is how much scattering is Conchi, is Conchi creating. So how much channel is Conchi adding to? Well, maybe it's the models that you have seen here for the human targets. But everything is quite random and enough random to be, I mean,
confident enough.
Not practically implemented in 100% deterministic thing. Okay?
Thank you.
Yes. There is always something stochastic that we have to add on top of that. Yes? Okay. Thank you very much. No tengo a Jessica. Tengo a Jessica. Okay, so thank you very much again. So now we have invited Jessica Carneiro from Australo. Australo is an SME company. I'm pretending to introduce you, and if I'm doing any kind of mistake, please correct me. Jessica has 8 years of experience working in European policy and projects. So we are not talking now about the algebra of the channels. We are talking about the policies of the European Union, and more than that, which is the role that the SMEs, the small enterprises, play into this European ecosystem. She has expertise in, as mentioned, in this policy analysis and project management in a range of fields, including, of course, research, innovation, and industrial policy, with more than 15 projects completed. And she has been involved in the SNS joint undertaking, yes, because you're the co-chair of the SMEs working group, right? Okay, so it's a very interesting person for you if you pretend to be in the next edition of the SNS calls. So track her. Since February, he's, as mentioned, chair of the Network Europe SME working group, which has more than 200 members in the communication sector. So, Jessica, here's your floor. Thank you very much.
Gracias. Good afternoon. So thank you very much, Narcis, for the kind presentation. My name is Jessica Carneiro, and Narcis just said I am a project manager in Australo, which is a small marketing agency dedicated to exploit the results in deep science projects. And I am also, since 2023, the chair of the SME working group. Oh, OK, I can use this one. So I was invited today to talk about the roles of SMEs in shaping 6G, SNS, beyond 5G technologies, and how this is happening from the point of view of the SMEs, but also from a political point of view. So we will have a very short introduction. Then we will speak about the value that the SMEs bring to the ecosystem. I will show you an overview of actual activities and the actual impact in figures about the contributions of the SME to the development and deployment of 5G and 6G. And then we will particularly speak a little bit about the SMEs in the SNS joint undertaking. So without further ado, first thing I always say when I start this presentation is that SMEs constitute 99% of the whole European industry. That means that just by sheer numbers, SMEs are really important players when we are talking about anything. In this case, communication technologies. On top of that, they are one of the cornerstones of the 6G development. They are driving advancements in numerous areas, and they are actively contributing to the objectives of the European Union in this regard. So SMEs are often a little bit forgotten. So everybody knows about the big players in the industry, about the renowned world-leading institutions that are super good in research. Even startups, sometimes they are shown as stories of success and so on. But sometimes SMEs are a little bit forgotten. So in general, how do they contribute to the ecosystem? We have here 5 points that then we will see applied to the particular case of 6G. So SMEs are agile and flexible. This means that they are quick and responsive to the changes and the circumstances in the context, to the changes or transformations, and to the new developments. They do not have such, let's say, complex processes, such as in large enterprises, and they are not so tied to research, such as the university, so they are always able to adapt to the circumstances, which makes them a very valuable player in some phases, such as the testing and validation. They are also experts in very niche areas. So often, there are some areas that are overlooked, either because maybe they are not so, they do not have such a high economic potential. Maybe it's just the investment, it's not worth the effort. Maybe it's just like not interesting or not unlocked yet. So many SMEs are exploiting these niches to actually come up with new business ideas and new technologies, solutions, and services. They always are, because they need to be very competitive. At the end of the day, they are competing with the European fabric of SMEs. So they are competing with their peers. So they are always tend to be very innovative and very updated in what's happening in the landscape of 6G. And another thing that I like to highlight is the community impact of SMEs. So they are really embedded in their local ecosystem. They speak to people one-on-one. They know what's going on in the region, in the town, and so on. And this makes them the first ones, for example, that you have to think of when thinking about user acceptance, adoption of technology. They have the key to those things thanks to their close relationships with the people, the citizens, but also the policymakers, and so on. So they have a lot of potential to mobilize the opinion of the public. And of course, entrepreneurial spirit. They are always thinking about what to do next. When we apply all of these, all these 5 characteristics, or all these 5 key potentials to the specific 6G ecosystem, we have the contributions, the measurable contributions of SMEs to research and innovation. As I said, they are at the forefront of development of 6G technologies, both as part of the provisioning ecosystem, so they are contributing to develop the infrastructure, the services, the hardware, software systems, and so on, but also they are users of 6G. So they constitute a big part of the verticals. There are SMEs in healthcare, in industry, public disaster relief, anything you can think about, there are SMEs there. They are also, or tend to show very cooperative spirit. So they are key to kind of act as a revulsive of the landscape to try to move forward and push against boundaries and integrate the technology quickly into their everyday business. The second, I spoke before about the niche knowledges. So of course, they are very keen to develop specialized solutions. One SME has to count on their portfolio and on the competitive advantage that their services have to survive. So therefore, they are always looking to find those solutions or those opportunities or those challenges that need to be addressed to try to get and exploit them and arrive there before some others do. Of course, even though in my experience, SMEs are not greatly involved in standards, they have a big role to play in terms of contributing to practical standards. So SMEs, they cannot be waiting for years and years for something to be approved. They need to be pragmatic. They need to work. They need things that work in their own timelines. So they have this possibility, this ability to push for practical standards that ensure interoperability. And as well as they are present across many different industries, they can also make sure that these standards are not really, really specific, but that they tend to, not one solution fits all, of course, but that they tend to have a bit of a wider scope when they are implemented. And finally, the impact. So this goes back to what I said about the involvement with the community. The SMEs have a clear socioeconomic and environmental impact. So just two examples, the job creation and both the development of environmentally friendly solutions, but also the use of those solutions in their activities. This is something that I am sure most of you are aware of this, that it's becoming increasingly important in the development of technologies to take into consideration social, economic, and environmental aspects. Actually, I'm sure that those of you who are involved in research projects, you have heard and you are dealing with the key value indicators, and this goes a little bit back to that. As I said, the user acceptance for technologies such as 6G, well, we all heard the rumors about 5G, cancer, COVID, and so on. So SMEs are really entities that the citizens trust because they tend to be places from where they purchase, they tend to be places, they tend to be run by people they know, and so on. So they have really a great power to really push the user acceptance, to show people what this technology is about, what is 6G, yeah, I sit in my phone, I see I have sometimes 3G, sometimes 4G. When I'm very lucky, I have 5G. But what's behind that? So especially in these time of disinformation, misinformation, pushback to science, and so on, they can really engage with the everyday citizens and help them to get involved into the technologies. And this is also important to bear in mind because, of course, the developments are so quick that we sometimes face the risk of leaving people behind. So yeah, we develop and reach new heights, but you as a regular person, how does it impact you? How does it affect you? Do you know what you are using when you, I don't know, you use ChatGPT or this sort of dilemmas when you have to explain to your grandma or your grandpa how to use the app in the bank. So these are everyday situations where SMEs really have high responsibility and also a high power for change. And then, of course, we have also the ethical and responsible technology. As I was just saying, it's not only developing technology, it's also doing it in a way that it's ethical, that it's responsible, that it safeguards the values, the European values, but also the people values, and to not just do things just because we can do them, but do things thinking about how we are going to use them. Now, I am going to guide you through the SMEs in the European 6G ecosystem. So this is very ambitious, and my heading is a lie. I'm actually just going to show you three main hubs, three main stakeholders of the ecosystem where SMEs are playing a fundamental role. The first one is Network Europe. Network Europe, for those of you that are not familiar, is the European technology platform for the telecommunication sectors. It has been active for more than 20 years now. 6G IA is the industry association, and then finally we have the Smart Networks and Services joint undertaking. So Network Europe, what it is? It's a non-profit organization. It has the largest community of SMEs in the telecommunications sector in Europe. But it actually goes beyond Europe, and there are also SMEs from countries such as the States, Israel, Turkey, South Africa, and so on. The Network Europe has a specific working group focused and dedicated to SMEs. This working group has a mandate that encompasses 5 points. So one is to provide support to SMEs. It's a little bit like secretarial support to them. So they can have meetings, they can foster collaboration, they can discuss hot topics for them. Boost their visibility. As I was saying at the beginning of the presentation, SMEs are not always very good at selling themselves. So what we try to do is to help them to be out there, to be known, to be taken into consideration. We also advocate for their interests, which sometimes are the same than other players, and sometimes they are slightly different. And SMEs, they have their specific challenges, their specific goals, so we try to push those forward. We also represent SMEs in the sector. For example, I'm here today. And we monitor their participation in SNSJU. 6GIA, so it's the industry association. It's the private, it represents the private side of the JU. The joint undertaking have a public side, which is the European Commission and the member states, and then a private side. So that's the industry association. And it encompasses every type of stakeholder. They have SMEs. At the moment, there are 88 SMEs. Compared with Network Europe, it's quite a low number, but it's growing every day. And both 6GIA and Network Europe, they have SMEs in their governing boards, which is very relevant for when we are speaking about making decisions. So here you can just see a very short comparative. Even though I presented this as two separate organizations, they work very close. And the best example to show you how close they work is that Network Europe is in charge, is responsible to elaborate the strategic research and innovation agenda for the telecommunications sector. This agenda, this SRIA, is then taken by SNSJU and 6GIA to elaborate the working programs for SNSJU. So Network Europe just published the new SRIA in last December, and based on that, they are creating now the work programs for that will impact the next call. So for those of you that are involved here and you are waiting for the next call of SNS to be launched, just have a look. And while Network Europe is more research-based, 6GIA, of course, is more industry-based. And both of them have different working groups. So I highlighted the SME working group. In Network Europe, you can see 6GIA, they have the vision, so somehow they established the roadmap for the next years, standardization, spectrum, security, and also very important, women in technology and research. So the SNSJU, I guess most of you are familiar with it. But so it's the initiative that was, well, it's the legacy of 5G PPP. And the initiative, of course, is trying to push the deployment of 5G and the development of 6G. So it has two main missions, the sovereignty and the deployment that I just mentioned. Just as you know, just very recently in some countries, they decide to spill the beans in Signal about certain things happening in the world. So I think that the fact that we focus in having our technology sovereignty in Europe is becoming increasingly pressing. And then, on top of that, SNS also has specific working groups. So what about the SMEs in the SNSJU? So far, there have been 3 calls. In 2022, they awarded 35 projects. And in those, 88 SMEs were involved. In the next year, in 20 projects, there were 75 SMEs. And in the last year, for 16 projects, there were 55 SMEs. But this is very important. Of course, we cannot establish a very good comparison due to the different number of projects. But the SNSJU issued the recommendation that per every call, SMEs should represent 20% of the budget awarded in projects. And as you can see, the percentages here, the first year, we fell a little bit short to that 20%. Then, in 2023, we increased it to 27%, which was a lot. And on last year, it just decreased a little bit to be in 26%. So this objective is being reached out, and the trend shows very positive results. Here you can see the number of SMEs in SNS calls. So Spanish SMEs accounted for 11% of the total SMEs. Spain is one of the countries that is more active in the SNS. This is great, but this is also a challenge. It's great because, of course, we want to be there. We want our SMEs to be there, to partake in the development, to be exposed to the new topics, to be in the just latest research. But it also means that for those new SMEs that need to enter, it's a little bit challenging because it's very competitive. The only country that surpasses Spain is Greece, that you can see there. They always have the highest number of SMEs. Of course, in terms of projects, you will see that it follows a pattern. The more SMEs, the more projects, the more SMEs, and of course, the more fundings. And this is very interesting because, as I said before, Spanish SMEs represented 11%, and they accounted for almost 13% of the total budget. So we are quite good at securing funding. There are some countries that are a little bit better, such as Belgium and so on, but in general, we are great. So the overview of the participation. A total of 30 countries participated with SMEs. Southern Europe is by far the most active one. Greece is leading in SMEs, projects, and funds, and Spain ranks second, there with our neighbor France. And of course, I have to say that one thing that needs to be addressed is the current concentration of projects and funds in a few SMEs, not just per country, but per SME. There are some SMEs that they have, like, for example, 7 projects in one call, which means that it's quite a lot. Of course, there is this opportunity of the cascade funding. So there are some SNS projects with open calls. And this is kind of a low-hanging fruit for SMEs because these calls tend to target SMEs. So they are looking for them. And they tend to focus in the early testing and validation of technologies, which is very something of interest for SMEs. OK, I just need to rush. So I was going to say, like, some benefits. You get funding and resources, expertise and experience, collaboration and networking, and challenges, joining consortia, the proposal contribution, the financial and resource constraints, and the project implementation. So just to finalize some advice, be strategic. You need to know what are your strengths before you try to apply for projects and get involved in research and innovation. Keep the balance. You also need to think about in which kind of projects you are willing to participate, if you have the capabilities, and if they serve some purpose in your company. Build your brand. Be proactive and be involved. And just to finalize this question, so what? I don't like to draw conclusions in this type of presentations because I think the public just takes home whatever they feel that it was said, but I just wanted to highlight that for you to keep in mind the value of SMEs, that if you are a university, a research institution, or a large enterprise, keep them in mind when you are working in your technology with all the benefits that they are bringing. And I encourage you to participate in the SME working group in Network Europe, as well as the next SNS JU call. We have a brochure here that you can download with all the SMEs. And thank you very much. Sorry for...
Thank you, Jessica. Very interesting, despite of the time of the afternoon that we are. Any quick question from the audience? Yes, German? Just one question. Then Jessica stays with us for the rest of the day.
Yeah,
She's here
feel
tomorrow,
free
so in case
to come and talk to me.
you can talk to
Jessica,
her.
thank you very much for your presentation. Just one quick question. Indeed, the results of small companies are often unknown and not that famous as what big companies are doing. But can you please name maybe 2, 3, from your point of view, most remarkable products, projects, results which were released in past couple of years from small companies?
So that's a very interesting question, and by heart, I don't know so many. But for example, I know I have one success story of an SME that deployed a series of points to provide Wi-Fi access in a music festival with thousands of people, so that everybody could access some web page in the festival with some services, like if you need to call emergencies or something. But just if you need access, you can have that. There is another one that provided some solution for the ferries crossing the North Sea, as well to ensure that they have reliable connectivity outside. So I can definitely gather a few examples and maybe add them in my slides for those of you who would be interested. And in any case, in the brochure, we have some success stories where you get a lot of examples of successful developments, technologies, and solutions that have been applied over the past years. Thanks a lot.
Thank you very much.
Thank you very much.
Gracias.
Gracias. So it's my pleasure to announce the last, but of course not the least speaker of the day, Professor Jose Cammani. Remember, dear survivors of the day, that after this talk we have a farewell drink and tapa out there, so we can celebrate that the day has been so sunny and so productive. Jose Cammani is full professor in our university. He was the founder of the iTeam Research Institute, and who was the director of the iTeam during 12 years before me. And Doctor is correct. If you see the name on the screen, is Doctor because he's a doctor in physics and in electrical engineering. So he has a double doctorate degree. He's also fellow of the Optical Society of America and of the IEEE. And he has double prizes. So he has been awarded with the two most recognized or distinctions, high distinctions in Spain, the National Research Award in Engineering and the King James I Prize. He has also he's also doubling the number of ERCs that he has been granted for, and the proof of concepts, and he has been the founder and the entrepreneur launching these startup companies or deep tech companies, VLC Photonics, Ipronics, and some other things that maybe he can tell you. How much time do we have for your biography? We don't have that much time, so just we can receive Jose. Are you ready? So the floor is yours, Jose. Thank you very much.
Thank you. Thanks a lot. So, good evening, good afternoon. Thank you. I want to thank the organizers for inviting me. And you know that one of the most important things when you speak in public is to control the time, okay? And today is even more important because after me comes the beers. So I have to have a strict discipline, okay? So let me tell you what I'm going to speak today is, well, we are in an event where we are speaking about 5G, where we are speaking about long-standing collaborations, where we have the UPV iTeam, we have Huawei. And I thought, why not speaking about the work that we have been carrying in collaboration between UPV and Huawei in the context of photonics? I thought that was a quite exciting topic to talk about, and in fact, this is the first time I'm going to do it. And therefore, first thing I want to do is to thank my coworkers in this activity. I think it's fair to mention them here. So actually, thanks to all of them. Also, thanks to the teams in Huawei that have been very supportive. So, well, let me first of all try to give you like an appetizer, okay? Why photonics? Why do we need photonics for 5G or for mobile communications? Well, I think that photonics is quite a broadband enabling technology, key enabling technology. This has been recognized in many areas of the world, and quite recently by the European Union. It's one of the established key enabling technologies. And photonics brings two very good things. It's compatible with electronics, with semiconductor technology, and also it's very complementary. So it can help to reach things that probably traditional electronics or radio frequency engineering fell short. So that's one thing. And the other thing is that photonics also is well known for providing huge bandwidth and also low power consumption. So I think it was this morning David mentioned that one of the issues with 5G is what perhaps was overly ambitious. And I think that one of the reasons behind that is that there was not the required hardware to carry the whole vision. Okay, so when you have all these ambitious goals, hardware is very important until it works. When it works, then software and applications take control, and hardware almost becomes a commodity. Okay, but we're not yet on that part, and we haven't reached that level. And I think that one of the things that photonics can do is to provide a technology that can support this migration and also open the possibilities to design and to integrate systems with a more simplified hardware. All right? So this is my mission, to try to convince you today about this. And the frontier area of research that deals with that is what we call microwave photonics. And this is what I'm going to talk today, and also because this is the framework of the collaboration between us and Huawei. So, OK, so if I'm going to speak about microwave photonics, I would better introduce it, what it's all about, and a little bit of the main concepts, just a very short overview. And I will go specifically to the implementation, the alternative that is most interesting, that is to implement microwave photonic systems in integrated chips. That's what we do at UPV. All right? We'll try also to give us some basic introduction. And then I would like to spend some time in describing what are the best results, the most exciting results that have come from the joint collaboration of UPV and Huawei. As a disclaimer, I have to say that probably if you compare with 5G fully-fledged products, what you're going to see here is mainly circuits, prototypes, etc. So, because one thing is to develop the concepts, to do the first demonstrators, the first prototypes, and another completely different thing is to do the product development, okay? But if there is no proof of concept, there is no way to do then a product development. Okay, so first of all, what is microwave photonics? Well, it's an area of knowledge that brings together the worlds of radio frequency, microwaves, and photonics. And why is this important? This is important because in the mobile network, we have an intermediate point where we interface both segments. We interface the wireless and let's say, the fiber segments from the base stations to the central offices. And that point is very critical, and that point is where you have to interface both worlds, and you need a solution that can seamlessly accommodate both. So this is what microwave photonic targets. And I have to say that this is a technology that came, first of all, for defense applications many years ago. I'm talking about 30 years ago. Right now, with the development of mobile communications, IoT, etc., where you have to interface these two worlds, then it's becoming more and more important. And I wrote down a little bit of applications that can be mainly popular and understood by all. I think that David mentioned this morning, for example, sensing, imaging, and of course, communications, right? So let me try to explain you in a nutshell, in 2 minutes, how a microwave photonic works. Right, so I'm going to be a little bit technical right now. Huh? When you have an RF or microwave system, you get signals maybe from an antenna, from an array of antennas, or from an equipment. And basically, what you want to do is you have a signal, some information content, and what you want to do is to process it, filter it, delay it, dephase it, or whatever. And you use these funny devices from RF frequency. And depending on the band where you are working, you use one technology or the other. There's no really big broadband technology. And well, afterwards, when you have done all the processing, then you go with your signal to the next antenna, maybe to the next equipment or whatever. Right, so it happens that most of these elements in radio frequency or in microwave technologies or even in millimeter waves are quite bulky. They are difficult to reconfigure and difficult to tune, okay? And like I said before, they are matched to several bands. And that's probably one of the reasons why it's so hard to make a very broadband base station or equipment, because you have to interface many different radio technologies. Now, with microwave photonics, that's the traditional system operation. With microwave photonics, what we try to do is something that apparently is more complicated. We have to pay a price for everything, but it has some gains. The idea is to get rid of this intermediate stuff and use my signal to modulate an optical link. If I have a sufficiently linear transmitter, then I can up-convert my signal to the optical domain. And in the optical domain, I have the possibility of doing broadband, flexible, low power, and interference immune signal processing, which when I have finished, I can actually down-convert, okay, in a photodetector, and then prepare my signal to be re-radiated or detected, okay? And the nice thing about this is that I can control photonics very well. Photonics is very broadband, so it has hundreds of gigahertz of bandwidth. I can control my chips, and with a simple design or a unique design, I can do different functionalities and provide in the optical domain the means to do the signal processing tasks that I want. OK, so that's more or less the concept. Right, what are the functionalities that we can do in microwave photonics that are required in commercial systems? Well, there are a lot. Signal filtering, you have pure transmission, tunable delay lines, phase shifting, arbitrary wave generation, beamforming. Most of them can actually be performed by microwave photonic systems today, okay? Or have been demonstrated, and with a considerable bandwidth. And part of the work that I'm going to describe today is going to show the big potential that this technology has, especially for providing operation in very extended bandwidths. And when I'm speaking about extended bandwidth, I'm meaning from, let's say, 1, 2 gigahertz to more than 50, 100, etc., with the same photonic chip. OK, so applications I mentioned before, Internet, IoT, more and more they are becoming more civil-oriented applications, right? So the question is, how can I make these systems very compact? I can make the systems very compact if I resort to chips, if I can actually put all my system that I showed before in a chip. That would be the ideal solution, which is nowadays not yet completed, not yet fulfilled that dream, but we have, in fact, or indeed, been able to integrate many functionalities on a chip scale, right? And what actually deals with this challenge is what we call integrated microwave photonics. It's like I said before, trying to put all our system in a chip, the sources, the modulators, the filters, etc. And actually, in the last, I would say, 10 to 15 years, there's been a lot of advances in this area. And right now, we are able to put on chip different devices, different systems, both for application-specific functionalities or even for general-purpose applications. OK? So, all right. So my integrated microwave photonics, actually, the target is to implement complex circuits that are able to carry complex RF signal processing functions. And the idea is that we want to leverage the bandwidth of photonics, the low loss, and the power efficiency. If we can make those systems reconfigurable, then that's fulfilling the complete objective. OK? And optics is quite good for that, as I'm going to show you. So in this context, where we have been working with Huawei for, I would say, more than 5 years right now, OK? And I'm very happy today to show some results, selected results, which I think that will convince you that there is definitely, this is a definitely good avenue for research, because the results are indeed very promising. So when I had to decide what to select, I put my eyes on 4 areas: programmable filters, beamformers, MIMO signal processors, and multipurpose processors. I think that especially MIMO and silicon beamformers are technologies that have, or that can be very promising for future evolutions of the systems. And I think that this morning some speakers addressed this question. So let me first of all try to describe some of the work we have done in programmable filters. Now, with programmable filters, actually, there should be another. Sorry, maybe I missed. Oh, I lost one view graph. It's OK, no problem. Why do we want programmable filters? We want programmable filters for 2 things: to suppress noise, like in any kind of communication system, OK, and also to be able to produce special modulation formats that are required in radio frequency systems. OK, so with that aim in mind, we actually have been working in designing photonic filters that can fulfill these targets. When I'm talking about microwave filters, microwave photonic filters, and tunable operation, I'm referring to the fact of having structures where you can tune the central frequency many gigahertz by many tens of gigahertz, but also that you can select the bandwidth of the filter. And all this by electronic means using the same structure. Okay? So let me try to address, I'm going to show you one of the salient results that we achieved with Huawei. This is like a very simple photonic filter where we have a modulator here on your left-hand side part. This modulator has an optical input, which is continuous wave, and all the information, the radio frequency that you want to process, is modulated in that area. It's impressed into the light wave. And then we have the tunable filter that can be, which we actually implement in silicon. Okay, and okay, this is the view graph that I was missing. Okay, but anyway, the filter structure is usually made of waveguide. That reminds very much of microwaves, but it's optical. Okay, so it's not digital signal processing; it's analog processing, and what we do is manage interference by setting phases and amplitudes in different paths of the filter. We are able basically to synthesize any kind of transfer function that we need. Okay, so these are the targets, and I come back to the filter structure which we have developed in cooperation with Huawei. So actually, this structure that you see here is quite a powerful one. It's a fourth-order ring-assistant Mach-Zehnder interferometer, which is able to provide filtering capabilities from almost 0 to 55 or 60 gigahertz. So we can move the central frequency. We can also shrink or expand the bandwidth. It's very low power consumption because to manipulate each of these phase shifters, we need on average 1.3 milliwatts. So it's very small. And what we have done also in the context of this collaboration is to have design these filters in a way that they don't need external supervision. We get the signals, we get some feedback, we get information, we train the filters, and there's an electronic control system and an algorithm that takes care of self-monitoring and guarantee that the filter is operating at all times. So, yeah, you see here, there's a nice picture of the filter, where you can see the different modulators here, some different parts. You can also have an idea of what are the dimensions of the chip we work with. So in this case, it's a quite long chip. It's almost 1 centimeter in this dimension, but only 2.8 millimeter in the other. Okay, and usually when we fabricate this, which is in silicon, actually when we want to operate the filter and measure it, we need to package it like any photonic chip. So here at the right-hand side, you have a nice picture taken of one of our setups, where you can see actually, that's interesting to see, where you can see the parts that we have, the fiber, the RF connectors, the electronic controlling system, fiber array coming in and out of the chip, and actually the photonic chip is there, is that black part. So it's a very small one if you compare with the rest of the package. Okay, that's something that is useful to show on a picture, because people otherwise don't get an order of magnitude of what is the photonics in terms of the electronics part. Okay, so one of the nice things, like I said before, is that you can reconfigure. Once I have the structure, I can send electronic signals, I can enable parts, I can disable another, so I can change my filters, I can change my shapes, and I can calibrate them, store the calibration information. So actually, this is kind of calibration, the different phase shifters, information that the system needs in order to be able to self-adjust itself. So this is very important. It's something you do only once. Once you do it, then your filter will work with that information. So I want just you to pay attention to the upper part. So actually, this is how the system is configuring itself to implement different transfer functions. This is measured results, so this is not a simulation. And I have some examples there where I can show you different transfer functions of different families. Everything is done with the same structure, so no need to change the hardware. Chebyshev filters, Butterworth filters, elliptic filters. You can tune your central frequency, 5 gigahertz, so it's close to 5G, 6 gigahertz, 7 gigahertz. You can go higher, 10, 30, 40. And you can see also in those pictures that the bandwidth of the filter can also be shrinked. So if you need to filter super channels, then you can widen it. If you need to filter smaller content channels, then you can shrink your filter. I insist, it's always using the same structure. No need to change. So that can give you an idea of the power of a filter. Some description about the algorithms that we use. The technicalities are beyond maybe the scope of this talk, but we have been able to publish these results in nice journals in photonics. I have to say that we are very happy because all our collaborations with Huawei have always led to publications in top journals, as you will see later, and also patents. OK, the other application of filters is to be able, like I said, to produce special modulation formats. OK, actually, what we do here is to put it at the output of a modulator. And when you modulate the signal, you get the two sidebands, OK? But if you want to transmit your signal, let's say, from one central station to a base station, which is separated by several kilometers, and then you have optical fiber, then if you want to avoid dispersion, you have to suppress one of these bands, OK? And this is what we use, why we use this filter. And you can see here how the two bands that are provided by the modulator, when it's modulated in double sideband, one of these can be completely suppressed by using the filter, tuning it to where you want. Okay? And with that, you can, for example, achieve improvements in fairly complex communication system constellations. Okay? In this case, well, actually, as we go up in frequency, the dispersion increases your EVM. But if you are able to suppress one of the bands, your EVM, your worst case EVM, lowers down. These results are for a fairly low band. It's the typical band used in 5G. And this morning, it was mentioned that, well, what happened with millimeter wave? It's like, I think that David rightfully said that it was a little bit of fiasco. And I think he was right. There are many technical problems to be solved. One of them is dispersion. What happens if you extend, if you want to upgrade your frequency operation and go from, let's say, from 5, 6 gigahertz to 14, 28 or more? Then what you have is dispersion. And dispersion actually produces these nasty peaks here that increase your EVM, okay? So that makes almost impossible to do a error-free transmission if you want to use the traditional modulation. However, if you are able to suppress one of your bands, you can see here that we have these very flat curves where the EVM is actually completely controlled over a considerable high bandwidth. It's 40, we're talking about 40 gigahertz, okay? So I'm saying that from almost 0 to 40 gigahertz is almost, the EVM is reasonably well controlled, so, and we avoid the dispersion effects. Okay, so jumping into another topic, also an exciting topic. This morning, we've been introduced to the need that future 6G systems will have for beam steering, for multiple antenna elements, and the technology behind that is being forming. Maybe you already know that beamforming is absolutely essential if we want to have directed communications, or if we want to especially multiplex communications and address different users, okay? So actually, what we try to leverage with photonics here, apart from the issues that I said before, low loss, high bandwidth, etc., is the fact that with photonics we can provide reasonably high tunable true time delays. This is something you cannot do with traditional RF technology. And this is the reason why most of the beamformers that we use, that use RF technologies, are based on phase shifters. Now, maybe you are familiar, maybe not. Beamformers that are based on phase shifters suffer. They are inherently narrow band. They suffer from a phenomenon that is called beam squint. That means that if your beamformer is pointing to one direction and is designed to point in one direction for one frequency, then if you change your frequency and you go to another band, the angle changes. So that's a problem, okay? And you have some example here of a beamformer that is pointing at 10 gigahertz, for example, at 45 degrees, and if you go to 9 gigahertz, it goes to almost 50, and if you go to 11, it goes lower than 40, etc. That's what we call beam squint. We know how to combat beam squint. And the solution is to change phase shifters by true time delays. So the only thing that we have to do is to take the signal that we want to radiate, and we need to delay physically the different stages so we can synthesize a wavefront that is pointing in a given direction, okay? And the key to do that is to have different elements. One provides a basic delay, no delay. The other one provides a multiple, 2 delays, 4 delays, 6 delays, or even 1 delay, 2, 3, etc. And to do this, usually in photonics we have used fiber coils, okay, to provide that, which are very bulky, but at least the weight is much lower than if you use coaxials or whatever, and they are broadband. But this is not the solution we want to implement. Actually, what we want to do is try to develop a technology where you can provide the delays using optical waveguides. And you can put your optical waveguides in spirals, and within a chip, you can provide delays that correspond almost even to 1 meter of length, okay? And what we do is we use these blue elements here that are switches. So we can program our switches in such a way that, for example, one element provides one basic delay, the other element provides a multiple, 2, 3, 4, etc. But it turns out that if you use this scheme, the number of angles that you can address is very poor, it's very low. For example, if we use what we call a 5-bit delay line, that is, this is called, it uses five blue elements, and you use the typical 1/8 beamformer, then actually the number of angles that you can point is 9. That's very small. Okay, so the resolution in angular resolution is very poor. So to combat this, there was a solution proposed in the literature where the basic delay in each of these stages changes. And actually, you see that the basic delay in the upper stage is 1 unit. The basic delay in the second one is 2, 3, 4, etc. It turns out that, in principle, if you have an m-bit delay line, then you can point 2 to the m different angles. Now, if you have 5m equal 5, instead of pointing to 9 angles, then you can point to 32. That's much better. Okay, if you have 6, 64. So we have 64 different angles. However, when we started working on that, we wanted to make a silicon chip that could implement that. We realized that what we saw in the literature was working correctly for one frequency, but when we deviated slightly, we started to observe a curious phenomenon. All the pointings for the positive angles were correct, but for the negative didn't work. And the authors of that paper were not aware of that. So we thought about what was the problem about that, and we find out that contrary to what is the common knowledge and the common opinion, even if you use true time delay lines, you can have beam squint. This is beam squint, another kind of beam squint that had not been discovered since then. And actually, it can be compensated. Okay? I'm not going to give you the explanation, but what you need to do is to put a compensating stage before each one of your stages. Okay? You can design them carefully and achieve correct pointing of every angle over a very broad frequency range. So actually, this is one of the summary of the results, and you can see that we change when this is different frequencies of operation. Okay, we just show the 32 pointing angles, different ones for 14, 12, and 10 gigahertz, and you see that all the pointing angles are correct for every frequency. Okay, the radiation pattern changes a little bit with frequency, but also that's because the lobes are increased, but it is correctly pointed. Okay, so this is what we did with Huawei. We designed the chip. We included the optical precompensation, which is line or marked there in pink. Then there's the beamformer. We fabricated it in silicon photonics. We also packaged the chip, and we measured it. And we were actually able to verify that this solution works perfectly, and it provides perfect beam pointing direction for a bandwidth of 30 gigahertz. That's huge for a beamformer. Okay. Moreover, we extended the design, and we also designed and fabricated a chip that can go up to 50 gigahertz. So that you can do with photonics, and of course, because you are able to change with photonics your switches, you are able to change your pointing angle. Okay? So this is a summary of the results that were published in Nature Communications last year. It's a very nice paper. It shows what I believe are fantastic results. I mean, it's correct pointing of the different alternatives, so the different 32 curves you see in each small drawing there are a lot, and almost uniform during all the frequency span. Okay, well, that's the summary. All the different pointing angles correctly placed in different frequencies with different colors. Okay. Right. The good thing about this is that you can extend the chip, put more bits. If you have 7 bits instead of 5, you can reach 128 different pointing angles. That means that you have a resolution of less than 1 degree for most applications. And moreover, this configuration can be scaled. We fabricated a 1 times 8, but this can be extended to 1 times 16, 1 times 32, 64, etc. And also, in principle, it could be upgraded to 2D. And the gain in the number of angles that you can point. Right. So I'm actually close to, how much time do I have? Narcis? 5? No. Right. Another thing, another technology approach that has been mentioned this morning is MIMO. Okay, so we did a small project also in collaboration with Huawei, where we wanted to know if we were able to construct matrix processors in photonics that could compensate for the MIMO channel effects. And actually, the idea is to interface the signals that come from one MIMO system, get it into a matrix multiplier in photonics, and then compensate different effects. Okay? So actually, we did a lot of preliminary theoretical studies, and we decided to implement an architecture that is based on what we call an optical feed-forward mesh architecture. And we did some other complementary studies. Let me try to explain you how this works. Don't have much time, so I will be fast. Once you have your MIMO channel, you have the signals from different antennas. And if you're able to up-convert them to photonics, then you can feed them into a chip. And the chip will try to counter effect or trying to implement the inverse matrix of the channel that you want to address. And this is fairly simple in photonics, because we can do any kind of matrix, programmable matrix, by using phase shifters and small interferometers. And that's the core of the chip. Actually, there are 3 parts here. The first one is the modulator that we use to convert the radio frequency to optics. The second is some small filters to get rid of noise and prepare the signal to be processed. And then afterwards, we have the matrix multiplication. The matrix multiplication, the coefficients of the matrix are performed by this basic control unit that we see here. It's a small interferometer. It works on the complex domain. It provides modulus and phase. So it's very powerful. It can implement any complex valued matrix. And that's very, very powerful. So actually, with that, you can, either because you already know, or either because you can learn from and use an AI algorithm, you can able to program the matrix coefficients that will counter-effect your channel. And then actually, hopefully afterwards, either you reinsert the signal or you detect them. So this is more or less one of the designs that we produce. It's a simple one. It's not very powerful. It's like for 4 inputs, but it can be scaled up. Okay. And you see the GDS, the silicon chip, and also, again, you see the package device where you have the 4 RF input and the 4 RF outputs. OK, finally, and with that I will finish, is a multipurpose signal processor. When we talk about multipurpose signal processor, what we are trying to say is, can we design something, a system, where I can not only change the frequency, not only change the bandwidth, but can I change the functionality that it makes? Can I make it operate as a filter sometime and then usually reconfigure the system and operate this as a beamformer, or operate it as an arbitrary waveform generator, or as a tunable true-time delay? Well, the answer is that yes, you can do it, and photonics can be explored to do this. And actually, what we worked with Huawei is to extend the chip that we use for the beamformer that I have explained before. Okay? You will remember that each stage had a different output. So we thought, OK, why not allowing the outputs to be independent or combine into a single output? And this you can program via the switches, the blue switches. You can either have parallel outputs or make all the outputs combined into a single one. When you do that, in the first option, what you can do is a beamformer. But when you do the second option, when you combine all the outputs, you can implement other functionalities like filtering or signal generation. Okay? And this is some of the most recent results. Again, the chip is there. The combiner is in the last stage. And we have demonstrated different functionalities, filtering at different bands, lattice filters, notch filters, arbitrary waveform generation. Let me explain that in 1 minute, because this is very exciting. If you feed the signal, the system with a pulse, then you can split the pulse into different stages and select the relative delays between the different pulses at the output. So this means not only the delays, but also the height of the pulses. So you can actually shape signals with different forms, like you see here. This is a kind of Gaussian signal. This is a kind of ramp. Okay, up ramp, lower ramp. You can synthesize many. And because you can control the delay between samples, okay, when these samples beat in the photodetector, they actually generate a signal that is radiated at a frequency that corresponds to the inverse of the time separation between pulses. So it turns out that this simple chip can generate signals that can radiate at different frequencies. But look at them, for example, 33, 50, 100 gigahertz in a single photonic chip. OK, so I don't want to take more of your time. This is a picture of part of the group. And we probably identify some familiar faces. Well, with that, I want to, first of all, thank Huawei for trusting us for collaborate with us, for providing very good ideas. And it's always very good for a university group to have the feedback from the industry, to know what are the real requirements, to know what are the challenges that they try to address. And of course, I want to thank the group, the collaborators, and my institute, and the university. So thank you very much.
Thank you very much, Jose. It's always a pleasure to listen to you, because this topic is really amazing. It's impressive. So I think we really think that this is the future of our core technology, yes, for the wireless world. Of course, questions? No questions? I cannot believe you. Yes, Yishin.
Please.
Okay. Thank you for a fantastic talk. Actually, when I saw you, you have many different works, and each work you may have a specific design of the chips. Maybe I was wrong, and please correct me. I'm not very familiar with this part. So one question is that can we have a kind of uniform signal processing method to deal with this for different tasks? I mean that one chipset can deal with multiple tasks. I saw you may have one example, but maybe for specific two tasks. For example, I don't know, we talk about AI, whether we can use photonics-based neural network to do this. Yeah, that's my question.
Thank you. Thank you.
Very good.
Very much. Well, we mentioned one of the... There are so many avenues that you can explore right now that are so important, that are so exciting. And of course, the possibility of using a chip to implement a small neural network. It doesn't have to even to be a traditional one, traditional architecture. It can even be a random neural network, so it can learn parameters and then refine the rest of the chip. That's a possibility. That's an open possibility. And I think that this morning, if I am not mistaken, I've heard from David that this is quite trendy to have the base stations implementing their own IA, so they can sense their environment and then communicate to the others. So when another base station needs to make a decision, there's the knowledge of what is the state of the rest of the network.
Yep.
That reminded me a little bit of when you study how internet works, no? And you see how routers work. And routers are constantly getting information from the rest of the network, although in a much more raw way. It's digital and it's not so elegant, okay? So that's one of the things that could actually be included in these systems to improve the performance. And that's a very exciting area of research, indeed.
Okay, thank you. Any other question? Okay. Nothing else?
Beers?
Yes. Thank you very much, Jose.
Thank you.
Thank you very much. It's an amazing day. You have, as mentioned, a drink. Jose is also staying with us in case you want to chat with him. Tomorrow we have a very impressive program as well, with discussions about smart cities and non-terrestrial networks, so also these hot topics, and how our technologies can serve these two scenarios. So let's have a drink together, and please come back tomorrow at 9. Okay, thank you very much.